Hi, 1 2 1. Yes, yes, yes. Hi, 1 2. Testing 1 2. Testing 1 2. Testing audio stream 1 2.
Enjoyed the NDC London conference so far? Yeah, good stuff. All right. Let's hopefully add something to that as well. All right, we're good to go. Welcome on this early morning. I hope you all had your coffee or drinks to get you up and running. You're here for a session on instrumentation in .NET and Azure for cloud applications. My name is Alex Tisse. I'm from the Netherlands, and I work at a company called Xspirit, and we help customers move to the cloud in general. And the step to the cloud is quite a big step. And the instrumentation part is something that is often forgotten. So with that, we really believe that if you have a DevOps mindset, that it should be all about the stuff that you build and you want to operate and run in production, that there should be some feedback loop. So you should be able to observe your systems. And this is from the Microsoft documentation. They have a monitoring checklist for if you want to do DevOps. I've highlighted 3 of the 4 that are there, make your systems observable. And then there's things with logs and metrics. And that's the main focus of today. We'll briefly touch on alerts and notifications. But the first 2 are like the big thing and the theme for this session. Now, okay, let's say that you're the DevOps engineer. And with that, I don't mean the people that build the pipelines, but the people, like the shirt says, we build it and we run it, we love it, we own the thing. And that's why we want to see what is happening when we're building things. So, just imagine on an average day, you pick up items from the backlog and you start working on it. You develop a new feature or something. And that's where you have your inner loop, a fast loop that gives you, isolated development and testing and a quick way of going back, that if things don't work, you can fix them. But once you're happy and satisfied, whichever branching strategy it is that you use, you probably commit your changes, put it in the code repository, you'll run on the tests from your CI/CD pipelines, and then finally you put it out into your environment, so you start hosting it. And you might have multiple environments, but eventually will end up in production. And what I see a lot, and maybe you recognize this, is that production is just like, it's there, but we don't really know what it's doing. So whenever the customers call, your website is down or it's behaving weirdly, that's where you're like, ooh, I would have wanted to know that or at least see what is going on. So the observability of your system is a big thing because if you can see what is happening in your environments, then there's a very rich second feedback loop that is, I think, essential for DevOps. So that's where you see how your application is behaving, how it's doing, and you get a lot of feedback from that. It might just be the errors, the things that go wrong, but it could also be usage. Which new features are being used and how are they being used. So very valuable. You need to gather that instrumentation data, like your panel with all the lights and numbers that tell you how things are going. And if you monitor those, that's where you get your outer loop. And that's where you can see what is happening there, change things accordingly through the inner loop, and make new items on your backlog if needs be, to adjust accordingly with the things you found out from production. And it might just be that performance degraded because you had a new search routine or algorithm, and it turns out that it's not that behaving that as well, but as well as you would have thought. CPU usage might have gone dramatically up. So, but at least if you have this happy developer, loving the DevOps stuff. And the reason that this is important is that especially if you go to cloud, you build your application in a much more distributed way. And that means that there's many moving parts and they interact with each other. And if things go bad, it might just escalate. That's one side of the story. But it also means that you're dependent on other resources, other moving elements in your solution. And seeing how things work and where things are going or where there might be bottlenecks or things stopping or outages or whatever, that's where you need you need something to help you tackle that complexity of your application and getting some insights there. The area is called application performance monitoring, but it's not performance in the sense of how fast is this. It's more about how well is it doing. So it could be speed, could be resource usage, like memory, the CPU, but also outbound connections and things like that, and the things that we put in there ourselves. Now, to help you out, there's a whole variety of APM, the application performance monitoring tools. You can choose whichever one fits best, or you might already be using. Today we'll focus on Azure Monitor because that's what the session is about. It's about doing this in Azure with all the tools integrated into Azure. All right, so let's zoom in on that just a little bit, because if you build a Azure-based application, preferably in .NET, but that's not really necessary, then Azure Monitor is the place where you want to observe and see all things. And it's comprised of two parts, the Azure Monitor logs and the metrics. The logs is where log analytics and the workspaces live, and the monitor for the metrics is where you can get insights. This is visible in multiple places, but you won't really see them as such. So it's there if you, for example, do a log analytics workspace with application insights. And we'll get to that later on. Now, the good thing is if you have a homogeneous environment with a lot of Azure elements in there, is that you'll get a lot of things from Azure for free, because it also outputs all the information to this location as well, to these resources. So for example, your Azure Active Directory, any interaction there, audit stuff, will be logged there. So you can find all the interactions with Azure AD there. Whatever happens inside of your Azure subscriptions, the activities, creation of resources, who does what, is also put into that logs. So you'll get those. And then with your Azure resources, combining resource groups, you'll get a lot of diagnostics as well. Most of the resources allow you to specify a log analytics workspace, which then uses the same thing, the same bucket to put everything together. So that's where you start getting more and more application specific. But as developers, like I think most of you are, the cloud applications that we build, they could be based on .NET Core with NuGet packages and some telemetry libraries that you'll be using, allows you to send more than just the other stuff. Most of that stuff is what I like to consider control plane based, so it's the interaction with and the access to. The resources are also about the data and the stuff that is going on in there, so the applicational side of things. And your application obviously is much about what happens in my application, how many conversions did we get in the web shop, for example. Those could be really nice metrics. All right, so good thing is that if you take this entire stack, you've got everything covered in your application, from the underlying resources up into the actual logic that you're running. And you can combine it and you can see all the information together. Focus for today. All right, so how do you do this application instrumentation? So there's 4 parts to this. So there's logging, that's recording stuff. There's tracing, following stuff. The metrics, that's numbers. And there's the health, and how are we doing. So with those 4, that's 4 things that your application can do to provide richer instrumentation. Okay, with this, how do you get that from your application? Well, the logging, tracing, and metrics are being pushed out. So you need to collect them, and then you monitor them, obviously, like we saw before. But the health information in general, but not always, is being watched. So it's being pulled from a health endpoint. And that's like, how is the application doing? Or are you ready to receive traffic, for example? Now this is how you can do things in the basis. There are ways for your health, for example, to push out metrics. So you can see statistics of the health information being pushed out as numbers. And you can interchange tracing and logging with one another, but that's where we get onto a slippery slope, because you should be very conscious of the distinction between logging and tracing. Once it's there, put it to good use, and there's a bunch of things that you can do with it. So just to give you an idea, obviously there's you can analyze things, see how it's going, time series, and then see the trends. There's alerting when say things go above or below certain thresholds or occurrence numbers. That's when you want to be notified. There's insights with dashboards. There's profiling if you really want to dig down in situations where things are not behaving as expected. And the metric streaming is, if it's high volumes of metrics, you can absorb that as well. I think this is maybe it's a bit of a crowded slide, so you can work your way through all the things that are mentioned there. But what I want to highlight here is that especially the first two columns are very important to keep apart. Things that you log are things that you might want to see a year down the line and still go back and see, okay, at this day, what happened with those 20 sales that we had. So important things that are worth recording for a longer time. It's sometimes used as trace information. We want to know in a production situation, why did this algorithm not behave correctly? Which things went in, the parameters or the arguments of a certain routine? And sometimes, you do the logging to find out what is going in and what is happening inside. So you sprinkle all of your code with all these log statements. And you might do, say log informational or something, so it's not that important. But it's not the tracing part. Tracing is about flow and things calling each other. So if you want to do that, then you should look into the area that is dedicated and intended for tracing. So my message here is don't misuse logging for tracing. And obviously it's a fuzzy area, so there's no strict rules there, but just be very conscious about it. Well, the metrics are about numbers, so that's quantitative things that you output and that you can measure and look at. The health we talked about, how are we doing, especially in, if you want to have alerts on availability, that's very useful, but it's also very useful if you're running a Kubernetes cluster, for example, because it can look at the health of your pods that are running and decide that it needs to recycle one of the pods if it's not indicating that it's healthy or maybe a degraded state. And the audit is something different as well. That's the things that you want to prove later on, usually security related, and it's not logging. So keep those distinct as well. All right, so I'll try to be brief in the first part of the logging because I think you've seen much of it, but just to summarize, so to speak, all the things that you can do with the built-in core FX libraries of .NET. So the flow that you have, if you want to log something, the gray area is your application. You'll use a NuGet package. It might be a different one. You might use Serilog or Nlog or something different. But the one that's built in is actually pretty good, I think. And that's your logging stuff that's coming out. It's a log message that you output. It has a certain category, and it has a level of severity. The logging framework, and then you have log providers, which sometimes confuses me. So what do you mean log provider? But it provides a place for the logs to be stored. And then you have the filters that allow you to tweak down the various information that is logged based on the severity or the destination. So you can be, have multiple providers listening in on the logs, and they might filter in a different way, each of them. There's a bunch of those that are provided out of the box. In the new, the lean startup that you also find with minimal web APIs, or if you do .NET 6 or 7 based applications, you'll see that the builder.logging is your go-to place where you configure everything and where you would register all the log providers that you would want to have. So that's all the adds that you do, add console, add debug. And this is how you can set it up and configure them, and that's pretty easy. Under the covers, what happens if you do those things is that there's a logger factory, and all the providers that you've added will be registered inside of the log factory. And the log factory will create the iLogger of T implementations. So iLogger is the thing that you can inject. Logger of T is what it actually is. And the T is the place where you want to use it. So usually the T is a type for your controller class, for example. Now, yeah, the things you do with the logger is you log things and you have all the severity levels nicely given to you. So it's from all the way from critical, you know, this is over, game over, to the trace and the information. I believe they're not in correct order of the significance, but debug and trace are the lowest ones in terms of very noisy. So things that happen inside of a loop that is iterated many times, probably if it would be significant, you know, then you would do trace or debug, so that you know that it doesn't surface in just regular logging, because that would just flood the log provider. The severity levels and the categories, you can see the real order at the right. The hierarchical structure of the categories is much like namespaces, and that allows you to be very specific. You know, if things come from this category, this is the level that I want to add to it. The string for the category with the separation and with dots is determined if you use the logger of T from the namespace and the class name or the type name. So you see that if you have a namespace with the web API controllers and you have a class leaderboard controller, that will be your thing. And you can choose at what level you want to, you know, specify what the severity level is and for which providers it's configured how. So filtering those log messages, like I said, if you use iLogger of T, it goes to multiple places, every log provider registered, but you would configure them probably in this way. So that's from your app settings JSON or any other means that you can influence the configuration system. You'll do a configuration of your providers with this information, and you can see that there's a default section that is just log level. And then you say, okay, for default, so if that's for everything, it's information. But if it comes from Microsoft, so Microsoft dot something, extensions, dependency injection, that would be warning. But if it's hosting lifetime, that's the startup of your ASP.NET Core application or your worker service, then we want information again as well. So a little bit more information to see what is happening. For each of the providers that are specific and different, you would add a new section that gives you, well, in this case, console. So that's with add console. You would log to that, and you can specify a different log level. Same section as above, but you can tweak the values in a different way. There's things with scopes that I'll skip on today, but you know, you can scope multiple log messages together because they belong together. And if you need to say include scopes. All right. We'll have a look at that with some things. All right. Let me see. There we go. All right. So what I have in this demo, and I'll show some stuff now, so we can later at the closer to the end we can have a look at how to collect all this information. It's a web API with a web app, and it kind of looks like this. Let me just start it again. So this is, by the way, the health check. So if it comes alive, we should see that this is going green again. And let's see if it's starting up. There we go. We'll get back to that. Let's see if we refresh this, that we have visuals. Yes, so this is the web API. What it does, it uses Entity Framework Core to retrieve some high scores, some seeded values. So if you try this out, and we ask for JSON, and we execute it, we'll get this bit of information here. That's the seeded data. If you go to the home page and refresh that, you'll see that this web application is retrieving the data and displaying it here. Health checks are okay now, so application is running. So how did we get to that? That would be here. Let's go to Program CS. So here we have the log providers. I've added the application insights, so remember this for later on. This means that we're sending out logs to application insights. We also add sec, and I'll explain that later on. And we have the simple console that outputs it there, which you can influence. How do you want to do it? Do you want to have the color behavior or just ignore that? So essentially, we have these two, but by using this thing here, the Create Builder, and I can show that in the web app as well, where I use the old type of startup, where we have the Create Default Builder. Now let me zoom in just a little bit. You see that let's try that again. There we go. So it says that the Logger factory is configured to do console, debug, and event source in this line here. So those are the ones you get for free. And if you don't want to have those, you could essentially, if you start configuring your log providers, you could start with a clear providers. So these are all the things that you could add, the sec, the simple console, systemd, trace. But clear providers allows you to start with a clean slate, and then you add the stuff that you only want to have. But usually for debugging, I'm showing here one strategy, that's the iLogger factory. If you have that injected, you can create your own logger, and you can create multiple ones. So you don't have to do multiple iLogger of T injections and keep them all together. Suboptimal maybe, but also if you want to control the category yourself, if you do a create logger without the generic, you can specify the category name yourself. So that's when you can tweak it to whatever it is that you like. And once that, you start logging. And what I've done here is, for demo purpose obviously, we're doing a log error, log warning, log information to see how these are logged individually and with the different severity levels. And we'll get back to these statements here and see what is happening. But if we go back to this, to here and run it just once more, then it's kind of hard to see because of all the things that are happening, but let's just stop this, go to the output, and then if we watch this just above the things here, let me see. It's kind of hard to figure out with all the noise that is there, but I believe it's there. Retrieving the score list with a limit of 10. That's the info, the warn, and a little bit above that, that's the fail for the error that we wrote. So we see those logs appearing down here in the debug window of Visual Studio. All right. Now, believe it or not, I used to study, or I have studied physics, technical physics in particular. So I had my fair share of quantum mechanics and quantum statistics. We learned that there's quantum state, and quantum state is kind of weird because, like a spin of a quark can be up or down, but it's actually both until you observe it. Before that, you don't know. You might have heard about Schrödinger's cat, the experiment, thought experiment. There's a cat that can, inside step on something, and then there's some poison, so it's a really weird experiment. But it might eat it or not, so it's either dead or alive. But if it's in the closed box and we don't know, it's half alive, half dead. So that's kind of weird. But as soon as you open the box, you observe, and then it forces you in one of the two quantum states. Okay, a little segue into how does this apply to messages and log messages. I like to think of it that there's the same duality. You know, it can be both. What do we mean? So first, logs are for us. You know, we want to read and see, okay, so we're retrieving something with a search limit of 10. That's very good that we can read it as humans. But for a machine, if you want to do, you know, the non-human side of things, it's kind of hard to look at that line, and you probably need regular expressions or say something to say, okay, these are the meaningful words and things, and the 10 there, that's actually what we want to have. So, you know, sometimes you want one, sometimes you want the other, and it's, you know, but it's when you observe it, you would want it to be either one. So, you know, and a lot of the logs that we write are just textual things, so just the line of with some string information. But we would like to have the other side as well, because we knew when we logged the message that we pushed in the limit, that was a significant number to us. So semantic logging or structured logging is what solved this problem. And you already saw this line just a moment ago. It seems, you know, like obvious. It's like, yeah, it's just you know, a formatted string there with some string interpolation. But if you look closely, this thing, the search limit, you know, it's not a zero. It doesn't match up by name, so it goes together in a positional way. But the left side of it is so the string with the curlies, that's the template that we have. The limit is the value, and they are kept in the one state. And if you want to have a string, it's put together, and then you get the string. So it's either regarding your observation. Now, not every log provider supports that. The ones that you know, are out there and used pretty often are SEC, which goes together with Serilog, but not necessarily. And you have application insights. Those are capable of storing that information, that rich information, and keep it separate and put it together if needed. So let's see that. So we already did this logging here, and just to show you that it has this template and this placeholder, and it has the limit. Now, if we start this running again, I'll show you that this is all in a Docker Compose. So in the Docker Compose, we have the composition of the web API and the web app. That's the moving parts of our application. And then we have the override that shows the configuration for the web API, the web app, and then it says the database, so we can test with the database, but it also has SAQ as a container. So we're running the place where we would want to store this semantic data. It's running from this SEC container, and it's running at this port 5341. I believe that's the default port if you run this yourself as well. So you can run it in an official production environment, but I'm just running it from a composition so I can neatly test it. Which means that if we go to here, then if I just refresh this, or do it like this, or we go to the thing here, we have this, and then we can say, okay, so we were looking for the logs that said retrieving, and these are the ones that we have. Let's create one with a different value, so we can see that up here as well. So let's say 42. All right. See, 42, 3 times. You see the dots here for the severity level, where you can filter and just pick out the ones that are warnings, errors, or both. But if you open up one of these, you'll see that there's a lot of metadata attached, and this one is the one that we're looking for. So this search limit of 42, that's where we can say, all right, so we want to have this search limit, and it knows that it's a semantic thing, so bigger than 10. And you can see that it filters out based on the search limit. And now the tricky part is, once you have this in place, is to find the right terms, because this can search across multiple log messages in different locations. So wherever search limit appears, this will just find it. Even if there's more information there, it knows where it is. So I think this is extremely powerful if you want to drill down and dig into, and if you have domain terms like conversion or a customer ID that might be relevant, this is what will help you find that semantic information and correlate it all together in search queries. Now, for the logging, keep your logging separate. Application should not be aware of the log providers that are out there. It should just say, this is what I want to say with this severity for this category. And your log providers and the filtering will take care of the rest. You shouldn't make any assumptions there. The other thing, your log severity level. What would you think if you had an exception? You do a try-catch and you do a log inside of there. Just think for a second, what severity level will you do? And you might think, well, usually I see in all the samples, it's like catch something, logger.log error, because we have an error, right? But it means that something is really happening in your application. And if you have alerts triggered to, okay, if there's errors in our application, we need to know about it. But catching something in a way that we predict might just be informational or even lower. Like, okay, we took care of it, we caught it, it's all fine. So be wary of the severity level and choose it carefully, because as a DevOps person, you might be with PagerDuty, VictorOps, or whatever tool you have for on-call moments, that you'll get, oh man, okay, so it's catching all the timeouts because sometimes the connection is slow to this other thing that we're calling. All right. Now, logging. We covered logging. Then the next part is about tracing. Tracing, there's two sides that I would like to highlight. That's the stuff that you probably already saw from the very, very beginning of .NET. And then there's new stuff that has been introduced in .NET 5 and onwards. So I call it the good old diagnostic trace, is where you don't just do log, but it's trace .debug or write debug, or you can write stuff to the trace. With tracing, remember that it's about the flow of your application. So you need to indicate, so this is what is happening now, this is where we are, this stage, or these are the variables. You can just trace everything, and it can be high volume. The good thing is that if there's no one listening, or it doesn't even matter, but there might be someone listening or not. If there's no one listening, it disappears because it's not logged. It's just sent out like a radio show. If somebody's listening, then they can choose to do with the information what they like. Otherwise, it disappears. And it allows for a publish-subscribe pattern. So you just put it out there. You don't know. You publish it. And there might be 0 or more subscribers. You'll find most of this in system diagnostics. That's just like it was at the very beginning. And the two things that you have are trace and trace source. Trace is the oldest. Trace source is a little bit newer. And thing to remember, and we'll get to that, is it uses activities. And that's significant for our story. But the two sides is that with the trace, that's very easy to use, because with trace, you have these options to do trace error, trace warning, trace information. Those are the three. Or you can do write and write ifs. And write ifs are conditionals. But it is evaluated, the if statement, so it does take a performance penalty. But it allows you to send out information any place without having to inject things. So inside of a complex calculation algorithm, you don't have to, with classes, object model, and all the way down there, you want to trace something, you can just say trace.write and write out something. Very convenient, instead of having to inject ilogger of t and pass it around all the places where you need to use it. The trace source is a little bit more modern. It has things where you control the trace data. You can trace events, which can also be significant. That's another way of doing it, but you need to wire that up with statics yourself. And both of them have switches, so you can turn it on and off if needed for a situation where you would like to investigate. So you can switch it on and off, almost like a feature flag. There's a bunch of listeners out there, so where it's being sent, or who are the ones that can subscribe. You can see that they are available from .NET Framework 2.0 is what I found, and well, .NET Core has its own implementation of the trace listeners as well. Those are more and more cross-platform, so they will work on Linux and macOS as well. Now the activities, that's kind of a cool thing. Activities are structures that allow you to have contextual information at the place where you're in. So it might be call stack or information regarding your trace. And that's being managed for you by the activity class, and it travels well across the various threads. So when you create one, even if you do async calls or then it will just travel accordingly, and if you ask for activity current, you will get the right one. So no concerns there. With activities, typically you add some metadata to it, and then you say, okay, this activity will start now, we'll start doing it. And from that moment on, this activity is like a little bubble, and things will happen inside of the bubble. You can spawn child activities, and they are related to one another, but everything that happens inside of an activity is correlated to the same thing. So there's correlation inside of activities. You can send out stuff that happens inside of your activity, so you can track some particular flow that you have. It even works distributed. So if you have calls from one place to something else, like we have from a web app to our web API, you can send out information along with the call out there. If both sides play the game, they know that they're working on the same thing, and a new activity on the other side, other process, will start based on the original one, so we can be correlated all together. So you can see flow from one thing to another thing based on those activities. And there's two things that make good use of this, application insights and OpenTelemetry. So if you're into OpenTelemetry, it uses activities under the covers, as does the application insights. All right. So I'll show that in code so we can get back to it later. Now, there's one place in our API where we can submit new high scores. So that's the scores controller. The scores controller allows you to do a post for your nickname and your game. And what we do here is we have this activity, we set the start time, that's done automatically, but if you choose to do it differently, you could do so. We can add tags to it, so we can add the tag gamer with the nickname we just received. We do our things, so we start an operation on a telemetry client that's being injected from application insights. A telemetry client being injected. And then we say, okay, so start an operation for dependencies. So we want to, see, we're calling something that is a dependency. And this is the activity that should track this operation. And then we start doing things. Now, this is obviously a local dependency to a database. We can see later on that databases are already done at the Azure level, so we can see a lot of things there. But just imagine that this would be some other thing that you're doing that is a dependency for you. In this case, it's just Entity Framework Core. And at the very end, I'm showing two things. So we're tracking an event, because if we passed all the way here, as we essentially received a new high score, and that's like, ooh, new high score in the leaderboard. That might be something that we want to track. And we put out this metric, so this number for the high score, that tracks the value with the points of the new high score. Doesn't really make sense, but this could be a sale in your web shop and the total amount of your sale. And then you could see, what's the sale doing if that is important. All right, so let's just trigger this for a second so we can perhaps see it later on. So we'll do a post here. We'll try it. We'll say Alex360. That's my Xbox handle, and then I'm not sure what game we should do. We already had, let's do Galaga. And we have the magnificent score of 1, 2, 3, 4, 5, 6 executed. And we got a 200, so everything worked. Let's do a new one. 124000, a big score. All right, so two new scores. All right, and we'll leave it at that because that's kind of the gist of it. It's not more than that, but you have to do things for it in this case. The activities are also in a lot of other places in .NET framework itself. So .NET 5, 6 later on. If you make HTTP calls, activities are doing the same thing without you knowing it. So there's already a lot of these things taken care of for you. All right. Now for the new stuff, because this is what you will easily find, a little bit more obscure, but all the more powerful, is the new system diagnostics tracing. So we just talked about system diagnostics trace, which is a class. This is tracing a namespace. And inside of it, you'll find a bunch of stuff, but two important ones are event source and event counter. And event source is, can think of it of the tracing and logging side, and the counter is about the metrics. Now, if you put this inside of your .NET application, and we're talking .NET 5 and up, it will use an event pipe to push that out. So event pipes are something similar to what is for LTTing or event tracing for Windows, ETW. That's your conduit out of your application to somewhere else, out of process. The event pipe is cross-platform, so it doesn't tie you like ETW does to Windows or LTTing, that's Linux-based. It works even for Mac OS. So event pipes are a good thing. You'll probably not interact with the event pipes directly, just know that under the covers, they are there. And then you have your consumers. So again, it's kind of in the tracing and the emitting thing. So you'll have consumers, a couple of obvious ones, application insights, and you have .NET tooling for .NET Trace, .NET Counters, .NET Monitor, but those can pick up all these things streaming out that you are emitting with event source and event counter. If you would like to, and if there's any reason, you can do it in proc as well, so you can have your own event listener and listen in on your own events and maybe use it for health information or some other thing that you come up with. So this is the way it works, but focus on the left with event source and event counter. Now, the event counters, they are a bit like performance counters, but that's again Windows-based. This is more cross-platform. And in .NET, in the runtime, the CLR, there's already a lot of things in there. This is just one section, system runtime, and you can see what is going on in there. So the obvious ones are CPU usage and the garbage collection related stuff. So you can see what is going there. Your working set, that's the amount of memory that you're consuming. So you can see, are we climbing and maybe have a memory leak? You could already view that with these things. And those are available out of the box. All of your .NET applications from .NET 5 onwards already had this, maybe without you knowing it. You can create your own counters. It's not that difficult, but then you can emit some specific information. But these are the ones you get for free. And if you want to implement them yourself, then you can use a couple of classes. You have the event counter and incrementing event counter. And the event counter is about values. So you give it values and it can see the trends and it can do averages or statistical things on a time series. So we can say, okay, what was the max and the minimum inside this time period? What are the averages? The incrementing event counter is more about rates and frequencies. So you can see certain rates of how fast things are happening. So it's per time. This is where you write it, so you give it. The other one, the polling counter and the incrementing polling counter, are two different versions that allow you to, they will ask you for the information, and you can do some logic there. That's inside of a Lambda expression. Now, in the example that you see there, we'll cover that in code in a bit. That's where you see that you need to have a frame event counter and do increments, and you can even write events. So that's the eventing side of things. But this is the little bit of code that you would need, and then you start calling that from somewhere in your application. So let's see that in code as well. And for this, I have a different scenario. So in this case, you'll see that in a bit. This is a little racing game. It's 8-bit, but it uses a backend that is a UDP-based socket server, and it receives all the information from people racing, and it sends out UDP package through a socket all the way. But at least it's doing something, right? It's just 5 times per second. It's emitting all this information. Now, all right. So what is in here? So the most important part is this event source. It's the game server event source. It's derived from event source. You can give it a pretty name, which is kind of like the category. This is the name of the provider that we're creating in this way. So this is something that we can see happen or encounter later on. It has the incrementing event counter and an event counter, and we create those, frame event counter. It has a frames per second. It's per second, so that's the rate time scale, and it has a nice descriptive name, as does the lab event counter, because every time you pass a lab, you will get a lab count that increases, just to show some things. And then if the race is started, you can write stuff, so write particular events, but this is another way of writing the events, and it uses the map name combined with the message here. So race started 4 is the template, and this 0 takes this name, and it takes it literally as the variable name. And the frame sent, that's the one we saw on the slides. This sends out that information. So every second, this is incremented, and this is actually a 1, but if it's something different, it's a double value that you can add here, but by default it's 1. And we're doing 1 frame every time we send this thing. Now it's a class with a static that creates a singleton, so that's this thing here, which means that if you want to use this somewhere in our code, this is where it would be. So this is the update method. For any of you that did game programming, you have an update loop. That's the game loop. We're sending frames here, but this is the point where it actually happens. So there we do the log. That's the thing that we just, the singleton, server same friend, server frame sent, and then we give it the map name, which was part of this update and this class. Now, with this, we can run this. So it's building now. It will start in a second. All right. So it has started. I'll put up 2 of these things. We need to connect to it online. You see that something is happening here, like it's send out the game list, so it's really doing something. And then we say, okay, log in, connecting, and if all goes well, timeout, let me see, yep. All right, there we go, the other one, let's connect that as well. Connecting, I hope that works, but anyway, we already see the information there, so this might just time out. Let's try that one more time. Oh, now it's already connected, so already logged, but okay, anyway. So stuff is happening. You see all this blue stuff, and it's changing all the time, because here you can see the numbers that are passing by. And now we go here, and we would do something like .NET counters PS. That gives me all the processes that are able to be used by this tool at this moment. So we will look at the counters that are emitted. We need to have this one, the game server, which is 20364. So then we can say, okay, which ones are there? So you can say lists, and then do it for a particular runtime version. Well, let's runtime. Let's skip that. So these are the things that you have. This is for .NET Core version 3.1. You can see that there's system runtime, there's ASP.NET Core hosting, but since 5, and I'm not sure why it's still at 5, but since 5 there's system.NET sockets, there's security, name resolution, HTTP, so there's a bunch of more stuff, not just the system runtime. All right, now the other thing that we can do now is, and this is not the correct one because we had, does anyone remember the number? Let's check again, 20364. All right, 20364. Now it will wait a little bit for all the information to come in, and if you don't specify anything, it will do system runtime and show you all the stats of the things that are there. So that this you can do with your ASP.NET Core application, just do this, and this was already there. But we had some custom stuff, so we need to 20364. What I'm doing here is providing this counter, and the other one that I would like to see is system sockets and system runtime, but only the CPU usage. So there's square brackets here to filter that down. And if I do that, then we can see that it says system socket. So it's actually showing us, so 5 times per second, you can see that this thing is going up because it's 5 frames per second. So we're hitting that rate. And we can see the frame rate here, but that's the thing that we emitted as well, is running there. And the CPU usage is pretty low at the moment. So this could be, anything of your stats, if it's calculation engine, the speed of processing, number of conversions per hour, those things can be emitted here. And this is now streaming from here and ending up also in application insights in a moment. All right, so let's move on. I put this in for reference, but there's a way to monitor these kind of things with .NET Monitor. You can do that locally or in a container, and you can install it as a tool as well, but this allows you to watch your things, and if you look at the API endpoints, you can see that you can get metrics there, you can force a dump, and some information on what is happening there and the logs, just as an endpoint to listen into it from this thing without any additional tooling. All right, now, we've done a bunch of stuff. So we did metrics, we did tracing, we did logs, we put it all out there, but how do we see it? Because if this is running in Azure, what good will it do to us? Well, that's where you say, okay, we want to monitor it, but also query and analyze it. This shows application insights, but this is equally true if you have any of the other APM tools. And the functionality might vary, but in this case, I've chosen for this setup where the Azure resources use App Insights and Azure Monitor, like we discussed at the beginning. Now, what happens with Application Insights, you can connect that to your web app, your web APIs, all the dependencies that you have, and the other stuff. And the other stuff, the more is in Azure, the more you will get from it. Other external services, you might need to do some things with the telemetry client and help out with, I'm now making a particular call that is with a weird protocol, for example, and I'm doing that with a client library that doesn't know about this stuff. But you can help there and specify what is going on. All right, so if you instrument Application Insights, it will send it there. Any dependency calls or HTTP requests or other things that are well known will be put out there. Any Framework Core also plays this game. And then the background services are just .NET implementations, so they can be instrumented with App Insights as well. Now you can do logging and tracing, so you can do trace listeners to have App Insights trace listeners. You can do the logging that we already saw, and you can use the telemetry client, which allows you to write those events and put out the statistics and the information as well. So metrics and traces. We looked at the start operation, track event, we saw those. Now, and we had the new stuff, right? So the event pipe, this is just a reminder to the previous slide. But from App Insights, you can send this with a telemetry module, but you have dependency telemetry modules. But there's two other ones, the event source and event counter, which obviously serve either one of those. Now, if you want to use .NET Trace, you can use Purview, which is a low-level, ugly tool that's been around for ages. It works well, doesn't look as nice, but that's where you can just see all the information. If you gather it yourself with .NET Trace, you can collect it, store it in a file, a .NET Trace file, and then you can observe it yourself. But otherwise, we'll jump into Application Insights. So I'll hope that we can get to see this picture here. Let's just stop this blinking stuff. we'll go back to our, I'll quit, and then we go here. All right, so let's go into this App Insights instance where everything is being logged to. It's smallish, so I'm missing the sidebar, but this works. So let's see, with all the activities that were built in and that we were doing, let's try to see the application map. So what it will do now is gather all that activity information and put it together. And then you can see this is what we did just a moment ago. You see all the information, and I'm trying to get this in view. So that's the sec call that we made. This is actually our activity got new high score. Remember that we created that? So because it was registered as an operation, as a dependency, you can see that it seems as if we're calling something external, right? So that's you can see, ooh, that's part of my application. We have the key vault calls, we have the SQL calls to Azure SQL, and we have the call from our web application front end, which was instrumented, to the web API that is here. And this one is also calling this thing here. And if you want to have details, you can see that it's the key vault that we're calling there. You can see that if there's errors, you can drill down into them. And let's just force an error. And I need to see if we're still running the application. We're not, so. All right. So there's also live metrics that you can see. Live metrics should be popping up. So you see that there's now 2 servers online. 2 servers meaning 2 pods in our composition, or sort of 2 containers in our composition, the web app and the web API. They are both thought of as servers. And you can see that things are going happening here, and there are things going wrong. All right, so that's a good thing that we can see it. Not so good that that something is going on. So if I do limits, and I do limit is 1, you can see that I only get 1. But there's an intentional bug. If I do 0, it's in a very long loop, not even a thread sleep. And the front end decides this is taking too long, I will terminate this. It uses poly for that, but it gives us a timeout exception. Now, in a moment, we should be seeing more things coming in here. You see the exception that it just passed by, because that's being logged and detected. Now, for the sake of time, I'll go to show you a bit about the metrics that we can also collect. So we have log-based metrics. The metrics that are there are about availability, about the browser, that's all App Insight stuff. But here we have the custom ones. So again, you see this frame rate counter. If we choose to see that, then for example here we had a bit of a difference in the frame rate. So a bit dropped to 3, not too bad. We could also, let me see, add metric. So we could also see what about this high score. So let's see if we already have that average. It's giving me some data, no or not, just yet. So refresh this. Okay, that might be coming later on. We could say, okay, do the last 24 hours because I obviously tried this before. And then you can see that there were scores being sent in. All right, so this is just the number of the score, the average there. We had a very high score a moment ago. Then we have the logs. And this is where we can say, okay, we have logs, for example, traces. Let me just quickly, to avoid some typing. All right, let's run this. The where operator failed, I'm not sure. All right, let's do it differently. We'll go to the logs, push out this, get rid of this. And just say, okay, let's see all the custom metrics. I believe that's the one. Run it. Now you can see that there's a lot of heartbeat state, but there's also the values of our frame rate, for example, and there should be things with the high score, excuse me, also here somewhere. But this is where you can do the filtering as well. So this is all the traces. But you can do similar things as in SEC to filter out the semantic logging information and get that info out in your thing. So let's see if this one would work. Let's hope it does. See, there we go. So the race started. That's because we started 2 players, and it's being sent out, and it has these custom dimensions. That is about the map name, for example, that was put in there. So this is, again, where we can filter based on those things, as we did just a moment ago, custom dimensions and event names. All right. Wrapping up. So what we saw in this session is we were able to do the things with the logging, tracing, and metrics to make our things more observable. Just a glimpse of App Insights on the richness that is in there, but you can get all the metrics. You saw the graphs, you saw the log information, play around with it. You can do troubleshooting, end-to-end investigation, and that's where it's very strong. The alerting is just a matter of create an alert, say which metric, values, boundaries, and it will help you raise alerts on availability from your health monitoring or your metrics and the trace information that you have. That's all I have for you now. We've got these reasonably covered, and I would like to thank you very much. We're out of time, but I'll be here for any questions and answers.
All righty. It's time to start, I think. So this talk is called Building Confidence in Concurrent Code Using a Model Checker, aka TLA Plus for Programmers. It's a bit of a mouthful. Hopefully by the end of the talk you will see what I'm talking about. Now, I'm Scott Voloshin. You probably know me from my functional programming talks and also from my domain modeling talks. This is nothing to do with that. This is all about having confidence, how you test your code. It's not testing code, but how do you have confidence in your designs? So I'm going to ask you in a minute about confidence. I'm going to be testing your ability to look at code and see whether it's right or not. So there is a poll. I'll show this link later on, but hopefully you had a chance to look at it, but I will show a big version in a few minutes. It's bit.ly/TLA poll 2023. Right, okay, so why am I focusing on concurrent code in particular? That's because there's two groups of people. There's people who write concurrent code and people who've had painful bugs in concurrent code. And of course, this is actually a perfect circle because concurrent code is horrible. Anyone's actually done anything with concurrent code, it's really nasty stuff. So this talk is really about confidence, right? How do you increase your confidence in your code? And what tools can you use to increase your confidence, right? So there's a toolbox of tools that we use. I mean, the classic one is to do code review or code inspection, right? I look at your code. It's nice to get another pair of eyeballs on your code and make sure it's looking good. I really like static typing. That eliminates a lot of stuff at compile time. It's kind of like compile time unit tests, really nice. I'm also a big fan of property-based testing. That's a great way to increase your confidence in the code. Things like TDD, all the classic techniques, you know, it's all about increasing the confidence in your code. And this talk is about this thing called model checking, which is probably for most of you a brand new concept. So that's what this talk is about. It's a whole new tool to add to your toolbox. Now, what do I mean by model checking? Well, what's a model? So a model is a tool for thinking. So before I spend a lot of money building a building, for example, I make a model of the building, and I can use the model to make sure I'm happy with the way it looks, and I haven't kind of forgotten anything, and I can show it to other people and get feedback. So models are a way to make sure that you're doing the right thing before you spend a lot of money building the massive building, right? So it's just a way of making sure stuff makes sense before you do something which is much more expensive. So model checking that I'm talking about is, again, you create a model of your code. You don't actually write the code. You create a model of the code before you do it, and then you check the model. And the kinds of things you check are all the constraints met. You know, does anything weird happen when you check the model? Especially if you're doing concurrent code, you know, does it deadlock? Does it ever finish? Does it reach a state that you expect to reach? All that kind of stuff. So we're checking the model before we even write the real code. So this is part of formal methods. Formal methods is kind of mathematical approach to code quality. This is actually the very easy one. This is like the simplest intro to all this stuff. So there's a couple of model checkers you can use. There's actually a whole bunch of them, but the two most popular ones is something called TLA Plus, which is actually a whole system, and TLC is the actual model checker within. And I'm not even going to get into all the other stuff in TLA Plus. I'm just going to focus this in one thing. And it focuses really on temporal properties, something to do with time, okay? So it's great for doing concurrent systems. Now, there's another one which is quite popular called Alloy, and that's much better on kind of relational logic and relationships between structures and so on. So that's also very good. But in this talk, I'm going to be focusing on TLA because of the benefit it has in modeling concurrent systems, okay? So at the end of this talk, you'll know something about TLA Plus. So this is what TLA Plus code looks like. And, you know, it looks weird, right? I mean, this is the weirdest looking programming language that, you know, I've ever seen. When I first saw this is a strange programming language. Well, the reason it's a strange programming language is because it's not a programming language, right? It's not a programming language. It's a modeling language. It's a DSL for modeling states and time. So you might look at this and think this is kind of weird, but hopefully by the end of this talk, you'll be able to look at this and not think it's weird. So that's the goal of this talk. Now, obviously, in one talk, you can't really become an expert, just like in any programming language. You can't, you know, learn it in an hour. But if the point of this talk is to demystify this, to just take some of the fear around using a tool like this. And so it's actually not that hard to use, and it's worth spending a bit of time learning. So let's do some first live poll. Here is the live poll I'm going to use, and let me get this started. Right. So the first, hopefully everyone has got this up now. It's bit.ly/TLA poll 2023, or there's the big QR code here. And I will show this again later on if you didn't quite get it. But let's just see what the results are. 100% of people can see this poll. Excellent. Nobody said no. That was very nice. Okay, so this poll seems to be working pretty well. Okay, good. Oh, some people say no. Some people are just mean, okay. Or they don't know how to use the internet. Right, okay. So some people are not going to be very good here. Okay, so, that's the poll. Right, so I'm going to be asking you later on some more serious questions. So this talk is basically going to start about, it's going to have some stuff about confidence, and then I'm going to introduce TLA+. I'm going to show you all that syntax and show you that it's not as weird as it looks. And then I'm going to run through 3 examples. First of all, I'm going to do a really, really simple model, which is counting to 3. Hopefully, that will be pretty simple. Then I'll actually do a very classic producer-consumer model, where they talk to each other through a queue. And then I'll actually do something which is kind of relevant to what we actually do, which is maybe a zero downtime deployment. So you're in charge of deploying some servers, and you want to make sure you have zero downtime. What algorithm should you use to do that? And if you mess it up, you're going to have downtime, so it's kind of important. Okay, so let's start with confidence. So I'm going to show you a non-concurrent algorithm. This is just a regular old sort algorithm. To sort a list, this is the algorithm that we're going to use. If the list is empty or has one element, it's sorted, we're done. Otherwise, we take the first element, which I'm calling the pivot, and I'm dividing the rest of the list into 2 piles. One's smaller than the pivot, one's bigger than the pivot. And then I take these 2 piles and I sort them using the same algorithm, and then I combine the whole thing, and I put the sorted smaller list, and then I have my pivot, and then I have the bigger sorted list. Okay, so that's how I'm going to sort a list. Okay? So do you have confidence that this algorithm is correct? Not in implementation, but this algorithm. Is this a correct? If I then write this code, is it going to work? Okay, that's my check for you. So that's my first poll question. What is the confidence in the design of this algorithm? It's basically a quick sort kind of algorithm. It's not really a quick sort, but it's a recursive sorting algorithm. Hopefully you've seen this kind of thing before. Now, you should have 100% confidence one way or the other, whether it works, because the code's right in front of you, and it's only 10 lines of code. So if you don't all have 100% confidence, I'm going to be very upset. And we have a mixture between people who are confident, people who are not confident, and people who aren't confident either way. And this is very interesting. So, for the people who are not confident either way, what could I do to make you more confident? Right? What kinds of things could I do? And if you thought it wasn't confident, if you thought it wasn't correct, what could I do to prove that it was correct? Or, if it was correct, what could I do to prove that it wasn't correct? Okay? So the fact that it's not 100% in this room, it's typical. It's typical. People are not very confident about their code. So actually, that's actually a bug. So all of the people who said this was right, you're not right. There's a bug here. And the bug is actually should be, I had strictly less than, strictly greater than. It should be greater or equal or less than equal, because I'm throwing away duplicate pivots. So there's a little bug, which you didn't catch. So how would you catch the bug like that? Well, one thing is code review. I mean, I could go and say, so you forgot to do the less than, you made it too strict. Another way is to do an implementation. I write this code in Python or JavaScript or something, and I test it. I'm a big fan of using property-based tests because that would catch it pretty straight away, I'm pretty sure. Rather than just unit tests, you might not catch it because you might forget to put duplicates in, but a property-based test would probably catch it straight away. Or you could actually prove it using a mathematical proof system, which no programmer would ever do that as far as I know. So personally, I'd use a combination of both. I'd have somebody else eyeball it, make sure they're happy, and then I'd probably write some property-based tests. And if you want to know what property-based tests are, I have a whole talk about that. If you go to f#profit/pbt, and I'll have that link up later on as well. Now, that was a non-concurrent algorithm, and we still had a big difference. Now let's talk about concurrency. How confident are you when concurrency is involved? All right, so I'm going to give you a concurrent thing. So this is a very simple producer-consumer system, we have a queue, and we have a producer that writes the queue. And the producer logic is, I'm going to see if the queue is not full, and if it's not full, then I can write to it. But if it's full, I don't want to, it's a bounded queue. And then we have a consumer that's reading from the queue. And they're going to say, well, if the queue is not empty, then I can read from it. But if it is empty, I'm just going to wait. And they're just going to loop around. The producers and consumers are going to be looping around. Okay? So that's the system. Okay, so here's the complete spec. We have a bounded queue. We have a producer and a consumer. And it's really important that we never read from an empty queue or write to a full queue. We don't underflow or overflow. And let's say the whole system's going to crash and bring down Azure, for example. So here's the spec, and here is the consumer spec. So again, the algorithm is really simple. I mean, it's actually simpler than the sort algorithm. Who thinks this is a correct design? There's one producer and one consumer. Yeah. And it's a trap. It's a trick question. It's always a trick question when it's concurrency. All right? So try that poll and tell me if you think this is a correct. Yeah, so for one producer, one consumer, and later on we'll talk about more than one and more than two, but for one producer, one consumer, is this the correct algorithm to use? Let's see what people say here. Oh, okay. We have a big difference of opinion here. And what's interesting is that most people are not confident. Now, this is really simple. I mean, how much simpler could you get? You just got, there's like 2 or 3 lines of code for the producer, 2 or 3 lines of code for the consumer. They're both running at the same time, and nobody's confident that this code works. Like a whole bunch of people are not. And the people who, there's a big split between the correct people and the incorrect people. So who's right and who's wrong? And for people who are not confident, how could I persuade you, I mean, I would say, let's say I say this is absolutely right. I'm really confident this is right. How would I persuade you that I was, that I was right? I mean, you don't want to run it in production because you might not show up in production. So we're going to revisit this one in a minute, and we'll actually model it in TLA, and we'll actually get an answer. So like I say, if you voted not sure, how would I persuade you? Now, let's change it up and have 2 producers and 2 consumers. So with 1 producer and 1 consumer, and we'll go to the next poll question now. With 1 producer, 1 consumer, it was 50-50 split between correct and incorrect, and there's a whole bunch of people who weren't sure. And now we've changed it to 2. So has people's opinion changed? Let's see. A lot of people are confident that it's not correct. Okay, so anytime there's more than one thing, you know that it's not going to work. Okay, and there are quite a few people who are not confident either way. But people, people are very suspicious. Like, I don't think this is going to work because somehow it's multi-user and there's concurrency, and it's like, I just know it's not going to work. Right, so people are scared. People are scared of concurrent systems, especially when there's a lot of stuff going on. Okay, so people who are not sure, how could I persuade you that it didn't work or did work? Now, the people who thought it didn't work, this is the big thing. So I say, I'll have a fix for it. I'm going to use atomic operations. I'm going to use semaphores. I'm going to use a lock. I'm going to use whatever, right? And I present to you my fix for this problem. How would I persuade you that my fix was correct? Would you just say, I never trust it? I'm just like never going to believe it's going to work? What could I do to give you confidence and say, yeah, actually your fix, I'm really confident that your fix is going to work and we can deploy this to production? What would I have to tell you? Okay, so it's hard. Being confident in concurrent systems is a really hard problem. Now, the tools that we normally use don't work. So if I do code review and inspection, I mean, you're looking at the code. We have a whole bunch of people looking at the code. I don't think our human brains are very good on concurrency. Our intuition is just rubbish. So that's not going to work. If I create an implementation and then test it, that's not very good either, because a lot of subtle concurrency errors don't show up in testing, and they don't show up in development. They show up in production when you have millions of things and there's a very high load, and it always happens on the worst day of the year. So just running it is not a very good way of doing it either. So the answer is to use a mathematical proof assistant tool, but that's too much mathematics. We're going to use a model checker. That's what we're going to do. So I'm going to revisit this problem again with the model checker, and we'll see for ourselves whether it works. So time to talk about TLA+. This is the tool we're going to use to model this. And again, I'm going to whiz through this very quickly. It's a very short, I mean, it's a quick talk, but hopefully it's going to just demystify it. You don't have to worry about the syntax too much. And stand back, because I'm actually going to use mathematics, so be careful. And that's because it's not a programming language. It's a mathematical-based model. So TLA+ was designed by Leslie Lamport, who you might have heard of. He had a famous time and clocks paper in distributed programming. He invented the Paxos algorithm. He's a Turing Award winner. And relevant to this, he is the initial developer of LaTeX. Here he is, a picture. And the reason why that's important is because TLA+ uses LaTeX kind of syntax. It's designed to be formatted by LaTeX into papers, computer science papers. It's not designed to be a programming language, which is why it kind of looks weird. So if you know LaTeX, the syntax will be fine, but if you don't know LaTeX, it won't. So what does TLA+ stand for? It stands for Temporal Logic of Actions Plus. All right, what does that mean? Logic. So logic is something to do with Booleans. Hopefully you know how to use Booleans, so that's good. Temporal is something to do with time. And actions in this thing is going to be transitions in a state machine. So as you move from one state to another, that is an action or a transition. So TLA actually stands for Boolean Logic of State Transitions Over Time. Now that's a little bit less scary, and we're going to kind of dive into that in a minute. And then there's some other stuff which we'll talk about later on. So let's look at the logic in TLA. So Boolean logic is what it is, and it's and or and not. Hopefully you all know how that works. The big thing about TLA is the way that they do Booleans is the mathematical way. So in maths, you have a kind of uppercase A is an and a kind of upside down A is an or, and that's what TLA+ it uses forward slash and backslash. So if you look at the code, you'll see these forward slashes and backslashes everywhere, and all that is and or. Now in programming, we use like ampersands and vertical bars and stuff. TLA+ does not use that, but it's the same, exactly the same concept. So hopefully you already know how to do that. And then another big concept is something called a predicate. So a predicate is just an expression that returns a Boolean. That's all it is, right? So in a programming language, I might say, here's a function with A, B, and C, and it's A and B or A and not C, right? So the whole thing returns a Boolean, and you just run it, and each time you get a different result, but it's a Boolean. That's a predicate. Okay, so TLA, I'd write the same thing in TLA like this. I'd say A and B, that's the kind of A, the letter A, or, which is the upside down A, and then A and not C. So that's how you would write the same kind of piece of code in TLA. So there you go. That's, hopefully it's instantly a little less scary, just knowing what all those forward slashes and backslashes mean. Now, actions, so state transitions. So you're probably familiar with state machines, but basically you have a bunch of states and you have a bunch of transitions, and that's how you model things. It's a really nice tool. It's nothing, I mean, I use it for domain modeling as well. So here we can go from A to B, we can go from B to A, we can go from B to C, but we can't go back from C to B. And this model kind of captures that information. Very nice. So, you know, if you're modeling a chess game, you can model all this stuff. People take turns. But what's nice, you can see straight away from this diagram that when somebody goes to the game over state, you can't go back to playing the game. I mean, it's immediately obvious that transition is not available, right? Here's something for like a delivery, of FedEx or something. Again, you can see that once it's delivered, you can't undeliver it. You can go back and forth in various other ways, but you know, this design does not cover that situation. So let's look at a transition in TLA. So in TLA, there's always a before state and an after state, right? So in this case, the state before is hello, and the state after is goodbye. So in TLA, we would say state equals hello, and then state tick equals goodbye. Now, every time you see the tick, or the prime, if mathematical jargon, that means it's the after state. There's always a before, and in every single transition, there's a before and after. And so if it doesn't have a tick, it's the before, and if it does have a tick, it's the after. So that's what those little ticks mean everywhere. And this whole thing is an action. So I can give this a name, like this is the next action that you can do, the next transition you can do. So in TLA+, I would write like this. I say next double equals, that's the, double equals is not assignment, it's like, you know, definition. So the next operation is at the beginning, the state is hello, and, which that's the slashes, and afterwards, the state is goodbye. Right, so in English, we'd say, you know, before the state is hello and after the state is goodbye. And that's the kind of formal way of writing this down. So this equal sign is not an assignment. If you don't think about programming variables, think about the state before and the state after. This whole thing is actually a predicate. This is true if the state is before and after, you know, like that, this is true. And if the state before and after is not like that, it's false. So this thing is actually a predicate. It's an expression which turns a Boolean. And you can tell it's a Boolean expression because you can swap the order of the things. And it's the same answer. So it's not assignment, it's more like pattern matching. It's like, is this thing true or not? And that's how the model checker works. So here we have our little transition. And in the first case, this transition is true. In the second case, the after state is not right. So that does not match. That's false. In the other one, the before state doesn't match, and that's false too. So there's, you know, it's true and then false and then false. Like I say, it's a predicate. It was an expression. Okay, now let's look at time. So TLA, the transitions go on forever, right? It's basically an infinite set of transitions. You start at something, and think of it like a clock ticking. It's like it goes from here to here and then here to here, and every time the clock ticks, you have to make another transition. Okay. Now, because it's a infinitely long series of transitions, you can ask questions. You can say, is something always true? Is something ever true? Does it ever happen to be true that this thing, you know? If something happens, must something happen afterwards? Can it, you know, does it require that something happens afterwards? So that's the time thing. So that is everything about TLA, right? So it's Boolean logic of state transitions over time. And we'll talk about the plus later on. So that's the syntax for TLA. Now let's actually use it to do a very simple model, and we're going to count to 3. Okay, how hard is that? So here is our series of state transitions, right? We go from 1 to 2 to 3. There's 3 states and 2 transitions. So we're going to model that in TLA. Now in a programming language, you would say x equals 1, and then x equals 2, and then x equals 3. Right? That's how you do it in a programming language. But we're not going to do that in TLA+. It's going to be more complicated than that. So the first thing we need to do is say, what is the initial state? In the initial state, x is 1. And then what are the available transitions that we can do? Well, the first transition we can do is true if we can do this transition if x is 1, and then afterwards x is 2. So that's a valid transition. Or we can also do a transition if before x is 2 and after x is 3, right? So the initial state is 1, and then the first transition is the before and after state of 1 and 2. The second transition is the before and after state of 2 and 3. And then the overall, all the possible transitions we can do is the first transition or the second transition, right? So the entire set of things you can do is the choice between those 2 things. All right, so that's how you count to 3. Okay, it's very, very exciting. Now let's just do a quick refactor. You can take little chunks of code and give them names, which is nice. So here I've taken out these 2 transitions and I've given them a name, step 1 and step 2. And now the overall thing is step 1 or step 2, which is a little easier to read. So these things are called operators in TLA. It's not like, they're not little functions, they're actually more like kind of macros. They're kind of copy, you know, search and replace type macros. So there's step 1 or step 2. So hopefully the forward slashes and the backslashes are not quite so scary after all this. Now let's look at the tool that we can run this piece of code or this model. So there's lots of different tools. The one I'm going to use is called the TLA Plus Toolbox, which is kind of an IDE. And this is what it looks like. It's actually written in Java, and it's over 10 years old. So it looks kind of ancient. It looks very unmodern. However, it does work, and it works fine. So I recommend you use this if you're doing it. So here we have my screen, and I basically paste my code in there or type my code in there. And the first thing you do is just make sure there's no syntax errors. And then what you do is you create a model for this piece of code. And in the model, you say, what is the initial state, and what are the various transitions you can do? And that's what I've done here. You can just like tell the model what those things are. And then what you do is you run the model checker. So let me actually run the model checker. Here we go. Here is my code here. And here is my model. And I'm going to go run. And here it is running. Run, run, run. And it looks like I got some sort of error. It actually says deadlock reached. And if you look down here, it says it starts off at 1, and it goes to 2, and it goes to 3, and then it had some sort of error. Right? So what's going on here? Right? There are 3 states, which is 1, 2, 3, but we get this deadlock. So deadlock sounds bad. What does deadlock mean? What deadlock means is that, and by the way, these traces are really useful. We'll see these later on. It basically tells you what it's trying to do, and so you can actually figure out. This is the way you kind of debug this thing. You can look at the states and see where they are. So what happened is it got to 3, and then there was nothing it could do after 3. Now remember I said these things are supposed to be kind of an infinite series of transitions. So it hit 3, and there was nothing it could do. And that's what a deadlock is. A deadlock is when you cannot make any forward progress. Like two people are trying to write to this file, neither can write to the file, neither of them can do anything. That's a deadlock, right? So deadlock just means nobody can do anything. And in this state, in this case, you hit 3, and then there's nothing you can do. That's a deadlock. So this little model deadlocks when it hits 3. That's no good. So how can we fix it, right? We're going to have to always think of these things as infinite series. Well, the answer is we just transition to 3 every single time. When we hit 3, a valid transition is transitioning to 3 again, and then transitioning to 3 again, and then transitioning to 3 again, right? So at that point, we can now have an infinite series of these 3s, and these are all valid transitions. So if we add these as transitions, it can make forward progress, right? It's not changing the state very much, but it is at least moving forward along the series of transitions. So we're going to add that to the model. So basically, we're adding a little loop on that. When it hits 3, it can just keep looping around and hitting 3 over and over again. And there's a keyword in TLA saying unchanged. So this last one, I've added a new one called done, right? And the done step is when x is before x is 3, and afterwards x is unchanged. Right? So it's basically x is still 3. So when we add this to our model and we run the model, it works really well. Okay, so we run this, we don't get any more deadlocks, which is very good. So TLA is happy. Okay, now let's move on to the next thing, which is doing nothing is actually always an option when you're modeling a state machine. Because let's say that I'm ticking every second. I go from 1 to 2, and then I go from 2 to 3, and I'm just ticking along. Now let's say that I'm at 1, and then a millisecond later I stay on 1. I transition to 1. Okay, and then the clock ticks, I go to 2, and then a millisecond later I go to 2. And then clock ticks, I go to 3, and a millisecond later I go. This is exactly the same system. The fact that it didn't do anything, for a millisecond, from a logical point of view, it's exactly the same system. You can't tell them apart, right? So being able to do nothing is almost always a valid option, right? So here I'm just transitioning back to the same number again. So staying in the same state is almost always a valid. Sometimes it's not. Sometimes you don't want to do that. But in a lot of cases, it's really common that you want to do that because things might just not. They can just do nothing for a while. It's not a problem. So the word for that, the jargon word for that, is stuttering. Meaning it just kind of stays around, just goes around in a little loop. So if you hear the word stuttering, that's what they're talking about. Nothing's changing. So now let's add stuttering to our little model here. So instead of being able to transition to 2, we'll say, well, it can stay at 1. That's all right. And then instead of transition to 3, you can stay at 2 for a little bit. That's all right. That doesn't do any harm. Right, so we've added a new thing to our model saying it can either do step 1, or it can do step 2, or it can be in the done state, or nothing happens. And that's all good. So that's our model updated with stuttering, which, like I say, most models should have stuttering because that's the real world. All right, now let's do some properties. So this is where we are no longer, you think that's a lot of work to count to 3. I could do it in a programming language in 3 lines of code. But what you can't do is the kinds of things that TLA can do, which is temporal properties. So let's look at these. So a property is something that applies to the entire system over time, not just to like individual states, but the entire system. We're going to make assumptions or predicates about the entire system. And these properties, again, like does it deadlock, does it ever get to the end? We are really bad at doing this kind of thing. And programming languages don't do this either. And that's why you need something like TLA. TLA is excellent at doing this kind of thing. So let's look at some properties we can check in our system. A nice property is something always true, right? Is the queue always within bounds? You know, is the file system always active? Is the servers always online? In this model, we could say, is it always true that x is greater than 0? It's really simple, okay? So hopefully it's true. Now, eventually true is a nice one. That means that it's not true right now, but hopefully at some point we would expect it to become true. Hopefully, if we got a bunch of servers, we would hope that at least one of them would serve a file at some point. Eventually always means that it gets to, eventually something happens, and when it gets to that thing, it's done, and it stays there forever. Right? So if you're doing a server upgrade, you eventually get to the upgrade thing, and at some point the upgrade's done, and it's done, right? Or in this case, we count to 3. When we reach 3, we're done. We're not. That's, you know. So eventually, always, it should be 3. And then the last one is, you know, the implication. If you hit 2, does that imply that it's going to become 3 at some point later? So all of these things look like they should be true for our system, right? So how do we do this in TLA? So again, in English, I'd say x is always greater than 2. Sorry, that's a bug. It should be always greater than 0 there. So in mathematical terms, we have to turn it into a predicate. We have to say it's always true that this predicate is always true. And the predicate here is x is greater than 0. And the always operator in TLA plus is this square brackets. The eventually, so instead of saying at some point x is 2, we say it's eventually, this predicate eventually becomes true. So eventually the predicate x equals 2 is true. And in TLA plus, we use angle brackets for that. X eventually becomes 3 and then stays there. So mathematically, we'd say it's eventually true that it's always true that x equals 3, right? And we use angle brackets followed by square brackets. And then if x ever does become 2, then it should become 3. And so we say if the predicate x equals 2 is true, that implies that at some point the predicate x equals 3 is true. And so we have the kind of curly, wavy arrow. Okay, so let's write this as code. So actually, rather than saying greater than 0, I'm going to say it's always within bounds. So always within bounds means it's always greater than or equal to 1 and less than or equal to 3, right? So you can see I've got the greater than 1, I've got the or, the upside down A. So it's either greater or equal to 1, actually no, sorry, it's and, sorry, it's not upside down. It's greater or equal to 1 and it's less than or equal to 3, and the whole thing is with the square bracket, so it's always true. Eventually 2 is that x equals 2, eventually that's going to happen. So there's little angle brackets there. Eventually, always, x equals 3. So when it does hit 3, it's always going to be 3 after that. And then, again, if x equals 2, then it implies that x equals 3 later on. So here's our 3, and we just write this in the code. We just add this to our file, and this is something you can't do in a programming language, right? We add it to the file, and then what we do is we tell the model checker, check these properties. Are these properties always true? And we run the model checker. Well, let's see. What do you think? What's going to happen if we run the model checker? Let me just go over here and go to the next poll here. If I run the model checker, how many properties will be true? All of them, 3 of them, 2 of them, or just 1 of them? Okay. There are properties there. Let's see what people think. Most people think that all of them will be true, it looks like. Okay, yes, some of them, 3 of them, 2 of them. It looks like most people think all of them are going to be true. Right, if we actually run the model checker, what does it say? It actually gives an error. So it's not true. Turns out that only 1 of them are true. Okay, because if you look at the trace, it says it goes to 1, and then it does stuttering, which means it stays on 1. Right, so people forgot about stuttering. I told you all about it, and then you forgot about it. So what it means is it starts at 1, and then it just loops back to 1 forever. So that's never going to get to 2, and it's never going to get to 3. And even if it did get to 2, it could just loop around on 2 forever. It's never going to get to 3. So both of these things, these states, you can just go around forever and never go anywhere. So we've just ruined our model. Yes?
So temporal property means true in all scenarios.
Yes. Yeah. Yeah, and it's just going to go around one and, it's just going to start at one and just stay on one forever. So by adding stuttering, we've actually ruined our model. We had a nice model at work, and now we've broken it, okay? Now, and I said, but we should have stuttering, so we've got a kind of conflict. We should have stuttering, but on the hand, as soon as we add stuttering, it breaks everything. So in this case, the only one that is always true is the always within bounds. So even though it stays on 1, it's always true that it's between 1 and 3, even though we've broken the rest of it. So let's fix that. What we really want to do is say, okay, you can go around a few times, but you should try some of the other ones sometimes, right? Don't just stay in an infinite loop. Like if you can go some other place, if you can transition to 2, every so often give it a go. Don't always do the same thing and go stay in an infinite loop. Right, so don't stay in an infinite loop, try different things. That's called fairness, right? Be fair. Like give each of the possible, if you've got 2 transitions you can choose from, use both of them every so often. Like, don't always pick one and never use the other one. That's not fair, right? Use both of them. So that's called fairness, right? And of course, TLA recognizes this as a really important thing, and it has a concept where you can model this in TLA+. So how do we model it in TLA+? Well, I'm going to have to refactor the code a little bit. And the syntax, unfortunately, is a little bit ugly. Now we're getting into sort of the ugly syntax. So first of all, I'm going to take the spec that we had, and I'm going to merge the initial state and the next thing into one single thing, which I'm calling spec. So this is the specification for the entire system. So it starts off as the initial and, then the next one is just always the next thing or unchanged. All right? So it's always always do the next step or leave it X unchanged. So that's our refactoring. Now it turns out there's a nice bit of syntax sugar for this. So instead of saying next or unchanged, there's actually a little bit of syntax sugar, say with square brackets around it, underscore X. Now it looks really ugly. That's because it's not been formatted by LaTeX yet. Once it has been formatted, you have a nice little subscript. X would be a little subscript. But this kind of looks ugly because this is designed to be, this is designed to be formatted code. It's not designed to be like programming language. So that's the syntax for try to do next or don't do anything. Now that we've got this syntax, we can actually add another piece, which is this fairness. WF underscore X next. So what that means is you can stutter a few times, but make sure you try doing the next. Don't always pick the same thing. Try both of them. Okay? And that's called weak fairness. There's another one called strong fairness, which I'm not going to talk about. But weak fairness just means try things. When you come to a branch in the road, try both of them. Don't always pick the same one. Okay, so that's what that means. Now, if we add that, and here we add our weak fairness to our design, and we have our properties like we had before. With the weak fairness, if we run it, it does work. So we can have the stuttering and still prove that the various properties happen if we have weak fairness. So that's good. So because you're thinking it's going to ruin everything, but no, it doesn't actually ruin everything. Weak fairness, you need to use this quite a lot sometimes. Okay, and these 4 properties, this is where TLA plus is not a programming language. You could not do this in Python or JavaScript. You couldn't say, are you sure that it will eventually become 3? Are you sure that it will never go out of bounds? Programming languages can't do that, but TLA plus can. Right, now let's move to the next one. Let's go back and model those producer-consumer ones, okay? And let's see if we can get some more confidence in that code. So here again, we have our producer, and it's checking whether it's writable, and if so, it can write. And the consumer checks whether it's readable, and if so, it reads. Okay, so each one has 2 steps. So how do we model this as a state machine? Well, there's 2 steps. There's 2 states and 2 transitions. So the first state is it's ready to start the whole process. It's idle, as it were. The first thing it does is check, is the queue writable? Is the queue not full? And if it is ready, then I can transition into a state where, okay, I'm just about to write. I'm ready to write my thing. And we're not doing this, like I say, we're not doing this as an atomic operation because that would be too easy, right? In the real world, you can't always do it as an atomic operation. So the first thing is, am I ready to write? And then if I am in that ready to write state, then I can actually write something to queue. And then I go back to being idle, okay? So 2 state transitions and 2 transitions. So in a programming language, I would write the code like this. If the producer state is in the ready and the queue is ready, is less than the maximum, then I can assign the producer state to the next state. And then the second transition, I would say, well, if the producer is in the ready-to-write state, then change it back to the ready state and then also increment the queue size. Now, I actually don't care about the queue. I don't care what the contents of the queue are. I don't care about how the queue is implemented. All I care about is the queue going to get too full? Is it going to overflow or underflow? That's all I care about. So I'm just going to model the queue. It's just a model. It's not the real code, right? So I'm just going to model the queue as an integer. And every time I write to the queue, I'm just going to increment the integer. Every time I read from the queue, I'm just going to decrement the integer. And that's all I need to do. So that's the modeling I'm doing into this queue. I don't really care how the queue actually works. So that's the programming version. Let's look at the TLA plus version. So again, before the transition, the producer state is ready and the queue size is less than the max. Afterwards, notice the producer state with a little tick next to it. Afterwards, the producer state is now in the can write and the queue size is unchanged. You have to say for every single thing, you have to say what happens to it. And in this case, for this one, nothing happens to the queue size. That's very important. Now, what about the write transition? So the write transition is assuming that before the producer state is ready to write, and afterwards the producer state goes back to being kind of idle. And now afterwards, the queue size is queue size plus 1. So I've just incremented. So this is how you would write this stuff in TLA. So it's not quite the same as the programming thing. It's all, notice this is a giant predicate. Everything is an and an or. Right? I'm not really doing any kind of calculations. So these transitions are only available. So for example, if the queue is full and a producer is in the ready state, the first transition is not available. So the model checker can't choose that transition because it's not available to choose, because it doesn't meet the requirements. Right? So think of these things as predicates, right? They always return true or false. It's not assignments. It's if the preconditions are true, then it can use this transition. If the preconditions aren't true, it can't use the transition. So if the queue max queue size was 0, that would be a deadlock, right? The producer could never transition between states, and the consumer could never transition between states, and the whole thing would just be a massive deadlock. So if you have a 0-length queue, then you've got a deadlock. So. Now, the producer action overall is a choice between try to do the first thing, try to do the second thing. So we've modeled the producer action as a choice, something or something. Again, it's the upside down triangle. Now, we do exactly the same thing with a consumer. This time it's reading from the queue. There's 2 different states. There's 2 different transitions. So we check, the first thing we do is check whether it's readable or not. And the other transition is we try to read. And when we read, we're just decrementing the queue. You can say queue size is -1. We're just popping from the queue there. And again, all the possible consumer actions is we either do the first transition or we try and do the second transition. Right, so that's the consumer side done. Now let's put it together into an entire system. I'm just going to put the entire piece of code on the screen here. So this now is all the producer side of things here. This is all the consumer side of things here. And finally, all the possible transitions we can do is either we can try doing a producer thing or we can try doing a consumer thing. That is everything we can do, right? So what's nice is we get non-determinism for free. Like if I was trying to model this in code, I'd have to have threads or I'd have to have actors or something, right? It'd be kind of tricky to model this. But in TLA Plus, it's just a choice. It's like when you're modeling, sometimes do the producer thing if you can, sometimes do a consumer thing if you can, and you can alternate between them. The model checker will try all the possible combinations of doing these things. So it's just do one or the other. And now we've got non-determinism because it will automatically, every time you have a choice, it will try them both, Now, do we add stuttering? Right? Should we add some stuttering where nothing happens? Maybe. Maybe not in this case. Maybe this is a case where you don't want to have it. But if you did have it, that would be an example where the consumer just stops working. So if the consumer stops working and doesn't do anything, does the producer keep adding things to the queue and overflowing the queue? Does your code check for that? So maybe the consumer's just not working, just taking time off for a couple of minutes and having a coffee break, Right, now, what are the temporal properties? So the most important one is it always within bounds, right? So is the queue size non-empty, well, sorry, greater than or equal to 0, and is the queue size less than the max? All right, so it's either that one or, sorry, and, see the and or stuff. It's either, it must be greater than or equal to 0, and it must be less than or equal to the max. And then we have the angle brackets, sorry, the square bracket, which means it's always true. So this predicate where both of these things are always true. Now, if we run this script, we don't get any errors. So that means with one producer and one consumer, this design works. All right? We have confidence in this design. Now, I think that when I did this, the first poll, it was 50-50. Some people thought it wouldn't work. Some people thought it would work. So with a single producer and a single consumer, yes, this actually design does work. We don't need to guess. We're actually doing the model checking. So if I revisit this screen that I had before, and I go to the next poll, here we go. So now how many people are confident that the single producer, single consumer one are, oh, everyone's confident. Okay, very good. Yeah, so it was 50-50 before, and I think the confidence level is much higher because I've run this little tool and it's checked everything, and I'm pretty sure that it's not broken. Some people are still not confident that it's correct. So I don't know, how would I persuade you? I would just take you through this in more detail and go through the model checking in more detail. But the answer is this actually is correct. So, right, let's keep going. Now let's do the multi-version one with 2 consumers and 2 producers or more than one. And this is why we need the plus in TLA+. So the plus is mostly set theory. And again, TLA+ uses a mathematical type of set theory. So for example, in programming, if I were to say, given a set, find all the elements that have this certain property, we would say something like set.filter, right? Something like that. In mathematical terms, we'd say the elements in the set such that this predicate is true. So we'd write it in a mathematical way. And in TLA+, we write it that way. We say curly braces, E/in, so just, again, well, LaTeX is going to format that as a little, Greek E, such that this predicate is true. So basically, TLA turns this into like nice mathematical notation. And again, if I'm saying, is there any element in this set which has this property? In programming, we would say something like set.ne, probably, I don't know. But in TLA+, we'd say, does there exist an element in the set such that the predicate is true? So that's how you'd write it in TLA+, and it gets converted into the mathematical formatting. Like when you run it through LaTeX, it formats it the other way. So there you go. Okay, so when you see that stuff, that's what's going on. All these slashes, that's the LaTeX formatting. Okay, so we need, since we're doing 2 producers, 2 consumers, we have a set. No longer just one, no longer just one consumer. So now we're going to need the set part of TLA+. So here's a set of producers. We have 2, probably good enough. P1 and P2, and we have 2 consumers, C1 and C2. Right, now how do we need to change our spec to work with multiple producers. So first of all, we need to initialize everything. So we're going to initialize the producer state to be, every single producer is in the first state, in the ready state. Now you can think of this set is actually like a dictionary in Python or something, or a map, especially a bunch of key value pairs. So in Python, I could have written P1 : ready, P2 : ready. It means they're both ready. In TLA+, you don't use that syntax. You say the set every P in the set of producers, you assign it to ready. Okay, and the same thing with consumers. So these states are, like I say, think of them as dictionaries or maps. They are not just, they're sets of key value pairs. Okay. Now, let's do the writable side. Now, this time we're parameterizing by a particular producer. So this particular producer, for this transition to happen, this particular producer has to be in the ready state, and the queue has to be less than the right size. And now afterwards, we're updating the state. Now, this dictionary, every single thing is the same except for this particular producer is now changed. So the syntax is kind of weird. You say the producer state is exactly the same except that this particular producer is now in the next state. But all the other ones are unchanged. So that's why you see this kind of except syntax. And let's look at again, I'm parameterized by producer. We check the state for this particular, so this is a dictionary lookup for this particular producer, and this is like updating the dictionary. This is the TLA way of updating a dictionary, rather than just assigning to the key. And now we're going to do the write in the same way. Again, it's got this thing where you update the dictionary for this producer. Now, we've got a whole bunch of producers. We can't just say do one or the other. What we're going to say is find any producer where we can do either of these actions. Like some producers might be in the middle of reading, writing, some of them might be idle. We're just going to pick one at random, try and find one that we can do a transition on. And again, we'll take turns. Because it's fair, we'll try each of them, right? So that's how we do that. Same thing with the consumer, it's exactly the same kind of thing. I'm going to start whizzing through this. Like I say, don't worry too much about understanding every single line of code. I'm just trying to show you the overall concepts of how TLA Plus would model this kind of thing. But again, we have a kind of a dictionary for the consumers, and if this particular consumer is ready, we update the dictionary and assign this particular consumer to ready to read. And the second transition is the same way. And then the consumer action in general is, does there exist a consumer that we can either read or, or check the readability for? So try and find a consumer that has a valid action that we can do. Now, if we run this script with 2 producers and 2 consumers, and that same always in bounds property, what do you think happens? First of all the possibilities of one is reading and the other one's writing, and this one, then there are 2 reading at the same time, and this one's, all those possibilities, the 38 combinations just with 2 producers and 2 consumers. Way too much. There's no way we can do a code inspection for that. Now, of course, this does not work. Okay, we are very confident that this design does not work. So when I polled you before, I think some people thought it might work. It's like, no, this does not work. Definitely doesn't. And some people weren't confident. Like, I am 100% confident it does not work. So we're not guessing. So how do we fix the error? Well, TLA Plus does not tell you how to fix it, right? You have to think. You have to find out what is the right way to model a producer-consumer. However, what it is good is testing the fix. So let's say I'm going to use a semaphore, or I'm going to use a mutex, or I'm going to use whatever it is that I think would fix this problem. I'm going to add the semaphore logic into my model. I'm going to rerun the model and see if it works, right? So if I rerun the model with semaphores and it works, I'm pretty confident that I can then go and code this with semaphores. And I got my semaphore logic right, which is always kind of tricky too. So you've got a lot more confidence that the fix will work or not. Maybe I got my semaphore logic wrong and it doesn't work. So either way, I've got some confidence there. So this is 50 lines of code, and we have a lot of confidence either way on the design. So it's definitely worth doing, I think. Now, okay, last bit, which is TLA modeling. How are we doing on time? Using TLA Plus to model zero downtime deployment. So this is a real-world example of if you're doing DevOps and you need to, do a zero downtime deployment. So I'm going to go even faster here. So again, don't worry too much about the details. But I just want to kind of show you that TLA Plus is a great tool to improve your design. Because what we're going to do is sketch the design. I'm going to, let's try it this way. We're going to check it with the model checker. And the model checker is probably going to say, no, you got it wrong. We're going to fix it. We're going to try it again. And the model checker will say, no, you still got it wrong. Fix it, try again. And when the model checker says I got it right, then it's like, yeah, now I'm pretty confident that my code is good. Okay. So I'm going to steal this from Hillel Wayne, who is a TLA expert, and I'm going to talk about him later on at the end of the talk. So how are we going to, let's come up with our model. Okay, we have a bunch of servers, and each server is going to be upgraded from version 1 to version 2. But here's the problem. Each server goes offline during the upgrade, right? And we really want to make sure that there's always a server that's online, right? That's really critical. And here's another thing. All the servers must be upgraded, because a really easy way to implement this is to never upgrade a server. Then they're always online. So we have to have 2 conditions. I mean, you have to be very careful. Having them always be online is easy if you never actually bother to upgrade them. So you want to make sure that at the end of this process, every single server is at version 2. Right, so that's the extra little kicker there. So how do we model this as a series of state transitions? Well, we're going to have 3 states and 2 transitions, right? It starts off, it's online, and it's in version 1. And then we start the upgrade, and it goes offline. And then we finish the upgrade, and it goes back online, and it's now at version 2. Okay, that's our entire model. And then once it's at version 2, it can keep looping forever, right? It's got that little thing where it's done, and we can just keep going. So we have to add that to stop it having a deadlock, right? So again, we're going to have a dictionary of key value pairs and the server state in this case. The server state for each server is going to be one of these three things: online v1, offline, or online v2. So initially, every single server is version 1. That's the initial state. Now, the start transition is we pick a server, which is in v1, and then we upgrade to be offline, that particular one. And then to finish the upgrade, we pick a server that's offline, and we update it to be online with version 2. So that's our start transition, and that's our finish transition. All right? And then doing any upgrade is we try and find, does there exist a server that we can upgrade? So we try and upgrade a server, which means trying to do either the start transition or the finish transition. And there's also another one which is done, right? All the servers are in version 2. So /a means for all servers in set of servers, the server state is online. And at that point, we can leave the server state unchanged. That's that little backwards loop. So we have an upgrade step and we have the done step. So the overall thing is either try doing an upgrade, and if we can't do an upgrade, try doing the done. Now, so let's run our script. There are 3 states. Now, with one server, there's 3 possible states. With 2 servers, there's 9 possible states. With 3 servers, there's 27 possible states. So for example, I could upgrade number 1 and upgrade number 2 and start number 3, or I could do number 1 and go through all things and then leave these alone, or I could do this 2 steps forward and this one step forward and leave this, it's complicated. There's all sorts of things, all sorts of combinations of things that you could do, and you wouldn't really be, some weird combination might happen that you didn't think about. So again, it's too hard to eyeball. So now what the temporal properties, so first of all, 0 downtime. So what does that mean? Not all servers should be offline at once, okay? And then the upgrade should complete. That means that at some point, eventually always, all the servers should be version 2, okay? So let's write that as a TLA code here. So 0 downtime means it's always true that there is a server which is not offline, right? It's always true that there exists a server such that the server state is not offline. That / equals is not equal. Instead of using bang equal, it uses / equal, okay? So it's always true there's a server which is not offline, okay, 0 downtime. Now, this eventually upgraded, okay? So it's eventually all the servers in the set of servers will have a server state which is version 2, right? So we've modeled that in TLA+. Now, if we run this script with 2 servers, we get this invariant. 0 downtime is violated. I thought we had a perfect algorithm here. So we look at the trace for the model checker, and it says at the beginning, S1 and S2 are both online at V1. We take S1 offline, and then we take S2 offline. Well, boom, now we're both offline. We've broken our constraint. Well, that was stupid. So how can we fix that? How can we fix that? Well, we'll add another step. Okay, we're going to add a fix, but are we confident that our fix will work? Let's see. So what I'm going to do is add another, for the start upgrade, I'm going to say you can only start upgrading if nobody else is offline. Okay, so there's my start upgrade. I'm going to add a new step. Does there exist another server where the other server state is offline? And if that's true, don't start an upgrade. Okay, so if somebody else is offline, you're not allowed to upgrade. So that's my fix for this problem. And now if I run the script this time with 2 servers, 0 downtime actually works. We guarantee there's no downtime because there's, if you can't start an upgrade if someone else is offline. So you can never have 2 people offline at the same time. That's great. Now the eventually upgrade fails. Why does it fail? Because of the stuttering. We haven't said, we can just say, stay in version 1 forever. Don't do the upgrade. How can we force the upgrade to happen? We need to add this fairness thing. Like, if you can upgrade at some point, you must upgrade. You at least try upgrading. Don't just stay in an infinite loop and never upgrade. Like, if there's at some point in the system where, everyone else is upgraded and you're the last one, you at least have to try it. Okay. So adding fairness then makes it all work. So that's good. Now let's add another condition. So this is good. We're sketching our model. We're playing around, we're getting confidence. Now let's add a more strict condition, which is that all the online servers have to be running the same version. They all have to be running V1 or V2, but you can't have a mix, because if we have a mix of V1 and V2, it's going to mess up our clients. So how do we model that? Well, first of all, we define a set of servers which are online. So we say online servers are the set of servers where they are not offline. Okay, that's easy enough. And now we want something which is always true. It's always true that for the set of servers which are online, if you pick any two of them, they will have the same server state. They'll both be V1 or both be V2. But they'll not be different. So that is our same version requirement. That's our constraint for same version. So if we run the script with the new property, boom, we get an error. And then if we look at this trace of what's happening, it says, well, first of all, they were both V1, and then S1 went offline, and S2 is still at V1, and then S1 got upgraded to V2, and S2 hasn't even started upgrade. So now they're both at different versions. The first one is V2 and the second one is V1, and we didn't meet our requirement. So we have confidence that that fix did not actually work. Okay. Now how can we fix this? I'm going to suggest we use a load balancer. So the load balancer is going to only point to V1 servers or only point to V2 servers, and you're not going to mix them in. So from a client's point of view, I'm only going to see the same version. So how do we implement a load balancer in this thing? So the initial state is now I'm going to have a new thing called a load balancer. And again, from the model point of view, I don't actually need to implement a load balancer. All I need to do is say, is it version 1 or version 2? So it's just going to say, am I pointing to version 1 servers or version 2 servers? How that actually happens in the real thing, I don't care, because this is a model. I'm just doing the very basics, right? So the online servers are now slightly different. If the load balancer is V1, the online servers are all the ones which are V1. And if the load balancer is at V2, the online servers are all the ones which are at V2. So that's how we would model our load balancer. Now, obviously, the real thing is a lot more complicated, but from a model, this is, we're trying to keep it simple here. Now, when can the load balancer switch from pointing to V1 servers to pointing to V2 servers? Well, it can switch when one server has been successfully upgraded, or you could say maybe 2 servers, but for this case, if any server upgrades to V2, I can switch the load balancer to point to it. Okay. So we now have a new step in our finish and upgrade, which is if an upgrade is successfully finished, the load balancer can now be version 2. So now if we run the script with the load balancer, the zero downtime works. You never have any downtime. Everything is eventually upgraded, and the same version works. So if I just run the code, I'll prove it to you. Go back here. Zero downtime. We open up the model. And you can see here is the code, by the way. So, it's like 50 lines of code. It's not that much. Here are all our properties. Zero downtime, eventually upgraded. Same version. Right? We take this model, we run it. And it runs it, and it's checking all the possible states. And no errors. Now, if you said I want the load balancer to always have at least 2 servers, which you might want to do, then you'd have to have, I've only got 2 servers in here, so it's never going to work. But if you had model it with 5 servers, and you could say at least 2 have to be up at all times or something, you can see you could extend the model to do that kind of thing really easily. Yay. So, who thinks this algorithm is now right? I just ran the model checker, and it didn't give me any errors. Do you think this algorithm is right, the algorithm I just showed you? What is your confidence in the design of this zero downtime deployment process? Like the first one didn't work, and then I added various fixes, and I've run it through the model checker, and this is good. So it looks like there's a few people who are not 100% confident. Yeah, some people are not confident either way, but it's a lot more than it was at the beginning, where 100% people were not confident at all. So the people who are not confident either way, or the people who don't think it's correct, obviously we have to go into more detail of this, but I think I could, if I spent a couple of hours with you, I think I could convince you that this actually was a correct algorithm. Maybe not, maybe I'm wrong, maybe I missed something. Okay, so that's our sketch complete. And again, we just only spent 10 minutes on it. So you can actually think of it as sort of agile modeling, right, for concurrent systems. So we're doing some sketch, we're playing with some things, we're finding out certain things don't work, certain things do work. It's all about getting confidence. So the most common question, and I'm sorry a few minutes over, I'm just finishing up now. The most common question people say, how do you convert this to code, right? The answer is it doesn't convert to code. It's not a code generator, it's a model. Just like if I have a wooden model of a building, it doesn't magically sprout and turn into a giant skyscraper, right? It's a model. It's a way for thinking about the building, but it's not the actual construction process. So it's all about having confidence in the design before you start writing code. So that's model checking for you. Okay, so hopefully you can see that TLA Plus is not actually that scary. The syntax looks a bit weird, but the whole thing of model checking is just a nice thing to have. It's not that scary. It's really nice for sketching things. In a few hours, you can actually play with it and get some confidence in your design. I would say if you're doing anything with concurrency, it's really, really important. I actually would say it's essential. And it's just another tool in your toolbox. You know how to do unit tests. You know how to do type-driven design or whatever, or TDD or whatever. It's like, these are just tools you have. It's another tool in your toolbox that I think as a professional developer you should at least have some knowledge about. Now, TLA Plus is a really big system. It can do way more than I just showed you. I'm just doing a tiny, tiny piece of what it can do, but I'm not even going to get into that. So if you want more information on TLA Plus, there's a home page, there's videos, there's books, there's papers, there's a long book by Leslie Lampert. It's a bit mathematical, but it's not actually that hard. But if you want a more programmer-friendly thing, check out stuff by Hillel Wayne. He has a book called Learn TLA, he has a website called Learn TLA, and he does trainings for programmer-centric trainings. So if you are involved in concurrency and you want to learn more, obviously a more deep, in-depth thing, check him out and he'll do a training for your team. So I'm going to put the slides and video up here on my website, f#fundedprofit/TLA+. If you want more about property-based testing, I also have stuff about that. I have my book, which people seem to like, and you can contact me on Twitter. And thank you very much. I'll be here. I don't have time for questions, but I'll stick around here if you've got questions for me. So thank you very much for coming.
I'm jealous now. Everybody's eating and I'm hungry. I'll close it off now. That's about it. Awesome. Well, thank you all for choosing me. There were lots of options, and I'm hoping you chose wisely. We shall see. So, this talk, just in case you're in the wrong room, we're talking about building operable software with TDD, and the obvious hook of not the way you think, so hopefully there'll be some surprises in there. Okay, so my name is Martin Thwaites. I go by martin.net in everywhere. I am first and foremost an observability evangelist. I'm also a developer advocate for a company called Honeycomb. Socials are there. We have a booth just outside the door. Come see us, blah, blah, blah. They pay for me to be here, so come see us. Awesome. So what we're going to talk about today. We're going to talk about operable software. We're going to talk about what my definition of operable software is more specifically, because that's all that matters. We're going to talk about how we test software as developers. We're going to look at something called outside-in testing, what that looks like, and we're going to talk about how we can use observability and how does that fit in to that operable software lifecycle. Now, before we get to that, I want to talk a little bit about the motivations for this talk. Before I started working with Honeycomb, I spent a couple of years working for a UK bank building a new banking software. And one of the things about banking software is it needs to be accurate and correct. Apparently, giving somebody the wrong balance and approving things when they shouldn't be approved is a bad thing. So basically, being able to say that my code is correct on the bottom layer isn't good enough because a system is bigger than your class. And we had to spend a lot of time thinking about how we test software. We wanted to go full CI/CD. We wanted to have really continuous release cycles. And a lot of that goes against the idea of resilient software, the idea of software that doesn't change. You know, banking industry is, we'll do 3 releases every century. And that was a bad thing in agile software, in building software that is resistant to change, all of that kind of stuff. It just isn't a thing in banking. So we spent a lot of time building out approaches and that kind of stuff. So what I'm going to talk about today is not theoretical. It is something that we spent 2 years building and is running in a production environment. Well, production-like environment. They're not actually taking payments yet. But it is running in an environment, and it is running cycles, and it is something that works. So hopefully, I'm not going to say dumbed this down, but what I've done is I've tried to simplify this into some of the component parts. But do take away from this that it is something that works. Okay, so what do we mean by operable software, or more specifically, what do I mean by operable software? Now, first and foremost, it's software that's built for production. Now, I hate to say this. I don't care whether it works on your machine. It's not where customers are going to be using it. When we build software, we build it to be run in production. That's the thing that we're thinking about. We're not thinking about how we can run an emulator locally. That doesn't matter. What matters is, does it run in the production environment when customers are using it? So, what does that mean? Built to run in production. It's built to run on production servers. It's built to run in a production environment. It's built to run with multiple regions. Those are things that you're building your software for. It's also built with live operations in mind. Now, some of you may come from the environments in the past where you'd write your code, you'd throw it over, and somebody else would then have to deal with it, because that's not your job. They deal with it. Unfortunately, everybody's ops now. Everybody is ops. We are working in a DevOps culture where developers and operations teams come together. You need to build your software with the people who are going to run it in mind. Sometimes that's yourself. Be kind to your future self. Because past Martin is, let's be honest, a little bit of an arsehole because he put a lot of problems my way. Future Martin, we can leave the stuff for him because he's fine. Okay, now the other thing is built for fast recoverability. There are things called the DORA metrics, which Google built on the DevOps reports. which it mentions something called MTTR. It's falling a little bit out of favor right now, but it doesn't mean that it's not something you should be working to, which is the idea of how do I build things that recover fast from failures. And all of that leads to the idea that my application needs to emit robust telemetry signals, whether that's metrics or traces or, God forbid, using logs. But that is something that you need to be thinking about, because in production you can't attach a debugger. Has anybody tried to attach a debugger to a live running IIS instance? Yeah. Did it go well? Yes. For those that don't know, whenever you attach a debugger to a live running process, it stops all the threads. Every request just halts. It's not a pleasant day. Okay. So when we talk about operable software, what do we mean by software? Now, the traditional definition is the code that you write that does the thing that the business wanted. Unfortunately, that isn't the case. It's everything. It's the application you write. It's the tests that are part of your code. It's the pipelines that you've built that test, do security analysis, and deploy your code into production. It's also the infrastructure that's been built for it. That might not be you who's built that infrastructure, but it's still part of the software, because the production environment is part of your team that delivers value into your customers. That is part of it. You can't host your application without infrastructure. I mean, that's just shipping your own machine, and that never works. So, but the other thing is it's your observability tooling. It's the live operations team that need to know whether your system is up, whether it's functioning. All of that is part of the software that you're building. So when you're building software, if you're not considering these things, you're missing out. You're neglecting part of your software. Okay, so let's talk a little bit about testing. Let's talk a little bit specifically about TDD. So what do we mean by TDD? TDD has been conflated over the years. I mean, it's very abnormal. We don't take terms in IT and use them for different things ever, do we? No, that's not. We don't take a well-known term like, I don't know, DevOps, and distort it into another thing. TDD was a very, very basic concept. Contract-first development. Develop your contract, develop your tests, do the thing. It's also red, green refactor. It's the idea that you write a test that fails. You make the test pass. You can refactor your code, and then it fails. And then there's a big cycle that goes through. But the main basis of TDD is you write tests first, and then you write the implementation. Unfortunately, TDD has not meant that to a lot of people. And one of the things that we found while writing this approach was people didn't like TDD. They thought it didn't work. It takes too long. And when you dig into it, it's because what they're doing is they're mocking all the things. The .NET developers among you will get the reference there. But they will mock everything. They will have a class with 17 dependencies, all of them with mock. And they will test individual methods. I've got a method that I've mocked all the dependencies for. I will test that method to death. Now, nobody cares about your 4,000 unit tests. I know you like them. I know you spent a lot of time on them. But nobody cares about the level of your unit tests. What they care about is your system as a whole. So why do we do TDD? Because if it has so many constraints and it's so bad, why is it that we're doing it? What are the benefits that we're trying to get out of TDD? Now, TDD is known to improve the design of contracts. I put methods on there. Might not be methods, it might be API contracts for your SDK. It might be API contracts for your HTTP APIs. But it's based on improving the design of your method contracts, because you write a test and it passes that test. You should do the smallest thing that makes it pass that test, which means your interfaces evolve, your classes evolve. It also helps you improve your understanding of the code base, because you're using these methods. You're not writing a test that does a very, very small thing. You're writing something that's actually using these APIs in the way that other people are going to be using them. It also documents your code. If you're writing these tests well, your tests are going to actually be documenting your code as you go, because you've wrote a test for a business outcome or a particular class that you want it to do something. If you've wrote your test properly, you've actually got documentation already, which means you never need to go into Confluence again. Okay, but what's the bad? And the bad here comes from what I believe is the way that a lot of people run TDD in their teams. So it's normally written, these tests are normally written in the absence of any consumers of this application. You'll get a business requirement that says, let's do a transaction. And what you'll do is you'll write a transaction class. And then you'll write some methods on your transaction class like add amount. That's not what your consumers have asked for. What you're doing is you're assuming what that class needs to do, and then assuming what you're going to use that in, and then assuming. And because of that, all of those tests become quite brittle to change. I've added a new parameter, I've changed the parameter. Well, I'll just delete all those tests and write some new ones. That's bad, because now all of a sudden you don't know whether your system still works, because you've deleted all the tests and started some new ones. Which means that you then end up with manual testing from the outside in and all of that kind of stuff. Okay. Let's talk a little bit about component testing. Everybody's seen this meme, I assume? Where what we end up with is lots and lots of unit tests, 4,000 unit tests on a single class, and it's bulletproof, that class. Absolutely. That drawer was probably the smoothest opening drawer that you've ever seen for about 25%. But that's where integration tests come in. Now, integration tests over the many, many, many years, like with all the other things we've been talking about, have been misconstrued and changed, and they mean 17 different things to 17 different people. So what I like to call these that I'm talking about is component tests. They all fall under a banner of something called developer tests, which is something that Ian Cooper's been pushing for quite a while, which is the idea that these are tests that the developers write to ensure the completeness of their code. The completeness being correct, accurate, does the right thing. These are tests that you write to make sure that your code works. So outside-in testing is part of what I consider the component testing workflow. And what that means is we're working from the outside of our application. We're working from where consumers live. That could be your HTTP API, it could be your SDK that you've built, but where are your consumers? The thing that you deliver as a package, as a thing, how do your consumers use it? So we're working right from the outside all the way to the inside. Now what I found is the majority of the time you can actually stay 100% on the outside, which is great, because you don't need to be on the internals. What we're doing is we're testing the inputs and outputs. And I'm obviously using the HTTP vernacular here because I'm guessing that I would say over 50% here write web applications, whether it's APIs or that kind of stuff. But that could be just using your APIs for the inbound and outbound, your SDKs. What it means is we're testing from our consumers or users. We're testing what our users will do. They will add something via a post. They will go and get something via a get. Well, let's do the post and do the get then, and make sure that works. But we're also testing specifically what the businesses have asked us for our users to be able to do, which means that we're really close to only delivering what we need to do. Now, you might have delivered this class with 4,000 unit tests that has 15 methods on it, and those methods are a thing of beauty. And then you look at the actual usage in your application, there's only one of them used, and they use one property from that object. You've done too much. Running from the outside in means that you're only doing the things that you need to actually build, which means you go faster. So, benefits. Business requirements first. All of a sudden, you've designed all your business requirements. You've satisfied all your business requirements. There's no need for that further layer of testing. If you've got tests that prove each individual step of your application, you've done your business requirements. You end up with better readability because you're not using your internal business knowledge. You're not using a test that says transaction service returns approved No, what you're saying is the transaction was approved. The transaction was cleared. Authorization was failed. You're using the business terms inside of your tests, which means that they are more readable. Use English language. And we'll go through how we can actually write some of these tests using some business language. But we're also testing the whole application, all of it. We're testing our serialization. We're testing the way that our startup works. All of that stuff is being tested when we test from the outside all the way in. One of my favorites, no stubs or mocks. We don't need them because we're testing the real thing. My absolute favorite, though, you get 100% code coverage. I know it's a vanity metric, I do. But what's great about testing from the outside in and testing for your business requirements is if that code isn't covered by any tests, you can delete it because it's not used. If it is supposed to be used, guess what? You're missing a test and you need to add a test. So you get 100% code coverage. It's awesome. Okay. A key part around using this approach for me and the teams that I've worked with is making tests readable. Now, what do we mean by readable tests? I mean test names that are descriptive. Your compiler does not care how long your method name is. It really doesn't. Put actual English in there. Tell me what that test is actually doing, so that when I'm looking through those tests, I can actually look at the test name and say, yeah, that's what it's doing. However you do that, there's no hard and fast rule. I'm not going to say you need to segment it into 3 sections with an underscore. Generally how I do it, but that doesn't matter. As long as I read the method name and it makes sense to me, let's do that. We build things that are reusable. We abstract context into reusable methods in our tests. That's something that I see every single person miss that I work with. If you're writing tests, you don't have to write a test that's 72 lines long and does everything against the raw objects. You don't need to do that. Abstract that away, give it context, give it a name. Say that I'm going to go and get this thing, not go to the object and grab that thing out. So we're abstracting away implementation that doesn't matter to us in our tests. It matters that we do it, but it doesn't matter that somebody sees the 17 different lines of code that do that particular thing. Maybe in one test it might be useful, but it's not useful in all of them. But we also use our domain language, what the business understands, what you're understanding from your business requirements. Because if you think about what the business is doing, you can then actually look at, somebody goes, it fails when we do an authorization. You don't have to understand how an authorization works in the system. You can go through the tests and say, where are the authorization tests? Here are the authorization tests. Oh, and it fails under this scenario. Well, this test says that's a specific thing. Great. I can get right to the tests. I can write more tests, and then I can fix it. The other thing is more tests, not more asserts. This is probably the most controversial part of it. People like to add 17 different asserts. Equivalent to should not be used ever. I'm sorry. You should be writing more tests because then your test names are giving you the context. You've got specific tests that are failing that give you that context of why that thing failed. When you've got one test that has 17 asserts on the bottom of it, guess what? It stops at the top one. Yes, you can make it work with lots of them, I know, but generally stops at the top one and you don't get all the other ones. It'd be better if you saw all the tests that are failing. And that's the elephant in the room. Isn't this just writing BDD? Yes, it is. It's not writing cucumber tests, it's not writing spec flow. But yes, we are defining behavior, and the behavior is what's driving our design of our application. But we're not writing given when thens. We're not building out a spec flow framework with steps that are only used once. What we're doing is the original definition of what BDD was about. We're talking about the behavior of our system, and we're having that drive the design and drive the development. So yes, it's BDD, but not that BDD. I have opinions about Cucumber and SpecFlow. Come around the booth afterwards. We can rant. Okay, so we'll look at a bit of code. Now this is using .NET. This same approach works with majority of languages that can run up an in-memory web server for your application. In this one, we're using something called the Web Application Factory. It's built into .NET and allows you to spin up your entire ASP.NET Core site and be able to hit the APIs correctly. This is a test you might write, which it's pretty simple. It adds a to-do and makes sure we get a valid request back. So I send a valid to-do item over, and I get an OK response. Pretty simple. But what I've done here is I've defined here, there's a business requirement. I need to add to-dos to our system. Great, OK, what does a to-do look like? Well, it's got a title and description. Great, I've wrote a test. That will actually compile. Whereas if you write this against actual typed code, it's not going to compile first time because those things don't exist. And what we're doing is, all we're doing is asserting that we get an OK back. Because that's what the business requirement said. I need to be able to add a to-do. They've not said they need to be able to get it. One of my favorite things about this approach is you can be really, really pedantic with your BAs. When they go, I need to add a to-do, it's like, great, I've added to-do. That actually proves you can add a to-do. I don't need a database. Don't need to store it. I've got an endpoint that allows them to add. It's great. Which means that your BAs start to get into this idea of thinking about exactly what it is that they need. And over time, you build up that relationship with your BAs where they actually think about what it is that they need. So, how do we make that a little bit better? Well, the first thing I talked about was removing implementation. For that test, I don't care that there's a web application factory. That's pointless to my test. This is called evident testing. So everything in that test should be relevant to the test. Everything else should be abstracted away. So obviously what I've done here is, in the background, I've created the web application factory and just made it accessible under a variable called API. Which means that my test now, if I say add to do with valid request, well, it just hits the API with a valid request. So that's already a little bit cleaner because there's a load of implementation details that are not relevant. So that's an easier test to read. But we can do better. I'm assuming that the majority of people have heard of AAA testing. Arrange, act, assert. Well, let's spread this out a little bit. Well, we'll create a to-do item. So that's our arrange. And then we'll act. So we'll throw the to-do item against the API, and then we'll assert. So that's, again, making this just a little bit more readable, but we can go even further. Because for this test, I don't need to know what the parameters are of that to-do item. What I care about is I've got a valid to-do item. So I can abstract that away and give it an actual context of a name that says, go and get me a valid to-do item. Because again, the shape of that to-do item isn't relevant to the test. Which means that all I'm doing is go and get a valid to-do item, throw the valid to-do item against that. That's now something reusable. It's a reusable action. Because now I've got another test. So now the BA's come to me and said, well, when I add the to-do, I need a unique ID for it. And that it needs to give me a valid ID back. Like, great, OK. Now I've got another requirement. But you can see those first two lines are exactly the same. All I've done is I've got a different test name, which tells me exactly what it is that I'm trying to test. And I've got some different asserts. There's better ways to do this. Obviously, you could then start to abstract some of your asserts out of that, make those asserts a little bit more context-driven. But what we're ending up with is something that's just a little bit more easy to read, a little bit more separated, so that we can start to act on individual tests and we can just add more tests. We got so many times people saying, I don't want to add more tests because it's more work. You know, I've got to copy 70 lines of code. Well, that's the wrong reason not to write tests. What you want to do is make it easy to write new tests. What these approaches give you is something really, really easy in a framework that somebody says there's a bug in production. And what you've got is a Lego set of different tests. They go, oh, this is broken. It's like, right, well, grab one of those, grab one of those. No, no, no. Oh, yeah, it's broken. Oh, yeah. Oh, I can fix that. Great, fixed. Job done. And now I've got a test for it. Guess what you've done? You've wrote a test first, and it failed, and then you fixed it. Guess what that is? It's TDD. Okay. So then we can go for persistent checks. So now they've come back to us and said, well, when I add the to-do, I need to be able to get it back. Like, great, okay, now I need a database. But up until this point, I didn't. Like I say, I love being pedantic. So this is now, right, we need to add a database to this. But again, what we've done is we've abstracted away context. Now, if you read what this test does, it should be self-evident. It says, create a valid to-do item. Now, you could say, add a valid to-do item to the API. Whatever makes context important to you, whatever makes that understandable to people. But we've gone and created a to-do in the API. We've not gone to the database. We're not understanding the schema of the database and injecting something into the database. We're using the API here. We're essentially calling into the previous tests that created a valid to-do item. And what that's going to do is give us a valid to-do item back. And then we're going to go and get it from the API. Now, at no point here am I touching the database. I'm not reaching into the bowels of my application and understanding what columns exist in the database. I don't need to. I can run this against the API because that's what my users are going to do. If you've got users that are going into your database and inserting to-do items into your database, you need to have a real think about your applications and your users. That isn't what they're doing, so why is that what you're doing in your tests? Nobody cares when there's a bug in production and you say, well, I've got a test that inserts it into the database and makes sure it comes back. I just didn't test that I post it through the API and it comes back. Nobody's going to take that as a valid excuse. So why don't we have tests for that? Okay, let's recap a little bit about what we've tested there. We've tested our startup configuration. How many people have created a service class in .NET and had their 4,000 unit tests against their service class and then forgot to add it to dependency injection before it went into production? You're all liars. At least in Oslo, they were about 50% of truthful people. But that's what happens. People will write these tests, and the unit test pass. Great, ship it. And then it fails to start in production. And you're like, my unit tests are passing. And what you've actually forgot to do is just register that implementation against your service collection. The other thing we're testing is routing. We're testing that the API routes that you've put in there are correct. Because that happens as well. You get people who forget to put a GUID identifier, a GUID qualifier on some of their names. So the routing looks like it should work, but it doesn't, because another route takes priority over it. We're also testing serialization and deserialization. Because when you push stuff into your application via the API, it's going to do your JSON serialization and deserialization. Now, pro tip on this one is when you're using this approach, rewrite all of your classes in your test assembly. Do not reuse the classes in your main assembly. Because what that gives you is, if you have to change the classes in your test assembly because of something that's breaking in your main assembly, all of your consumers are going to have to do the same. And what you can actually do is put path approval checks inside of your commits that says if somebody's changed this, somebody else needs to look at it. So what you've actually got is contract testing built in to your application. If somebody changes the serialization method from camel case to Pascal case on the JSON objects, all your tests are going to fail. But if you use the same serialization classes, then you've got a problem. We're also testing model validation, required parameters, regexes, because we're going through the full HTTP pipeline when we do it. We're testing things like database interaction. If you're using Entity Framework, which this is an example that's up on GitHub that you can go and have a look at, it's using Entity Framework. It's using SQLite. Don't use the in-memory database because constraints don't work. But if you're using SQLite, you've got a database that you can use. So you're actually testing that the database interaction works, your foreign keys work. We're testing selecting of columns from the database properly, making sure that you're actually using the right column names in your tests, in your code. But we're also testing the customer APIs. We're not testing our classes, right down below. We're not testing those. We're testing our APIs, the things our customers are going to use, which means we're testing the business requirements, which means that we're testing only what needs to be tested. I don't care that your class returns an object with 17 properties on it if I only need one of them. And we're testing all of that. And like I say, if you do that, you end up getting 100% code coverage. Now, just before we move on to that one of the main objections that I get for this is it takes too long to run the tests. Because I'm running up an application, so it's going to take too long. Normally, that's people who haven't tried it. We have around 2,500 tests in that framework that run in 8 seconds. So anybody who says this takes too long has not tried it and done it properly. It takes time to build frameworks around it. Yes. It will work out of the box a lot of the time. You can reuse the web application factory. You can use different contexts for your database so that you get clean tests. Yes, it takes a little bit of work. It's not too slow, though. If you're worried about your test taking 8 seconds, I'd ask you how long your deploy is taking. Because I guarantee you it's not less than 8 seconds. But what can't we test this way? You know, I've sold you the dream. I'm sure you're all going to go away tomorrow or Monday and do all of this stuff, which is great. But what can't we test? So we can't test things like how the back end changes, but the front end doesn't to the user. Caching being one of the big examples of that. If I'm doing a get against my API, how do I test that caching works? Because I get the same result no matter what. If I'm not getting the same result, then my test's broken. I should get the same result. We can't test things like internal state changes, like audit logs, things like that. We can't test performance. Anybody who thinks they can test performance locally, come and see me, I've got a sticker. You're also not testing integration with cloud services. So you're not testing integration with Cosmos. You're not the integration with Dynamo, things like that. You can do that with this approach because you're working from the outside in. What you can do is you can switch out the implementation with the live implementation and rerun the tests. Maybe if you've got a branching structure, something like that, you run that test on your main branch when it's actually merged in, but you don't run it on every feature branch maybe, or the other way around. But because you're running from the outside in, it's literally a case of in your service collection just replacing your implementation for, I don't know, entity framework to something else. The other thing you can't test is configuration. So you can't test that your deployment pipelines have put the right key vault ID into the config so that it can access the right key vault ID. Or can we? And this is where we start to talk a little bit about observability. So all those things, yes, you can't really test them with the approach that we just talked about. But we can augment it a little bit in order to get some of those techniques in there. So we're going to have to talk a little bit about what observability is. And this is the definition from our co-founder who first coined the term observability in the context of software about 6 years ago. So it's about understanding and debugging unknown unknowns. It's about the ability to understand the inner state of our system by asking questions from the outside. That's the statement that I'm more interested in. We're writing observability into our applications, writing those telemetry things so that we can understand our internal state when we're in production. If we're writing operable software in a way that means that we can use it in production, well, can we not do the same thing with observability in our local environments? And that's what I set out investigating about a year ago. And we came up with this concept. I hate the fact that we use the term ODD. because what we actually turned it was observability during development, which is just really confusing. But the idea is, how do we use observability, or more specifically tracing? I wanted to call it tracing during development, but apparently TDD's taken, and we're not allowed to just augment names and use them for something else. But this whole concept, don't call it ODD, call it whatever you want, but it's the idea of how do we bring observability into our applications and our local development flows. Observability is an output, it's a side effect of our application. It's something that our application does. So why aren't we testing it? If it's important to us, why aren't we testing it? Observability can detect things like parallelization. You can know whether two things run in parallel or run in series. That's important in some scenarios. I have a few anecdotes that I can share offline, but one that I can share online is a friend of mine went into an organization and they had a problem that the startup of their desktop application was taking 30 seconds. And he went in, put some OpenTelemetry and tracing data in there and said, well, when you do this gRPC call, you're initiating the connection for everyone, so it's initiating the connection 20,000 times. It's like, no, it opens the connection once and then just sends all the data over. He's like, it doesn't, that's not what it does. It's like, no, it absolutely does. And he's like, but the computer's telling me that it doesn't, and computers don't lie. They only tell you exactly what they're doing. And then they went in and went, oh yeah, it's not. And turned 20 seconds into 200 milliseconds just by 3 lines of code of reuse the connection. So observability can tell you these things, and they're important in a lot of applications. The other thing it can do is detect code paths. It can detect if you go through, say, caching. If the caching code is called, you can tell if this was a cached version or a not cached version. But the key is, if it's important to you locally, for you to be able to write a test on your class about it, it's likely going to be important when it gets onto production and it goes wrong. It's likely going to be important that you know that that's where it went wrong in your application. What you really want is when somebody sends you a bug, what you want them to do is say, it was on this line here and it sent the wrong information. All right, I'll change that line there and commit it and push it. Like that's a really good QA who can come to you and say, it's this line of code, can you fix this line of code? Observability done properly with tracing, causality, all of those kind of things can really show you internally in the application what it does. So if that's important, why aren't we bringing that into our testing? Why aren't we bringing that into our application flows? So let's take a look at some caching code. For any future employers out there that may look at hiring me, I don't write caching code like this. This is an example. It's very basic. I wouldn't write it like this. So to give you an idea of what this is doing for those that don't read C#, which I'm hoping is a minority, what we're doing is we're setting a cache key. We're using a memory cache here to try and get a list of to-do items using that cache key. If that didn't return anything, then we're going to go to the database and go and get the to-do items, and then we're going to return the ones from the database instead. The methodology there is pretty sound. That's how you do a lot of things in applications. You'd have sliding expirations, all that kind of stuff. But that's pretty much what a cache code would do. Now the thing is, both the line that says return to-do list and the one that says return all to-dos, they're both returning the same information. So external to the application, I don't know whether it's actually got the data from the cache or I've got it from the database. So when I write my test, that says, well, the first call needs to come from the database. I don't know how to write that because I've got nothing to assert against. Whether it comes from the database or it comes from the cache, it's going to be the same. So how do I do it? Yes, I could write headers to it, but those can be messed up. And this is where something called OpenTelemetry comes in. So OpenTelemetry is the number 2 project to come out of the Cloud Native Compute Foundation behind this little small project they did called Kubernetes. Don't know whether you've heard of it. But it's the number 2 project to come out there. It's becoming the de facto standard in how we do telemetry signaling. Telemetry signaling being, at the moment, tracing, metrics, and logs. It's completely open source. It's run by a lot of the vendors. The vendors have been building this as an open source project. But one of the really interesting things about it is something called the in-memory exporter. Now what that means is, and especially in the .NET world, your production application does not need to depend on OpenTelemetry in order to get telemetry out. Because a lot of organizations will go, well, we're not ready to take OpenTelemetry into our production application yet. There's some problems. We don't really want to do that yet. But because .NET uses something called activity, activity has been built into .NET since, it's either .NET 2 or 3.5, and it's changed a little bit since, but it's part of the BCL. So you can instrument your code with activity without thinking about OpenTelemetry. And then you can actually bring OpenTelemetry into your test, because largely organizations don't care what frameworks you bring into tests. They care about what's deployed to production. And what we're doing here is we're creating a tracer provider inside of our web application factory. Not inside of our code, not touching the production code here. But all we're doing here is saying, listen to this particular activity source, bring in the ASP.NET Core instrumentation, which will give us spans for requests. And any spans that are created, any activities that are emitted from your application, stick them in this list. So we've got a list now. Got a list of individual spans that have been created as part of our test. Pretty cool. And then what we do is we add it to our services. Because when you're using the custom web application factory, you can add additional things to your service collection that are only present when your tests run. Now, because I've added this as a singleton like that, that means it's going to start listening to all of the activities that are run and created during my tests. So that's pretty interesting. We can do that. Another pro tip, when you're writing your custom web application tests, run this clear providers. It'll save you a ton of time in your tests. Because if you don't and you've accidentally enabled console logging, your tests take a hell of a lot longer because it outputs all of your logs to the console, which takes a lot more time. That's a bonus. Nothing to do with what we're talking here. I don't charge extra for that, just to be clear. So what does our code look like now? Well, we wrap our database call inside of a span. We get the added benefit that we now get to know how long it takes to get things from the database. That's something that's interesting in our application. It's not something we're going to test against because we can't test performance locally. It's pointless because we're running against an in-memory SQL, and SQLite will be a lot faster or slower depending on what you're doing. But we're going to wrap it in there and give it a specific name. That's it. It's not particularly complicated, but now what we can do is in our test, we can say, well, find all of those collected spans that have been created and tell me, did it contain one that had get to-do list from the DB? Well, this test is making sure that the first call calls the database. I actually wouldn't write this test because that's pointless. Because we know that the first test will only pass if it's got data. So kind of pointless test, this one. The second test, though, is the inverse of that, where what we want to do is make sure that the second call does not touch the database. And what we can do there is, well, run our first get, clear out all the spans, run our second get, and make sure we don't have something called that. So now what we've got is a really actually useful test that tells us whether it's going to go to the cache or not, or whether it's, more specifically, whether it's going to call the database or not to get that data. Obviously, very, very simplistic test here. There's a lot of nuance that will be in your application that you'll need to throw into that. Do you use iDistributed cache, and you have to use the in-memory version of distributed cache? Do you have to make sure things are serializable? That's another thing that people miss when they try and use iDistributed cache, which needs serializable entities, whereas in-memory cache does not. And that fails when you put the actual real Redis cache in place, but it worked fine in your unit tests. Nobody cares. Okay, now the other ones that we did, we started to refactor for readability. So now I can take that first test where it calls the database, and I can make sure, well, collective spans has span with name. I've got a really readable test that tells me that. I could even go further and have a static list, a constants of all my span names, because that might be important that they remain consistent throughout releases. You can have them in shared libraries, for instance, that you can use. And that could actually be referencing a constant. There's lots of stuff that you can do, but the main thing is, look at your tests, make sure they're readable, make sure they're testing the things that are important. Now, the other thing I said was we could talk about parallel processing. We could make sure that these things are run in parallel. That's something that you can test with observability. Much, much harder to test when you're running actual code. Even when you're running code inside of a unit test where you're just testing a class, it's still hard to test parallelization. But what we can do with this is say, well, get me the spans with this name, so start get. Bad name, but hey-ho. And then get me all of the spans that say get from DB. So maybe in this example, what we've got is it's actually doing 7 or 8 calls to the database, but we don't want to run them in series. We want to make sure that it runs all 5 of them at the same time, because that's quicker. And then we can say, well, make sure that every single one of our processing spans has a parent ID of our new span. You could do things like make sure that none of the spans start after the other spans. There's lots of ways to do this that allow you to be able to see into your code and see what it's doing. So, a couple of do's and don'ts. Use it for things you care about in production. Use it to test things that are important. Don't use it to test things that are not important. Do make sure that you're thinking about the data on your spans. That might be important to you. Take the first 2 into account, but you can test against some decent data in your spans. Don't check the database was called directly. Don't test your query. Don't test that it hit the database with select star from users. That's not what it's for. That's abusing the system. Don't abuse the system. Don't check that an individual method was called. Don't create a span for every method and then go in and say, did it call this particular algorithm method? That's not important to your test. That's how we make things brittle. Now, the other thing that we can do, once we've got all of this in place, we're using OpenTelemetry in our tests. We're using activities in our code. What we can then do is we can use tracing tools to start to understand our applications better during our test cycles. So what we can do is we can take all of our test runs and we can send them into something like Honeycomb. It's not specific to Honeycomb, but you can. We can send all of those in and we can say, well, how many spans were created during that test? How many spans were created during the next test? Over that whole run, how long did the whole run take? What was the average time for the tests? Things that you used to get out of the box when you were using things like TeamCity and things like that. When you move into using, say, GitHub, a lot of those tools are lost. But you can use that. Now, the other thing is that because we're producing traces inside of our application now, and we're using OpenTelemetry, we can actually see the traces and visualize the traces in your trace tool. So this is an example of that does not call database test. What I can do is I can look at that and say, well, what is the shape of the trace for that particular thing when I ran the test? Now, if you're using these, when you go to production, if you use the same tools in production for tracing your production application as you are using locally, you can start to see what that should look like in production. And when you look at it and go, well, no, that's not how it should work, you're gaining more knowledge about how your system works. So, some interesting reading on stuff. The repository is there. Martin JT to do ODD. Couple of interesting other talks to follow on. TDD Revisited is a talk that Ian Cooper did for the first virtual NDC back in 2021, which a lot of the concepts that I've come up with about how we decompose TDD into something that's useful come from talking to Ian and that talk. It's a really, really interesting talk about what TDD is and is not. The other one is David Whitney talking about writing tests that don't suck, which is a really interesting talk about the refactoring and naming stuff that we're talking about and extracting context, run from a JavaScript context. But it's exactly the same context. Me and David worked on this for the last 2 years, so all of those concepts are very, very the same. Okay, sales spiel. We have a free forever account with Honeycomb, so the things that we were talking about where you put OpenTelemetry in the end of your application, you can actually send all of that to Honeycomb for free for yourself, locally if you want to. We allow 20 million events to come through us per month for free forever. If you're writing more than 20 million spans in your tests per month, let's talk, because I'd like to know what you're doing. We also have, we wrote the book on observability engineering. It's free to download, which you can get on the website, which is not Honeycomb at all. This is all about how observability works, what observability is. There is a full chapter on ODD in there. But yeah, that's me. I'm happy to take questions. We have a ton of stickers. We had a thing where people said, oh, we'll do a sticker exchange and see whose stickers are best. And my response was, what's it like to lose? All the best stickers are on our booth out there. Come and take some stickers, or come talk to me. You don't have to talk to me, just take the stickers, that's fine. But yeah, I'll take questions now, but come by the booth, come say hello. If you want a demo of Honeycomb, we're happy to do it. Oh, and also, please do the ratings outside. It really helps me. If there's specific feedback of stuff you wanted to see and didn't, that kind of stuff, do tell me, ping me on Twitter. It all helps other people who are seeing these presentations to make them better. Do it for me, do it for all the other speakers that you're going to go and see as well.
Would that reach it? Or you can go to menti.com and put that code in if you can read the code. The question is, I am here because ... If you can complete that sentence, we're going to collect everyone in, make sure we get all our attendees, and then we'll kick off.
And Dan, if you can put it in the Zoom screen share too, that'd be awesome for me.
Okay. Right, Mike, I'm just going to bring you back. Where were you? View, speaker zoo. What do I need to do here? Screen share again. Sound, there we go, share.
Have some responses.
Oh, great. So yeah, once you've dropped your response in, just have a look at what other people are saying. Might give you some indication of whether you think you're in the right place. I am here because ... Just going to spend a few minutes more collecting everyone up. If you've just arrived, there's a link on the screen and a QR code to, you may want to move more into the center of the room if you can't see clearly. There's a question to answer. We've got a sentence to complete. Getting a few more folks coming in now. I am here because what?
So I'm facilitating a workshop later.
Thank you for these responses. I can already see there's some amazing reasons for being in the room. It does seem like most people are in the right place. Oh, I can shut the door. Okay, yeah, great, thank you. We're going to just close the door and we can leave that soft jazz elevator music behind us. And welcome to our workshop. If you still need a few more minutes, or a few more moments to answer the question, the Menti is still open. Got a few more people coming in, thank you. So yeah, anyone just arriving, we have a question here on the screen. There's a link or a QR code for menti.com. And we just want to know from you, what's your way to complete that sentence? I am here because. People looking for tips, people about to present or do a workshop today or maybe very soon. People looking for ideas, making the most of people's time. I like that one. Okay, yeah, come on. Get a seat. There's a link at the top of the screen there. Still a chance just to get your answer in before we move on. Question is, I am here because what? Move to space, come into the middle. You may be able to see the screen a bit better, and the link at the top there will help you get started. Just have a look over what other people are writing, see if you share the same goals as those people or if it's a bit different. Everything that we collect today will be available at the end as well. So if anything you write down in today's session, you will have a copy of that. We'll put it on Slack in a PDF format. So all the content, all of the things that you write down will be available. What do you think next? Should we
Yeah, I think so, yeah. I think we'll...
Sorry, before you start, there's something wrong with your mic. Don't know why.
Give me a second. Okay. Some feedback there. Okay, anyone who just arrived, you still got a chance to get the link from the top of the screen, menti.com. There's a code, there's a QR code. You can answer that question before we move on, and you'll find out what we have in store. Batteries in my microphone. Right. Okay. Should we try and get started? We're doing it. Is it advancing?
Yeah, there's just a short delay on this.
Yeah. We've tried 3 different clickers today. Is it? Let me just.
Yeah, it may have lost focus. If you just
Let me just. I've just clicked on the Menti window.
Okay, great.
There we go. What's the next slide? What? Okay. Go.
All right, so thank you all for joining today's session. Basically, the idea behind this particular talk or interactive session or workshop, it's kind of somewhere in between those things, is it's a journey that I've been on over the last couple of years. Started my career as a software developer, moved up as a senior principal, then I worked as a consultant. And one thing that's always been a constant through all of the work I've done is working in groups, needing to work together. Sometimes we're diverging. We're looking to explore and identify product features we can build, different ways we can work together as a team. What should our process be? Should we use story points or not? Sometimes we're converging, as I was touching on there too. How should we design a system? How do we implement some feature in code? So basically, there's always a need to work as a group to discuss possibilities and make decisions. Up until 2 years ago, it had been a very making it up as I go along experience, just organize a meeting, get a bunch of people together and stuff, and just figure things out. I learned some techniques like event storming and off-the-shelf recipes, you can call them. And then I had the chance to work with Dan and Mike, who introduced me to some very different ways of running workshops, some very different ways of thinking about workshops, some great techniques. And so if you're in a situation where you're in a situation and there's not an off-the-shelf solution and not an off-the-shelf workshop recipe, and you're like, we've got this challenge, it could be a diverging or converging challenge, and you're like, I need to work with a group of people to make some progress, to discuss an idea, the techniques we're going to talk about today are all aimed around that space. Anything from you, Dan and Mike, to add?
Well, I'm just looking at the flow here, and so we're where you can see the red pin. So we're just settling into the session. You've sat down, you've done the check-in question. We find out a little bit about who's in the room and why everyone's here. But we want to do other things today. We want to move on to talking about the process of design, so the conversations that you might have as you approach anything, like a meeting, a workshop, a conference session, something where you're gathering a group of people. What kind of conversations can you use, either just questions with yourself or questions in a group with the co-designers or someone you're working with, to say, what do we want out of this, and are we moving in the right direction towards those outcomes? And then, Nick, you've got some examples and stories.
Yeah, I'm going to be sharing some examples from the last couple of years since I've started working with Dan and Mike, how I've been applying these ideas to my work, some very technical focused workshops, some public workshops, experiences working with private companies, stuff we've done together to try and give you a sense of how it's relevant. But obviously, these are bespoke workshops. You can apply these concepts very differently in your sessions. But a lot of general ideas, I think, will copy across, and some actual specific techniques you can take away.
And for most of you, you should be able to see Mike up in the top corner of the screen there. He can see you because we've got a couple of cameras pointing at the audience. So Mike will be joining in with some of the facilitation. He's also managing any technical issues we've got with the content, because he can manage these Menti slides. And yeah, so just listen out for Mike. If you hear an American voice booming in over the speakers, that is where it's coming from. But Mike and I work together a lot, and we met together working on a client that Nick was also involved in. So there's some connections through client work. So as we finish up then, so we do all the stories and we'll finish up here at the end, we're actually giving you a chance, and I know that this is going to matter to a few of you in the room who are doing things today or this week or the next month. whatever it is you want to work on, we're going to give you a chance to do that today using some of the thinking tools and conversation topics that we introduce. And then we'll check out and we can leave, and you will get a copy of everything that you've written down today as well. So that's it. If there's anything that you don't want to take part in, just don't do it. We just want people to participate at the level they feel comfortable. So if you're in a small group today, you don't have to join. If you just want to work on your own, that's fine as well. So we're not prescribing any type of interactions. What's this, Nick?
So we've designed this session today, how we would design a session if we were working with a client or a public workshop. And we've got an activity for you as it would appear in one of those sessions. So this is the Ethnographica deck. There are how many? About 20 pictures there, maybe 25. And what we'd like you to do right now is look at these images and think about this question over here. So reflect on your personal experience of designing and facilitating workshops or meetings or gathering people, and which one of these images say some things about your experience?
People on the side, if you want to come in, obviously to get a better view of the pictures, go for it.
So have a couple of minutes to think about this and then type your response into Menti, and then we'll move on to the next slide.
And I just dropped the image into the Slack room if people need a better view too.
So where are you in your practice when it comes to delivering workshops or meetings, and which image says something about that?
A few more seconds.
Yeah?
Okay. All right, let's continue, shall we?
Let's go. Is it lost focus again? Let me just click on here. Try again. Shall I advance on here?
Yeah, if you can advance, please, that'd be great, thanks.
Okay.
So, now we want to see your responses. So which of those images did you choose and why? And your response will come up here, so don't post anything you wouldn't want to share publicly.
So yeah, just remember the name of the image or something that describes it, and then just tell us, I chose what because ...
Good responses.
Yeah, thank you to everyone who's sharing already. I chose tricycle because I'm a beginner at workshops. So if you've answered and you're looking at other people's answers, just take a moment to have a look through those, and also just reflect on the experience of that activity. It's quite a simple visual activity. We'll talk more about that as the session goes on. But what became possible for you as you did that? What happened in your mind to get that answer that might not have happened if you did a different sort of activity?
All right, shall we wait 30 more seconds and then continue? Okay, still a final chance.
These are great. These are great.
So I'll share a bit of my personal experience with this one. We were working with a large Canadian company, and we had to design a meeting for some senior leadership people to reflect on this big program of work they were running. And Dan and Mike proposed using the Ethnographica deck. And I said, you're going to get some of the most senior and expensive people in this company that makes $1 billion of revenue and get them to point at some pictures. I'm like, this is never going to work. But you know, if you guys are running it, I'll happily watch you burn to the ground. But it totally didn't work out that way, and that was a turning point for me when I realized, okay, they're onto something here. There were some different ways of thinking. We got one of I think he was a director of engineering, and he picked out the candles, and he said, my job is to bring light to this project. I want to bring light and keep people happy and motivated and things. And the thing to think about here is, if you didn't use this technique and you did something else, what would you do? Would you get answers like this? I'm a snail because workshops take a lot of time, or I think of a tricycle. It just activates different thinking, different kind of responses, varies your workshop a bit. So again, a very easy technique that can lead to very different results. Okay, let's move on. I think we've got a few ideas to talk about first. Clicker's not working, so
there we go.
I'll hand over to you. And,
here we are then. Right, so you chose an image. You've had a chance to think about what that meant to you, and you've shared something about that. Now just turn to the people around you. Just get together in a group of 2 or 3. You might want to move around the room if you're not positioned well. If you want to, join a group and say something more about your choice. I've got a sand timer here, the lowest tech way of keeping time, but in 2 minutes, we'll tell you when to stop. So just move around or turn around to the people behind you. Just say, I chose this because it meant this to me. And just add a bit more to the conversation.
do you have the time?
5-2.
Okay, so we've 15 minutes. Is that on schedule? Or? What's that, sorry? Can I quickly get behind you? Yeah, sure, come on. Oh, behind me? Cool, no worries, thanks.
Okay, if you want to bring your conversations to a close, just finish up your conversation. We're going to move on. Heard from the buzz in the room that a lot of people are taking the opportunity to use that small group time. It's good to hear. I think we're going to move on to some theory and some practice around how you could start to use some new techniques in your workshops. These are 16 design aspects. I'm going to ask Mike to talk through what these mean. Mm-hmm. So we've actually developed, so Mike and I have developed this through all of our work, including the work we've done with Nick. Mike, take us through what this means and how people might use it.
Thanks. Everybody hear me okay? Good? Looks like it. Head nods. Excellent. So hi, I'm Mike Rosinski. I'm on the East Coast of the States, just north of Boston. So appreciate being here today and being able to join. And as Dan mentioned, these 16 design aspects come from work that we've done together over the last few years, bringing together a lot of influences and a number of experiences. And we settled on these 16 at the moment, because as you can see, we're versioning. They're evolving, they're adapting. And the way we look at these design aspects is they're a series of conversations you might have with yourself or others that you're co-designing and co-facilitating with that cover the major elements that you want to be mindful of and be aware of and do the work to be ready for your workshop, a presentation, really any kind of meeting. And what we'll do later on today is we're going to focus in the top left-hand corner with the basic information and the framing. As often that's kind of the first stone we might drop in the pond to get things moving. And it's a really non-linear process from there. It's really gravitating towards where your mind's going, where the folks you're working with, where their minds are, and just making sure you're touching on each element here to the depth that's required for what you're trying to achieve. So we'll talk a little bit more about some examples about how we've used some of these and the questions that go along with them as we go. I'll turn it back over to you, Dan, to talk a little bit more about those influences along with our experiences.
Thanks, Mike. So as Mike said, we didn't just pull this out of thin air. It's come from years of work, and certainly, I mean, between the two of us, or three of us, thousands of hours spent working, designing workshops or meetings and gatherings of all sorts. And before all of that, there was all of these influences. And continuing forward now, there's some names here that you might recognize, some which you may not have seen before. Some of these people deal with complexity science, some deal with different ways of working. There's theories, there's models, things that have influenced us in our work. And we continue to gather that stuff. So we stand on the shoulders of these people, really, when we put forward those 16 design aspects. And again, there's more than you can read or we can talk about at this moment, but you'll get a copy of that in the PDF at the end, which we'll post in Slack. Okay, it's story time. Nick, I think we're going to be...
Sure. Yeah, let's jump into the first one.
Okay.
So the first concept, possibly one of the most important and one of the easiest things that you could start doing straight away, is thinking about how you want to start your session in the check-in phase and also the check-out. In my personal career, I've always found the start of meetings and workshops when people try and do things like turn to the person on your left and tell them what you had for dinner last night, or tell us something weird about yourself. Or I've always found that stuff very arm-wavy and fuzzy and hippie, and I didn't really enjoy it, and I thought it's just a waste of time. Since I've worked with Mike and Dan, and I've been paying attention to the check-in phase of a workshop, I think I found it to be really important, and it's something I'm using all of the time now, private work, public workshops. And I think as this slide demonstrates here, you can use that check-in to think about what kind of atmosphere, dynamic do you want to have in the workshop, the way you get people started. Like we did here today, we asked you why you're here. We were just curious to know why you're here, different group, we don't know you. That was the direction we went for. If you go to the next slide, please. The first example I've got is from a public workshop. I think we had 30 people, more than 30 people for a 2-day workshop in person. Hadn't met any of them before. A lot of them didn't know each other either, so I thought, let's go for something fairly general, open-ended. I just want people to share something about themselves. So I asked the question, what's your favorite game? And we got a whole range of responses here. It wasn't particularly on topic. It's more of a general question. And you can see a lot of responses here. We spent about half an hour going through the group, just talking about each person's response and understanding, why is that your favorite game? Oh, in my country, this is a tradition, in someone else's country, or I got this passed down in my family. So already in this 2-day workshop, the first 30 minutes, you're learning about the people around you, building some social connections, learning things about other cultures. A great way to get started. And a lot of things you just won't expect. And some people might agree with experiences you've got. I remember we talked about Monkey Island for quite a while. But yeah, you can continue. Another one, I was working with a company and their domain, this is a bit more on topic this time. So this was a workshop, a series of workshops for a company who have a domain which is based on meetings, conferences. I don't want to give too much away, but yeah, it was around the topic of meetings, large-scale meetings. And so we used a slightly more on-topic question, again, for the first workshop. Didn't know too much about the people, wanted to see how much they were willing to share about themselves. So we asked, who would you like to meet? You know, slightly connected to the workshop topic, nothing too deep. As you can see, we got a whole range of responses. Some people went into the past. I'd like to meet Elvis, as long as I don't have to be dead to meet him. So, you know, whole range of responses. Some people very serious, got to learn about other people, how much they're willing to share about themselves. So again, that was a different experience. And if we go to the next slide, this is something that you've put together, right, Dan, when you're thinking about, do you want to talk about this? Or?
Yeah, so we can talk a bit more about the flexibility of the idea of a check-in question or a checkout question. So those things you can use to bookend a meeting of any sort. They're very flexible things, and they can be used for different purposes. And you can see the bottom right here, we've just pulled in the relevant design aspects. So taking you back to that grid of ideas. Why might you use a check-in? To manage a transition in or out of the room. People are walking in. Where are they coming from? Where are they going to? What mood do you want to create? What ideas do you want to put in their head? Settle them into the session. Do you want it to be a check-in that actually gets people connected together? Is it important to you to grow some relatedness or social capital in a group of people? Think about whether they know each other already. Is it important to try and just turn that up a little bit? And then, of course, framing. So we chose one today that did actually set the frame for today's session. It got your minds thinking about what you're about to think about and what you're about to do. So you can use a check-in question to frame. And you can vary the difficulty of a check-in question depending on what you want to achieve. So on this basic sort of matrix, you can see you can use one like Nick picked, what's your favorite game? It's easy to participate in that. Everyone can just pick something and they can participate. It's a low barrier to entry. You could start to ratchet that up if you wanted to actually do some more work. So if you want to get closer to the work, you know, we might turn it right up and say to you, you could have said to you, why was it important for you to be in this room today? Or what choice did you make by being here and not somewhere else? So there's more power in that question. It invites you to think about change or possibility and the freedom that you had to make that choice.
All right, so this next topic is it's about using different workshop activities to think about the particular problem you're solving or the particular challenge you're facing. And sometimes we, when we're making decisions in our organization, we've got a particular topic, should we keep the monolith or move to microservices? And it can go around in circles. You never make the decision. You get in the meeting. You keep talking about the old conversation again, like you just pick up where you left off last time. And sometimes you want to just we need some different thinking here. We want to just completely approach this topic in a different way. Put all of those old conversations to one side and just get people to look at the problem in a completely different way. And so one of the ways to do that is to go completely the opposite direction. Instead of asking people, what's the best solution here, for example, you ask people, what's the worst possible solution here? What is the absolute worst possible thing we could do to solve this problem? And this is actually one of my favorite things. I tend to be defaulting more towards the stupid check-in questions and the crazy out there activities, but I do have some rhythm behind it. But I do find this really enjoyable. If you go to the next slide, please. Actually, yeah. Do you want to quickly explain what this is doing, and then I'll get to my stories?
Yeah, so, I mean, one of the activities that comes to mind here is one of the liberating structures methods called TRIZ, which is where I first saw about how to make use of this thing. So if you invite people to design the worst possible outcome in any given situation, it definitely unlocks some creativity. And it's really fun as well. Like every time you ask a group of people to create the worst possible result, it just breaks a whole load of taboos. Like it makes it possible to talk about things that you're already doing wrong. So you can actually create a list of things that that would be like terrible to produce a particular result or an outcome, and then you can say, which of those things are you already doing? Be honest. And it allows, suddenly you've made it possible to talk about bad stuff, and you could even say, which of those things are you going to stop doing? Don't start anything new, which of those things are you going to stop? And because it's fun, people actually come together through that activity. So you've increased the chances of that group wanting to work together again after the activity.
So I've got a couple of examples from one of my workshops. We were asking people to design the worst possible technical strategy for a company. And so everyone will get fired and be replaced with AI robots. They were going to be on TV. They were going to be burning down the company's headquarters live on BBC TV because all the employees got fired. Kind of like a strike in France, like you see very often on the news. What have we got in here? Yeah, someone's going to outsource a $6 million contract to his brother-in-law who doesn't even work in tech. Yeah, just all kinds of crazy stuff. You know, before we get into the serious stuff, let's just have some fun with this. And there are some things that probably do carry across into a more serious topic. The next one has got one of my favorite quotes. The same topic. What's the worst possible tech strategy? We'll have more microservices than Netflix. That's one of my favorite. But then you get something very, very serious over here. The team will respond to any fire or incident right away. That's quite a common problem I see in lots of companies. Whenever there's a bug, people switch from what they're working on and immediately fix it. You might get the whole team, 20 devs, all trying to fix this bug or emergency issue in production. And that can have big implications on your WIP, for example, and your blockers. So yeah, some of this will be pure fun and pure silliness, but there might also be some real serious stuff in there. Again, the microservices one actually is quite a relevant point, actually. So basically, when you do this activity, as Dan says, you might see things that you're already doing, and you can also take these ideas and refine them and say, how much would we need to tweak this crazy idea till it's actually a pretty good idea? So if you say to someone, what's the best way to solve this problem? Analysis paralysis, blank sheet of paper. If you say the worst possible thing, you'll get all kinds of crazy ideas. Maybe you can start building on these things. So that's why I'm always a fan of this technique.
Yeah.
Thank you.
So
now we talk about questions.
Yeah.
Questions are easy, right? You just say something and put a question mark at the end of it.
Exactly. Just pick a word, what, how, why, write something, and then question mark, and we're done, right? Maybe not.
Let's move on to the next slide. Let's have a look at this example we've got. So we've got two possibilities here. We've got a very simple, you want some information, you can just ask someone the question. I'd like to know your name, what's your name, for example, or I'd like to know what your favorite food is, what's your favorite food? But there are different ways you can phrase questions, and there are different reasons you might want to do that. The first one is just simple variety. Just asking questions gets a bit boring. So you can mix up your normal questions with complete the sentence questions. And what you'll find with complete the sentence is you can shape the way people think and respond a bit more. So it's having a couple of different benefits. So in this example, what will you do when you get back to work after the conference would be the simple standard answer. There's nothing wrong with that. If you're designing a meeting or workshop and every question is a simple question like that, it might be a bit repetitive and boring. This one down here, complete the sentence, is a bit more varied and makes you think a bit differently. So within 3 days of returning to work after NDC London, one thing I should do is, because it will help me to X. You don't have to answer this now, but you can think about that one. So there's all kinds of questions, not just complete the sentence. I think there's some on your website, right? I've written some blog posts about this too, around different kinds of questions, like devil's advocate questions. I've got some blog posts. Like when I send out the slides later, I'll post a link to some blog posts where there's different kinds of question formats. But the key takeaway is, mixing up your questions using different formats makes your workshops more engaging. It makes your workshops more varied. It gets people to think differently, and it's very easy. You can just start with your normal kind of questions and just change the format. And already, if you've added a check-in question, that's interesting. And if you've varied your question formats, already your workshop's going to be much more interesting just with those two things. And you haven't even done the worst possible thing yet, which is the third aspect. Anyways, any words from you on questions?
Just, well, we could speak all day about questions. So questions are just magic, right? There's so much you can do with questions. There's so much hidden power in the way that you phrase a question. And also, why are you asking a question? Because most of us would assume, particularly if we're in technical roles or in consulting roles, we ask a question to extract an answer, right? Well, not always, because the real powerful questions don't necessarily have clear answers. And the power in the question is actually more in the asking of it than the answering of it, in many cases, with some of the more powerful questions. It's what happens in your mind as you hear the question, you start to think about it. And what happens in your mind as you look at those two is potentially, if anyone has read Thinking Fast and Slow, certainly it was sat on my bookshelf for years before I actually got around to reading it, talks about system 1, system 2 responses in the mind. The second one's a much more of a system 1 type response, right? You just know how to fill those answers much more quickly than you would do the first one. You have to sit and go, oh, I don't know. You've got an open question, you're not quite sure how to finish it. You might not have a very good answer for that, but the second one, you just feel like you can just get the answers more easily. They just come to you much more easily. So think about how to use phrasing, think about how to use sentence stems to get people's minds where you want them to go. Where do you want the flashlight of their attention to go by using questions?
Okay, now we get to the conflict part. Different people have different ideas. We don't always want the loudest voice to be getting their opinion across all the time. So it's important to try and get those differences of opinion visible in a way where people can see what each other thinks and discuss those, and allow the best ideas to emerge, allow people to have a chance to change how they think. So let's look at one way to achieve this. It's what we call inviting dissent. Just want to clarify that the referee's not inviting dissent there. He's probably not too happy to be receiving dissent, but I couldn't find a different image. Any thoughts from you on this one before we get to the example?
No, I don't think so. I'm not a huge football fan, so I'm trying to find more depth in the metaphor there, Nick, but I think you're right. It definitely, this person there who feels like clearly they want to say something and they've got something on their mind, and maybe they wish they'd been invited to say that thing rather than just having someone hold their hand up to them. But behind Mike's head there, what you can't see is the design aspects we wanted to bring to attention. So inviting dissent is its whole section in the design aspects because we think it's that important, right? Depending on the context, is it important to get people to say, no, I'm not so keen on that, or I don't agree, or I've got a different opinion? What's the value of doing that in a group? And you might find in an organization, it has a lot of value. Here, maybe not so much because you're not colleagues in one organization, but in many companies we've worked with, just being able to say no is an incredibly powerful thing, because unless you can actually say no to something, saying yes has no meaning. That's what the power of dissent is. If you can make it okay to say no to something, it's the path towards saying yes. All right, let's get focused again and move on.
Right, so one of the ways you can do this, another question in effect, is using this emotions wheel. Similar to the ethnographica deck, you can pose people a question and ask them which one of these emotions they feel most connected to. And it gives people a chance to talk about some anger, sadness, those kind of responses. And what I found with this activity is people having this wheel in front of them, people will choose an emotion that they might not have chosen off the top of their head. It makes them go through these emotions and think more clearly, what is the exact emotion I feel about this topic, getting the nuances to the surface. So that's, again, another simple technique you can introduce into your workshops. Very easy. And the next one is an example of a company we worked with. So the leadership team, they wanted to introduce a new hiring process to be able to hire software engineers 10 times quicker and quickly ramp up their company. They had some interesting ideas, but when we spoke to the teams and the managers at the team level, they had some concerns, but those two groups weren't really talking that well. So we wanted to create this space to allow that dissent to emerge, where the teams could surface their ideas and opinions in a way that management could see it and understand okay, that's how the teams feel. Maybe we should spend more time thinking about this and maybe make some changes. So we use this metaphor of a mirror, holding a mirror up to the leadership. We had a remote workshop, and we had a questionnaire in the workshop, which was anonymous, sorry, not unanimous, definitely not unanimous. It was very anonymous. So people could share their responses in a safe way that management would see, and people were able to identify themselves if they wanted to when we went into the discussion, and if they chose not to, that was also fine. And then we changed the color, so people got to vote from 1 to 5 how much they agree with a particular idea and what concerns they might have. So 5 was good, that's the greens. 3 and 4 is orange. It's kind of like, yeah, we think that's a potentially a good idea, but some concerns. And then 1 and 2 is red. Not too many of those, but a couple in the key areas. And that might be important enough that that's something to focus on. We've even got a 1 down here as well. So yeah, that worked really well. We got these things surfaced. There were some productive conversations. But if we go to the next slides, the leadership team weren't ready to receive all of that dissent. We had a great workshop and lots of productive conversations, but then the program manager said to us, he said, me, Mike, and Dan, we were kind of in trouble. He said, that should never happen again. He said, whenever we go to the workshop, always has to be 5 and green. Every idea management has to be unanimously approved and well accepted by the whole team. So he wasn't ready to invite dissent, and this was a real shock for him. So I guess one of the first points is, if you're going to do something like this, think about how certain people might take it if it's their idea that's receiving dissent. But the thing is, over the next few weeks and months, this person kind of reflected on that experience, and we had more sessions with him. And he was more open to accepting dissent afterwards. So kind of like planting a seed. Some of these ideas might have an initial reaction, but over time, you build that culture where inviting dissent is more widely accepted.
Yeah, sorry. When you have these sessions where management has difficulty to listen to the dissent, how is the ratio between the workshops that you have with the team where you try to enable dissent and actual training, coaching the management one-on-one to prepare them for accepting dissent?
That's a great question. I think there's a lot we could say about that, so we'll come back to that at the end of today's session. But a great question. Thank you for raising that.
Yeah, there's a question there about how to work with management in dissent. If you've got other questions, we'll put them in the Slack channel and we'll answer them all at the end, or just as you think of them, just drop them in Slack and we'll try and answer them all at the end. Also, we'll be here after the session or just outside. So.
Just one final thing I would add on this one is we had a lot of people after the workshop who we hadn't even met before who were involved in this, and they came to us and said, we enjoyed that workshop, we got to express our points of view. It wasn't just the company, there were other agencies involved who wanted to get their thoughts in as well, and they were the people who came to us the most. So yeah, a lot of people appreciated that, and some...
So it usually works, it's just that not everyone's happy with the results, depending on the level of fear in the culture.
And again, before we got to that point, we had a check-in question and a couple of activities before that led up to the dissent. We didn't go straight into the dissent. We designed that sequence of steps to get to this point.
Yeah. So, we're going to invite you to dissent on all the things we've talked about. Which are the things that we've just said? Which of those practices? So you've got the five areas of practice there that we've just shared with you. Which ones are you least likely to use? Which ones are real thumbs down for you? So you've got setting the mood with thoughtful check-ins, bringing creative thinking in, the art of questions, embracing difference, or I'm not sure. So anyone who came in right at the end may not have used Menti yet, and we can see the results coming up now. So take a moment to think. We'll stop on this slide for a few moments. And we'll see where the room's at.
Dan, these should all be 5s. Whenever we get to this point, these should all be 5s and green.
Yeah, we need to cover this up in case the executive team walk in for this conference and we're revealed to be very poor program managers. Thank you for your responses. This is great. So it looks like the winner at the moment, setting the mood with thoughtful check-ins, is something that people aren't really feeling is necessarily the thing for them. That's interesting. And other people aren't sure. So we'll just give you a few more minutes if you, looks like we've got most people there probably from the room. Thanks for your answers. So the winner there is the check-ins. Looks like most people are thinking, can't see how that's going to work for me. So thanks for sharing that. Again, it's something we can talk about after the session or on Slack.
Yeah, definitely. After the session, if you've got any questions or ideas about this, we're always happy to chat. So don't feel...
Why did you pick the thing you just chose? Can we find out a little bit more about that? Would you be willing to share a bit more? So I am least likely to use the practice of blank because what? So just stay in Menti for a second. And again, just like at the beginning, anything you answer is going to appear on the screen. So if you're not happy to share it, please don't. Why are you least likely to choose that thing? Okay, so some awkwardness perhaps. Okay, some people are just picking one that's maybe the worst of a good bunch. Okay, good. Feels
This is basically
forced.
what I was saying earlier. This is when I didn't like check-ins, that forced happiness, that forced fun.
Yeah.
It feels so fake and artificial. Totally agree on that one.
Yeah. So possibly some risk in it then.
Yeah.
People feeling like, oh, that's gonna expose. There's some vulnerability in that. If you ask people to do that right out the gate, you're putting a lot of pressure on yourself to make sure that that was a good question, and it's actually going to do the work you want it to do as people arrive. Doesn't add value potentially. So these are some great answers. Thank you for everyone who's sharing these.
I think those points about check-ins, there's a lot of, I agree a lot of that. If you're bringing a group of people together who know each other, then treating them like a group of strangers and asking weird questions, yeah, it might be a waste of time. But also, yeah, we always like to do it, don't we? We always find there's something new and interesting that comes out in all of our sessions, even with the same group of people.
Yeah, I think it certainly comes with experience. It feels natural to me and to Mike, definitely, and you now as well, Nick, but it doesn't always, especially when, as I've said, you're putting in a position where you'd rather not be vulnerable at that point as a facilitator or presenter, perhaps in a session. So we'll capture all of these. They'll be exported at the end. If you're still answering, just give you one more moment. Okay, we're going to move on.
Yeah, and something to add just on the check-ins too is that it's often people transitioning from something, and even where there are deep relationships, it kind of forces some creativity to get to know each other a little bit better and just get into the space of doing work together. But I certainly appreciate all these comments too. It is a practice that evolves for sure.
Okay. So we're going to quickly get through this and then on to the section where you actually get to do a little bit of work about whatever it is you're thinking about. So again, we'll go back to Ethnographica deck. What's the invitation, Nick?
So we're kind of reflecting on that first question we had from a different perspective now. So where is it you want to get to in your workshop design and facilitation practice? So again, pick an image which talks to you about that topic.
So you know where you were, you pick the image at the beginning, where would you like to get to? And which image says something about that? Okay. So just quickly give us give us an answer on that. If you'd like to share that, what image did you choose and why? I chose what, because. Where do you want to get to in your practice? Okay, thanks to the folks who've responded. So again, just if you've answered, have a look through what other people are saying. Get a feel for who else is in the group here. Maybe people you're going to see at the end of the session or the rest of the day, and you see you can see who's in this group today and what kind of things people are aiming for. Maybe it will come up in conversation. Okay. Should we move on, Nick, to the
sounds good.
part? Right. So, thanks for participating this far. Thanks for staying with us. At this point, we're inviting you now to think about some of the things you've been playing with today. We're going to bring you back to those design aspects, so the 16 topics, the 16 conversations. As Mike said, we always start sort of top left, and we've got basic environment and framing. So whatever you're working towards, you're in here for a reason. What is it you want to get better at? Is it a meeting that's coming up, something you're doing today, something you're doing next week? We've got some questions to help you think about that. Everything, as I said, that you write down, you'll remember what you said, and we'll anonymously put that in the PDF, so you'll have those notes. The first question for basic environment is how much time do you have? So just, again, go to Menti, start answering these questions, think about what it is you're working towards. How much time do you have for that session, that workshop, that meeting? You're going to build up a picture of like the basic information for this workshop or this meeting, whatever it is you're doing. Okay, so 1 hour is definitely the winner. 1 hour is the sweet spot for this group. Great. Okay. Okay, so it looks like a lot of people in that 60-minute area. A lot you can do with 60 minutes, but you're also constrained in other ways as well. So that'll be something you're thinking about. What can I realistically do with that time? Next question, how many people will there be? What's the size of the group you're working with in this thing? Okay. Okay, really strongly weighted there towards, I think we see some strong signals on the area that people in. 60-minute meetings, under 20 people. Okay, so keep those in mind. Where will everyone be? Are they going to be in person, virtual, all virtual, or some mixture in hybrid, or something else? You're inventing some other form of hybrid.
Wasn't expecting to see that many hybrid. Interesting.
Yeah. So you're starting to build up that list of basic information about what you're designing for. What do the things you know about your gathering enable you to do, and what do they constrain you in? What sort of other things are going to come to mind for you soon? Okay. And then finally, we move on to framing. I hope everyone can read that. Nick, do you want to invite people to do some framing?
Yeah, sure. So what are some things you know about the people who will be in your workshop? What about the things, you might not be able to share private details about your company, but what feels relevant to the workshop you're designing about those people? Personalities, ways of working, things they might find, issues they might find difficult to overcome, that kind of stuff.
And what kind of identities might you have in the room?
Thinking about different power dynamics, for example. How long have they worked at the company? You've got a lot of new employees or a few people who've been there for a very long time.
Yeah.
Is it a topic you've been talking about a lot of already and people are kind of bored from it and worn out from it? Or is it something new and interesting you're trying to get started and start building momentum?
Thank you for sharing these answers. This is great. So you can start to see where the group is in terms of what's on your mind. You know something about who's turning up to your thing. What do you know about them? And as you think about those things you know about that group, what is it going to mean for you? What kind of questions might you end up using in different parts of the session? What kind of level of altitude? Is it going to be way high up here? Is it going to be working with management? Do you need to be somewhere in the middle? Are you going to be going right down into the content of something? What sort of activities are going to feel right to you? Okay.
Something else I would always think about in this one as well is how busy are people? Will they be able to... I was looking at this one about the short attention spans, and that's actually a very common scenario. People are so busy with their work, they've got deadlines that when you're organizing a meeting or a workshop, that's just another block in their calendar to try and get through as quickly as possible. And so that's a great one, actually, short attention spans.
Yeah. And if you're dealing with something like that, what might you choose to do in the session to actually break that up? Maybe you'll actually have a moment's pause to say, just stop and think on your own for a minute. For the first time today, you've just gone from one meeting to the next. Stop and think about what you want to say next. Make some notes in silence on your own in this meeting, and then we'll carry on. Incredibly powerful in an environment where people are just bang, 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 one meeting next. You just turn up, you start talking. You're listening to people, and you never stop to think about anything on your own. Just use individual thinking time. Okay. So you've made a pretty good picture now of the who's going to be in the room, where they're going to be, how long you have. You've got some constraints and some possibilities. What are you actually going to be aiming for? And we've got 4 questions now to help you frame it. This is the story around your meeting, your workshop, whatever it is. The first one is this. Wouldn't it be great if you were going to complete that sentence as you think about whatever it is you're working towards? How would you complete that sentence? I like these already. We can hear everyone. We can hear every voice. Okay, so we've definitely got a sense of people looking for some inclusivity in some of the people in this room. What the things they're working towards is having everybody to have a voice, being engaged, being part of it.
Yeah, fun. That's one of my favorites. That's why I'm always into the worst possible. So yeah, that might be a relevant one for you. If you're thinking about how to make it more fun, you could start with the worst possible.
Okay.
But there is a risk that worst possible can go wrong sometimes, so it is important to be careful with that.
I'm going to move on to the next one now because we've got these other ones to get through. So the next question was, the most important part is, if you had to pick one thing, what's the most important part of what you're designing? Thank you again for these answers. I love some of these. People should feel safe to disagree. Okay. So the next framing question is this. What I'm most worried about is, what could go wrong? What is it that you're feeling inside you that's like, oh, I wish that wouldn't, you know, what could go wrong for you? Okay. Time wasted, people not engaging, switching off. And as you sit with those worries, what might that mean? Like, as you begin to get into more of the design, what might you bring into that 60 minutes with those 20 people to reduce the chances of those things happening? Okay, we've got one more sentence, so thank you for these. I'd love to sit for a bit longer and let you think about these, but we want to make sure that we've had a chance to answer all the questions. So to finish then, to help you frame your thing, whatever it is you're working towards, by the end, I hope most people feel what? Optimism, being heard, making progress. Okay, thank you for all these. These are great answers. Okay. So, can we do a time check? When does the session end? How long have we got? We're done? Yes. Okay. Well, now it's small group time. Okay. Maybe we can take this outside the room, but the next invitation is to work in small groups. Take the answers that you just had. We're going to collect those up. We'll export them from Menti, and we'll put them into, what we're going to do is put them into Slack, and maybe just before we leave, we'll just quickly answer this one. So just as you're walking out now, and we're wrapping up, which of the things that we mentioned seem important next now to you? So you've answered those questions, and you've had a chance to think about your framing. What seems important next? Where's your mind going in those 16 things? We'll just quickly capture that as we finish. Fascinating to see where, in this group of people, where are people's minds going to next? What seems important to think about now? And notice the things that hardly anyone's thinking about. What's going to happen before and after your session? You get to the end and everyone wants to feel heard, and they're like, well, what happens next to all the stuff we just collected? I don't know. Oh, sounds like every other workshop we've done. It's just gonna get all those Post-its and put them in the bin. So have a think about what happens before and after, and how you're going to communicate. What are you going to do next? Thank you for these answers. I think we're over time now, but thank you very much for everything you've contributed today. Anything else to say?
No, just thank you. Hope you enjoyed it. I've been on a learning journey myself over the last few years, learning to apply these techniques differently to my workshops, and I hope that this can be a seed that grows into a nice plant for you over the next few years as well. Thank you.
Thanks a lot.
Thanks.
anymore. Or you want to sleep, then that's fine too. Otherwise, it's going to be a bit of a problem. So thanks to be here for this talk about backend for frontend. I have a 1 hour slot. I won't fill it, so if at any point you want to ask questions or make comments or whatever, feel free. I prefer the talk to be interactive, especially since during the pandemics I talk to my screen a lot, and the screen doesn't tend to ask questions, and it's a bit boring. So yeah, back to on-site events, we talk to people. If you don't have questions, that's fine too. I'm Nicolas Frankel. I've been a developer for 2 decades, which is probably a long time for most of you. I worked mainly on the JVM. I worked on the Java platform, Spring, well, before Spring, Java EE, then Spring. A couple of years ago, I started to do some Kotlin. I love Kotlin. Who knows about Kotlin? Wow, it's not a .NET developer conference. That's good. I thought that NDC was .NET, but I'm learning Rust at the moment, like by leaps and bounds. It's really, really interesting. And a couple of years ago, I also decided that I had enough of projects because they were like those like customers, and they already had like strange requirements. And in general, organizations, they want you to solve their organizational problems with technical solutions. And when your scope is the technical scope, then it's not that fun. So I became a developer advocate. So now if you don't care about my advices, that's fine. I won't know it, so everything will be fine. Anyway, as I mentioned, I've been working for some time already. And when I started working, this was what we did. That was amazing, right? Server-generated pages. But now it's back full circle again, as I understand. But yeah, that's what we did. It worked very well. I can show you some crazy code like hello world type of code, because now I'm a developer advocate, so I'm not supposed to do something complex. Besides, perhaps I'm not a developer anymore. I developed the stuff in Python, so I hope that's fine with you. Who here is a Python developer? Wow, there are nobody. No Python, 1 person, okay. Yeah, I'm lower than that, so that's fine, okay. I thought, wow, perhaps I will talk to people, I will do some Python, even though I don't know Python. It will make like, you know, the relation better, but nobody here knows Python. Should have done it in Kotlin, but anyway. So here, it's a Flask application. I don't use a database because I'm super lazy, so I have data that is in arrays. Then I have like 3 routes. First route is for products. Second route is for news. Third route is for debugging information, very important. Most developers, they don't care about it, but I do. And then the main route aggregates everything and returns everything in one go. So here it's not like a page that is generated server-side, but it's like fits this model that in general you have like one single endpoint, and then you have something that queries it, and you get all the data, and everybody is happy. But of course, it didn't stay like that for long. Because afterwards, there were phones and tablets and devices and whatever. And so we had the same thing. We still had like a server endpoint, but we had to deliver data for all those different devices. And of course, we could still do the same. We deliver everything. And then on each device, you need to remove what you don't want. Okay? And that's not a great idea, because first, every device needs to do it, which is additional like computing power that you lose on each device, which is not super nice for the user. And then on the network side, you return whole payloads, and you might use only a part of it, which from an engineering side is not that great as well. So of course now everybody has 5G, right? Yeah, that's the point. When a user goes to some, everybody has 5G. No, no. Sometimes you don't even have 4G, like depending on where you are. So be nice to your user, be considerate, just return what you need. But it gets better because you say, okay, we can actually be smart and just return what the device needs. So you might have a different route, you might have a query parameter, you might have a header, and then when you request the endpoints, it returns you the data that you need and only the data that you need. So there are Kotlin developers, perhaps there are Java developers. No Java developer? Ah, interesting. So Kotlin developers, you are Android developers, right? No, there are no more Kotlin developers. They just disappeared in like 5 minutes. Where are my Kotlin developers? For what? Sorry, okay. So no Python, no Java, no Kotlin. .NET developers? That's what I thought. Okay, and then all my references get lost because, well, I don't know .NET. It will be hard, but I try to communicate it. What we did in the time, we tried to return like generic data, and then on the server side, we added what we call the servlet filters, or if you want, just filters, and basically depending on the device that was asking the data, we just like filter it here. That was fun and nice, and everybody was happy. And now came the fun stuff, the microservices revolution. Who here does microservices? Yeah. You don't. Yeah, you do, you do. Okay, I will return the question. Who here doesn't do microservices? Ooh. Couple of hands, yeah. People who do microservices are very proud because that's hype and, well, that's a good way to get hired. I'm not kidding, actually. I'm very serious. But I think a bit differently. And so just because I'm French and we like to complain, give me a couple of minutes to rant. We are in an industry that right now says that microservices are good. I mean, I don't know if you went to a couple of talks. That was the grail. You wanted to do microservices. And monoliths are bad. Bad. Ooh. No. I disagree with that. I also. But that's the state of the industry nonetheless. And, well, again, give me a couple of slides to try, perhaps, to instill some kind of critical thought into that. This is the definition of microservices by Martin Fowler. I don't invent anything. If you are unhappy with it, just bring it to Martin. I'm not responsible. Whether you like it or not, that's what I will use. In the same blog post that I referenced here, you can find like characteristics of microservices. And in general, all the technical aspects are respected. But the last bullet point is not one technical aspect. It's how you handle, how you manage. So now, let me rephrase, re-ask the question. Who here does microservices according to those characteristics, especially the last one, meaning you are doing products and not projects, meaning that you have recurring budget from year to year, of course it can change, whereas a project has a start date and an end date. Now, who does microservices according to this definition? So we went to like nearly everybody to 2 and 2 halves. That's very interesting. So basically, according to Martin Fowler, you don't do microservices. So you can remove it from your resume right now. I will check afterwards. Let's get a bit further. I'm sure that everybody has heard about Conway's law. It's okay if you tell me no. Again, this is a discussion. Everybody has heard of Conway's law? Okay, great. So the idea, and this is Melvin Conway, by the way, so I was very happy to take a selfie. Prime. The idea is that if you have an organizational structure, then your architecture will reflect the communication in the structure. And when I started hearing about microservices like 5, 6, 7 years ago, it was very clear. Every talk about microservices said, you must reverse Conway's law. Meaning that right now we have layer-based architecture, and the reason is that we have like layer-organized teams. So if you want to have a microservices architecture, you must have independent teams. Again, who here has this kind of organization? Don't be shy. Most of you do. No, nobody dares. And okay, and who have this kind of organization? Oh, really? Wow, that's cool. In general, it's about the same number of people who do products. That's really cool. So, okay, there, let's say 30% of the room are organized like this, and nobody organized like this. So that leaves 70%. I don't know how you are organized. So either you are too shy to admit it, which is fine, or something else. So can somebody who hasn't raised their hand tell me how they are organized between this and this or something else? I feel like a school teacher asking the students, and nobody, like, you all look at your shoes. I'm not that impressive. I told you I'm French, that's fine. Okay, forget it. So still, this is a high number of people who do like this. So if you are organized like this, microservices might be a thing. The problem is 30% is already for me a high number. So it's like, you know, product, not projects. If we go into the detail, there might be some grain of truth, or it might be a bit different. The problem, if you have like a legacy organization organized around like this, and you want to migrate around like this, who will be in your way to do this? What does the guy look like? There is a hint. He has a suit and a tie. Do I look like I have a suit and a tie? Can show you I'm French. No, this guy is a middle manager. So the person who can help you going from this kind of organization to this kind of organization are the middle managers, right? So in this organization, the middle managers are at the top here. There is one middle manager for the UI team, one here and one here. Where are the middle managers in this schema? Gone. They are gone. So basically, the people who can help you migrate your organization from your legacy state to the to-be state are the people who will be made irrelevant. They won't have a job anymore. It's really, really hard, right? It's not going to happen. Nobody, well, not many people are going to make themselves jobless just for, hey, the sake of the greater good. So that's the reason why I think that most organizations, most legacy organizations are not suited to microservices because they don't have the right kind of organization. Only when you start from scratch, no middle managers. And just for fun, is there any middle manager in the room? Or I can be offensive a bit. One, okay, you will come afterwards. I will give you some chocolates. Then I will make up for it. So first, I've met a couple of good middle managers in my life. Sorry? Okay. I've really worked for a couple of them. If you find one, please follow them everywhere. They are very rare. Most of the middle managers I've met in my career, actually, they were paid to approve my vacation requests, which in general, well, was just like stamping because everybody on the team was happy, or if they weren't happy, they would have told no. Then to be the proxy for your raise at each yearly interview. I mean proxy because you cannot negotiate, right? Is we give you this. Yeah, but it was decided. And the third is reporting. So basically, your manager is a not so good bot that takes data and puts it in an Excel file, or Google Sheet if they are modern, or Office 365 if you are on the Microsoft stack. And they get a lot of money for that. That's not funny. So if you find a good one who is really helpful, whose job is to remove the blocks in your job, well, follow them. So I've ranted a bit, and my point is microservices are an organizational mess because you need to migrate your organization. Or you keep it the same way, then you will get none of the benefits of microservices and all the issues. Now, from a technical point of view, because I assume that nobody will listen to my advice anyway, that's what I told you at the beginning, you will address it from the technical point of view. And from the technical point of view, it completely breaks what we did before. Because now, your phone needs to receive data from service 1, service 2, and service 3, which means that not only do they need to actually make X calls, depending on how many services do you need, but on the back-end side, that means that the team in charge of a service needs to care about the phone and the browser and the tablet and whatever. And this concern needs to be replicated along each service. And of course, there is like an explosion of cardinality if you add one more on each side. So my solution, which is not my solution, is to have something on the back end that is handled, managed, developed, and deployed by the front-end team. It means that these new components will actually aggregate and filter the data that is just necessary for the phone. Because who better knows what they need than the phone team? And they are close to the service, so you make a single request. Here you make multiple, but you are close, so that's not that hard. And everything works as expected. This is an organizational decision. And the problem is, this is an organizational decision, this is an organizational pattern, and people, tech people, I think I'm a tech person, we translate it into a technical pattern, like straightforwardly. It means that we generally do something like this. So I've shown you my idea of the monolith, which again is really, really bad. Everybody knows it. And I transform everything into a microservice. and I added a backend for front-end. I will directly do like this because this is not really interesting. So here now I have separated my microservices. It's only two. Basically, it's really stupid. I've just created an endpoint for the product and an endpoint for the info. And here I have the news, and I've created, guess what, an endpoint for the news and an endpoint for the debug or info. So also, I need to have an else check for every service nowadays. And I aggregate them as the following. I still have my route, and here I will do the request on the back end and aggregate them however I want. Here I decided that I will have an attribute for the product, an attribute for your news, and a single attribute for all the debug information from all the different endpoints. So if I show you my Docker Compose file, here, this is how it works. API 6, I will just talk about it a bit later. And I have my catalog, my news, and not my best friend forever, my backend for front end. Let's see how it works. Docker Compose down. I will just remove everything just to be sure. And up. It was really, really fast. It's a bit strange, but normally it should work as expected. So I can curl local hosts 90, and I say just at the roots, and yeah, it works. So I have everything. If I GQ it, I can have it in a nicely formatted way. So that's what I told you. I have the info endpoint, and I get like nested the health or info, whatever information for each service. Then I have the data that I want. It means that, well, here I've written everything in Python, but as I mentioned, that's not so a great idea because, yeah, the backend team writes in Python, but the front-end team writes in whatever. Probably, I don't know about any front-end technology in Python. JavaScript, yeah. Or if you are an Android developer, you would write Kotlin code again, or Java code, or .NET for mobile, which I don't know if it exists, but I have no clue, but well, you can fix it for yourself. So the idea is that, as I mentioned, it's an architectural pattern that many implementation. And since here I'm using an API gateway, who knows what's an API gateway, by the way? Who doesn't know what's an API gateway? OK. I'm always a bit worried. That's fine. But again, if you don't ask me question, I will assume that it works. I'm using an API gateway. So the idea is that you can do the exact same stuff, but you translate it in the API gateway. So instead of having a Python here, I have just a plugin inside the API gateway. It's still the same team that deploys it, but it's another implementation. And perhaps they are more at ease with it. So it's all about independent development and deployment. It has nothing to do with anything else. It's not a technical requirement. I work on the Apache API 6 project. Who has heard about Apache API 6? Nobody? Or perhaps too shy, I don't know. In some countries, it's because of shyness. But the more I talk, the less people raise their hand. They always feel that like there is a trap afterwards. So it's an API gateway built on Nginx. Who knows about Nginx? OK, that was not a trap. That was cool. So it's really robust reverse proxy. On top of it, the problem of Nginx is if you want to change any of the configuration, you need to stop the service. which is not that great in this day and age. Like, you don't want to have a static web page saying, hey, we are back in a few minutes. Huh? If Facebook doesn't do it, your grandmother probably wouldn't understand what it means. We know, well, all people know what it means, but us, the family, don't. So we have OpenResty. OpenResty is a Lua engine on top of Nginx that allows you to script your Nginx configuration. And then we've got plugins. And the plugins allow you to get, like, out of the box, already prepared common use cases. But you can still write your own stuff, which is exactly what I did here. So what I did here is I changed my architecture again. And now my architecture on the Docker Compose file is back to what it was before. So there is no dedicated Python app for front end. Everything is in API 6. So there are two ways to deploy API 6. The first is with etcd. If you have dynamic configuration, etcd is a distributed key value store, the same one used by Kubernetes. It's pretty robust. But here what I'm using static files, so you can use it in a, like, GitOps way. Up to you. And what I did, I created the same code that I did before. Is there any Lua developer here? Good. I'm not a Lua developer either, so I can show it to you. You can criticize my code. So basically, sorry, I've created a generic function to fetch the data from an endpoint here. I've created all the endpoints that I wanted, and then I go through all the structure, and I get everything, and I aggregate everything, and I put it in JSON format. The only thing that I need to do is configure API 6 to have like a virtual endpoint, because normally an API gateway should actually like forward somewhere. Here I create this virtual endpoint to say, okay, I will handle it by myself, which is not the usual use case. In general, you forward. So I can start it again. And from the customer side, the user side, it shouldn't change anything. I think I know why it starts so fast. I didn't rebuild. Okay. So I didn't cheat you on purpose, but I still cheated. Curl. Okay, and if I curl again, JQ, yes. So you still have the same results, even though the architecture has changed. And the organization is still the same. You still have your backend for front end, but in this case, instead of having a dedicated component, it's just a plugin inside of the API gateway. Every team can have their own plugin that they deploy independently. So it doesn't mean that like this pattern needs to be implemented in a certain way. You have multiple ways to do that. If you have an API gateway and you don't want to code any Lua, depending on the API gateway, but it's possible in Apache API 6, you can do a bulk fetch. So basically, you still will do one request from the front end to the API gateway, no code, no nothing. And on the API gateway, you configure something generic that does all the calls, and you return all the data. So we are back to square one, only we have one single call. So it's quick and dirty. You get some benefits, not all of them, but it still works. Good. As I mentioned, it won't be 1 hour. Please don't do microservices. Really. Don't. Really, really don't. As I mentioned, you won't listen to me. Or perhaps you are already like neck deep in microservices. You cannot leave. I can understand it. Yeah. But if you do, and if you have multiple device types, then backend for front-end is one pattern that you can use. Think about it. I will repeat it. It's an organizational pattern. There is no direct, straightforward implementation. You can create your own components using the language you want. You can use an API gateway, and perhaps there is something that I didn't think about. Very important to go beyond the scope of this talk. Every problem is an organization problem. People problems are still simple. If we or both of those of you have disagreement, I can talk, we can have a meeting, you are smart people, we will come to a consensus. Worst case, I will fire one of you, or both. This is easy to fix. What is very, very hard, impossible to fix, are organizational issues. There are so many organizational problems that we need to cope with that make no sense. Stupid stuff. You said you were a middle manager, so basically you need to report to somebody in general. You need metrics. There are two kinds of metrics. Vanity metrics that are easy to compute that tell you nothing, or metrics that are very, very hard to compute, and, well, it takes time, or it takes money, or whatever. Other stupid organizational statements. You have a company. You divide it into silos. You try to optimize one single silo, and you think that the sum of all local optimums gives you the global optimum. Who here believes it? That's completely crazy. Guess what? Every one of us is still doing that. You've got a company. You've got only 2 departments. You give budget to department A. You give budget to department B. Department A, at the end of the year, needs budget. They already, spent everything. Department B didn't. What happens? How long does it take? Forever. So basically, you have a department that needs money. It will never get it. Only because at the beginning, you decided to split the money into virtual buckets. See that I'm only complaining. I'm not providing you any solution. Huh? The French way, right? But it's still an issue. But if only I could make you think about what we take for granted, most of the rules that either we apply to ourselves or that the organization puts on us, most of the rules are pretty stupid. They don't help us at all. They actually make our work harder, sometimes even impossible. If you find yourself in such an organization, you have 2 solutions. Be demotivated until you retire. And in general, I must admit, they give you a lot of money for your demotivation. Or leave. Thanks a lot. I'm Nicolas Frankel. You can follow me on Twitter. You can, I want to make a social experiment. If you have a Mastodon account, please follow me there. And I want to count how many people are on Mastodon, because there is this great shift from Twitter to Mastodon, and it doesn't seem to translate so far with my experience. If you are interested about the code, though it's in Python, I could write it, you can probably read it. You can check it. I've made all the Git commit steps as one of the steps I've described. so you can follow around, see the differences. And if I got you interested in Apache API 6, of course, you are welcome to have a look. It's an Apache product. It's managed by the Apache Foundation. So basically, it will be free and maintained, well, free forever, maintained depending on who is interested. And that's good. I don't know how much time do we have, but we have time for questions. So I will be very happy to have discussions now. Or not. Sorry? Who is the middle manager? You mean among you? Who is the middle manager? No, I don't snitch. I don't snitch. I'm not. Well, actually, like officially I am, but I have very independent people like me, so that's fine. Other questions or comments or whatever? Yes?
I think sort of the back-end for front-end stuff could be like the stuff you were saying with like microservices. That could be done instead with and like different teams working on sort of front-end and back-end. Like that could probably be done with like GraphQL, where you can like also filter stuff out.
As the volunteer, can you take the mic, please?
Oh, yeah.
You should be the one to know.
With the stuff with like filtering and stuff like that, when you have different teams working on sort of different parts of the application, when you think like something like GraphQL would be quite helpful with that, and like just sort of using like a federated server or something like that to actually like consume all your services that you have, and then being able to communicate that with your dev team on the front end.
Yeah, GraphQL is definitely an option. Also, I was a back consultant because I was able to say, I don't have enough experience. So here, in that case, I don't have enough experience to tell you whether GraphQL is a good solution, a good technical solution to this problem. I think not, but I cannot tell you, hey, this is the reason. So I need to delve deeper into it. As far as I understand, GraphQL has issues on its own. And again, in my opinion, if you have an organizational issue and you try to solve it with a technical solution, it's going to have many ripple effects. So probably it's possible, but there might be side effects that you don't want. But it's an option, of course. Other questions? I have a question for you. I don't know about, I mean, some of you are young, some of you are not that young. Do you feel, like me, that you have to cope more with organizational problems than with technical problems? And both yes or no are fine. I just want to understand.
Well, I'd say I do, but I'm head of engineering, so I'm a middle manager. If you wanted to know what a middle manager is, it's a dev manager or a head of engineering. Could be a middle manager. But I came from a developer background, but I still code bits.
Which is fine, because now you know all the problems that your team has to solve, and you can try to shield them from.
Yeah, my job is to be the umbrella to protect them from the shit, unblock them.
So you see, this is one, if he's right, if he speaks the truth, which I cannot assume, it's one of the few middle managers you can work for. Yeah, indeed.
And we only just had a team reorg to bulk up a product area that's integrations with third parties, and we moved people from the other teams. And one of the delivery managers said, well, the other teams have got quite small, we'll just merge them. I said, don't you dare touch them, because they're on the product. They're product specialists on those teams. So leave them alone, because they need to work on that. And if you merge them, they will never come back. We need them in the future in about 6 months when we add more developers into them to get, because there's enough,
Where you heard.
because there's enough backlog work for them to do.
Yeah.
Okay.
Where you heard.
Yeah, well, they haven't merged them. I didn't know
That's
how
good.
to do it, 'cause it'll
Because most of the frustration I had as a tech person was nobody listened to me. Of course, perhaps it's the way I talk. Huh?
And
But even when I talk very nicely, and it was like a lot of effort for not that much result. So anybody else has like the same experience as I have regarding the organizational problems and the technical problems, or? In general, my experience is that the older you get, the more you get the same feeling, because you get like exposed to wider problems. Of course, when you are on your code, when you start working on like you are a young engineer, a young developer, you start working, well, you won't be exposed to this kind of problem. Your problem will be, hey, should I use a hash map or a list or linked list or like a doubly linked list or whatever? And that's fine. I mean, that was happy times. And if you get into like tech lead and architects and solution architect, then I was exposed to this kind of stuff. So thanks a lot for your attention. I will be there until tomorrow noon. If you have questions and you were too shy to ask them in front, then just please come. And thanks again. Enjoy the rest of the conference.
You do know this isn't the after party, right? There's a lot of you, and I didn't expect that. So because it's the last slot of the day, I will do my best to get you out of here a little bit early, ahead of schedule, so you've got a bit of extra time to process the learnings that you've learned throughout the day. There have been some really big, important, meaningful sessions that have gone on throughout the day. And just like those, this is, well, it's a session at least. We're going to be talking about how to build the top 5 techniques to build the worst microservice system ever. I really like this image as a representation of microservices because you've got this gentleman on a scooter. It's a bit washed out in the projector, but he's going really fast, and he's not hampered by any bloat like protective headgear or anything. And his center of gravity is really high, and the pivot point is really low, and all it takes is one bump in the ground and permanent brain damage. Just like microservices. So who am I, and why am I qualified to talk to you about microservices? My name is William Brander. I'm from South Africa. I know the South African accent can be a little bit difficult to understand at times, so I will try and enunciate a little bit clearer than I usually do, and I will try to speak a little bit slower than I usually do. Hopefully that helps. As you can see from the mug, I'm the world's okayest programmer. I'm also incredibly passionate about building bad systems. I hope some of that passion is going to come through and energize the room so that we can end the day on a high note. There are 3 things that I dislike about this mug. The first is that the A in programmer is tilted ever so slightly to the side, just enough to bother my OCD. The second is that the font is dangerously close to Comic Sans without actually being Comic Sans, because that would be sort of cool in an ironic way. But this isn't. It's just like a weird knockoff. And then the third is that the mug is unfortunately unverified. It may surprise you to learn that there was not, in fact, a worldwide census done on developer ability with me landing square in the middle. So I went about looking to see if there's other ways that I could prove that I was an okay programmer. And I spent some time looking through my company Slack. And my coworkers definitely don't think I'm the best programmer either. But at least one of them doesn't think I'm the worst. So I've got that going for me. But what does being an okay programmer have to do with writing bad systems? Right? Being an okay programmer means that I've probably written some systems that I'm proud of and some that I'm a little bit ashamed of. But I'm sure everyone has written some bad systems, right? Has anyone not written a bad system before? If anyone's hiring, look around for hands now. We've all written some bad systems. So what do I bring to the table that can elevate me and can really make it that I'm the guy to teach you how to write bad systems? Well, that's got to do with who I work for. I work for a company called Particular Software. We make N-Service Bus. Has anybody heard of Particular? Well, we've got a booth outside, so if you haven't heard of us, we've done a really bad job. Anybody heard of N-Service Bus? I hope everyone. Anybody use an N-Service Bus? Thanks for my salary. So for those of you who don't know, N-Service Bus is a library and framework for building distributed systems. So whether you want to build microservices or SOA or just partition your system, N-Service Bus can help you do that. But that's not what this talk is about. So what does working for Particular have to do with making bad systems? Well, at Particular, if you work on the engineering team, you also do support. There's no distinction between engineering and support, which means that if you work on N-Service Bus, you support N-Service Bus, and you support the customers that use N-Service Bus. And that's honestly one of the more fun things that I get to do is support, because I get to see a lot of different systems applied in a lot of different ways at a lot of different scales. And I get to see how people are using N-Service Bus to build these distributed systems. But here's the thing about support. If one were to assume that system quality follows a normal distribution, where you've got some really poor quality systems on the one side and a few really high quality systems on the other side, with most systems having reasonable quality sort of in the middle, that doesn't really help with support, because the people that have got the high quality systems aren't coming to support for help, and the people that have got the medium quality systems aren't coming either, because they can probably work out their problems themselves. So the types of systems that I see when I do support are the ones down here. And I see a lot of these. In fact, as far as I'm concerned, based on my history with support, it means that the distribution of system quality does not follow a normal distribution like this. As far as I'm concerned, all systems are bad, and as an industry, we should be ashamed of ourselves for what we do to our poor customers. So microservices, right? Why do we do microservices? The consulting answer for why we do microservices is we want to decrease coupling so we can have independent deployability. We can scale things up and down without bothering the rest of the system, and blah, 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 blah. Nobody does microservices for that. We do microservices so that we can increase complexity and decrease performance. We do microservices so that we can come up with the most convoluted way to render angle brackets for a browser. And most importantly, we do microservices because we don't want to be seen to be doing a monolith, right? Monoliths are bad. If you start a project and say, well, I'm going to start with a monolith architecture, you get looks of despair from your colleagues. Every new project it's going to be a microservice architecture, right? Monoliths aren't bad, though. They're good. This picture on the left-hand side is of the Kailash temple in India. It's carved from a single rock, making this the largest man-made monolith in the world. The ERP system you've been working on for the last 7 years doesn't come close. Here's a different picture of it with a slightly better angle. You can see there's people on the, probably in the way there, there's people on the side on the left to give you an idea of the scale of this. This is huge. This is a massive undertaking. They carved this from hand. Well, I mean, not from hand. They didn't claw the rock away. They had tools, but well, they weren't electric or pneumatic tools. This must have taken an immense amount of planning, dedication, work, effort. This has been a labor of love for someone, and a whole bunch of slaves, probably. But it's beautiful. Monoliths can be beautiful. Don't think you have to do microservices because the alternative is monolith. There's a spectrum and a whole lot of options in between. As a side note, could you imagine what this would have looked like if they had built this using Scrum? So, for the rest of the talk, I'm going to assume that we have a system, and we're now trying to transition the system into microservices and make it as bad as possible. And we're going to see a few techniques that we can do with that. So we've got a monolith. It's a monolith, so it must be bad. So it's a tire fire of a monolith. And we're going to transition this to microservices. And a typical technique, and it's come up a few times at the conference already, is to apply with something known as the Strangler Fig pattern, where you take a bit of functionality in your system, say the charge credit card method, you isolate that from the rest of your code, and then you move that off to a service. And then your main monolith can call the new service instead of having to have that call in process. Yay, we've microserviced. What have we actually done, though, to our system? So if we apply this everywhere, what is the result? Well, let's take a look at the throughput of the system and how the throughput changes as the load on the system changes. We'll start with the monolith. So as the load of the monolith increases, the throughput will increase as well. At the start, it'll increase fairly linearly. And by that, I don't mean one-to-one, but there'll be some like K factor where as the load increases by 1, the throughput will increase by somewhere between 0 and 1, hopefully not 0. And as the load increases even more, that throughput should increase a little more as well. But the rate of change of increase will decrease a little bit because as the system is doing more things concurrently, there's more handing over to different threads, there's more exchanges, you're waiting for resources. So it will start to taper off a bit. And eventually it's going to get to a point where the throughput is going to drop off completely. And you might ask yourself, well, why? What is the behavior that's causing this to happen? And this has got to do with the way that .NET does memory management. So in .NET, there's 3 types of garbage collection events: Generation 0, Generation 1, and Generation 2. Technically, there's also Generation 3 or large object heap, but for the purposes of this discussion, we can fold that into Generation 2. And the way that garbage collection works is that when you try and allocate a memory in .NET, if there's certain criteria met, .NET goes and says, okay, I need to free up some memory. Let me go and do a Gen 0 garbage collection event. And a Gen 0 garbage collection event is intended to clear up resources that have been allocated and freed fairly quickly. So var x in a function, var x equals ABC. And then the function finishes, the garbage collector can retrieve that memory and return it back to the pool. But if the garbage collector tries to retrieve or tries to free up a bit of memory in Gen 0 and it can't, it promotes that to Generation 1. So Generation 1 is intended to be for longer-lived variables or longer-lived memory. Perhaps it's a variable on a class, and the class sits around for a bit longer and does a few other things. If a Generation 1 garbage collection event runs, and it can't clear up memory because something's still referencing that object, it promotes it to Generation 2. And that's where the problem happens. So Generation 2 in .NET is a stop-the-world event, where as a Generation 2 garbage collection event starts, all user threads are paused in your app domain. which means only except for the thread doing the garbage collection. So all of your other threads will pause. And many years ago, Stack Overflow experienced this, and Mark Gravel wrote a blog post explaining why this happened and what they were trying to do to work around it. These 3 big spikes over here are increases in response time because the Gen 2 garbage collection event was pausing all user threads in the application. So the performance at these points was very, very poor. It's gotten a lot better since then. After this came out, we got the concurrent garbage collection configuration, and now that's been replaced with the background garbage collection configuration, which doesn't, it interleaves some of the garbage collection for Gen 2, and it more proactively gets Gen 1 and Gen 0 garbage collection done. So Gen 2 garbage collection now pauses and then resumes a little bit, and then the garbage collection carries on a different thread a little bit later, so the pausing is sort of split out. It's still a horrible experience when you're dealing with performance. But that's our monolith. Our microservice is better now, right? So what happens when our microservice experiences load? As the load increases, the throughput will increase. The throughput will also increase at a fairly linear rate, but it will increase lower than the monolith because you've introduced a network hop. Network operations are expensive, which means that these threads that are doing the processing are probably going to hang around a little bit longer. So there's going to be more contention for resources, which means that flattening off is going to come sooner. And because they're hanging around even longer, there's more chance that they're going to be promoted to generation 2, which means that drop-off is going to come even sooner. So by simply distributing our system, we could have potentially made the overall throughput of the system worse. The first rule of distributed computing is don't distribute your computing. But we've gone ahead and done this, and we've potentially made the throughput of our system worse. This isn't always true. For instance, if the charge credit card method was on the hot path and we isolated this and moved this off, we could then scale that hardware up independently. But we're not going to do that. We're just going to microservice the way we learned at the conference, so we're going to do everything on one machine anyway. So the first technique we can use to mess your systems up is to put an HTTP call in front of everything. Who here remembers when .NET 3 came out with WCF? Right, yeah? There were those people going around, everything should be a WCF class, operation contracted all. It's a great idea. That was a very weird time. There was WCF, WPF, Workflow Foundation, and card spaces. And card spaces just sort of disappeared very quickly on in the evolution of .NET there. Okay, so we've taken our monolith and we've strangle-figged it until it's no longer a monolith, and now it's distributed. We still have the same coupling between the components. We still have all the same problems we had before. We've now just made the performance lower. So it's still a monolith. It's just distributed. That means instead of a problem that we have with our monolith, working with our monolith, we've now got to also introduce network topology coupling to that. So that's another layer of coupling that we've put in there. So it's not just a tire fire. It's a burning field of tires. This is a good first step. But this is difficult for us to work on. This isn't a pleasant experience. And we don't want to make our lives worse. We just want to make the system worse, right? We want to enjoy our job. So we go to business and we say, I bet you I can rewrite the system in 6 months. Anybody find themselves thinking that? I've done it many times, that particular. I've even tried a few times. Failed miserably. The thing with big bang rewrites is that they don't work. Little asterisks in the air. They work in 2 specific scenarios, which I'll get to later. But why don't they work? Why do big bang rewrites of large complex systems fail? And that's got to do with how software works for these large systems. So as you're developing the system, we'll have another graph here. Where on the y-axis, we've got the functionality that's available in the system, the amount of features that we've got. And on the x-axis, we've got the time that we spent developing the system. And at the start of the system, as you start developing, it's fairly easy to add new functionality because you don't have competing components with each other. You're still getting to know all the business rules that you have to work through. You know, it's a nice time to work. This is the greenfields era. We all love greenfields projects, right? As we carry on working, though, the rate at which we can add new features decreases because we have to add features where we didn't really design the architecture to match that feature set at the beginning. So it's a little bit slower to add the features. We have to change a few things and propagate. And there's competing business rules that we have to worry about. But that's fine. And then eventually it gets to a point where adding any bit of functionality takes a lot of time and effort. Potentially even just changing the name of a field on a form could be a full sprint process to do sometimes. So let's assume that at this point here, this is where we went to business after we've done our distributed monolith, and we said, please can we have 6 months to do a rewrite? After we've done the rewrite, everything will be wonderful. The UI will be modern, the performance will be better, and we'll be able to add features before you even know what to ask for. It'll be so good. And business says, well, okay, 6 months. I'll give you 6 months to do this. And you're ecstatic, because now you get to do new work again, and it's great. So now, instead of working on the old system for those 6 months, we work on the new system. So we're not adding new functionality over this period. So this little section here that we would have added a little bit of value to our users no longer exists. That disappears. And instead, we start working on the rewrite of our system. And at the start of our system in the rewrite, it's really quick to add features, probably even quicker than when the first system started, because now we've got better ideas. We've been thinking about how we would improve it for a few months before we did the rewrite. We know more about the business domain. Things are looking great here. But it's not going to take 6 months. How do I know it's not going to take 6 months? Well, that's because I'm a developer, and developers are really, really bad at estimating. In fact, instead of doing coding assessments when you try to hire someone, they should do estimation assessments. And anyone who's really bad at estimating must be an amazing developer. Anyone who's really good at developing is probably really good at estimating is probably a project manager and shouldn't be developing. I myself am the world's okayest estimator. But even if you could estimate correctly, you're still not going to take 6 months. Even if your estimation for what you think the system is going to take 6 months is 100% accurate, it's still not going to be correct. Because developers are also a bit like that dog from Up, where you get distracted by a squirrel and you run off. The systems that we work on, it's very, very unlikely that any large system that we work on will be 100% documented. Even if it is, there's even less chance that we'll have all of that knowledge sitting in our head while we're trying to thumbsuck an estimate. It's going to be very difficult to be able to get those guesses right. So we carry on working, we do our rewrite, 6 months comes and goes, and it's now 9 months, and business comes to us and says, listen, we can't go on like this. We need new features. We've got a compliance deadline we have to meet. GDPR 2.0 or something, the return. So you start panicking, and your team starts working weekends, working nights. You order pizzas every evening for the team. You've got a masseuse coming in to massage the team to relieve stress and tension. And you're just driving morale into the ground. And eventually, you're still not going to be done, and business is going to come to you at a point and say, we can't do this. You've got to cut this rewrite. And you panic a bit. You panic because now you've put a lot of effort into the new system. You love it. You're emotionally attached to this new design that you've got. So you compromise, and you say, OK, business, I'll tell you what. Got an idea. We've still got the old system that's running in production, right? So we'll have that, and then we'll also deploy the parts of the functionality that we've currently written, or that we've rewritten. And then the users can use the new system for the stuff we've rewritten, and then for the ones that we haven't done yet, they can use the old system, right? But now we need to keep them up to date, so OK, no problem. We'll put an integration layer between the two, and then everything will be fine. Except we know that the integration layer is going to suck because the original system sucked. And the longer that this integration layer sits in production that we have to maintain and fix, the more chance there is of some of the bad elements from the old system bleeding over into the new system. Because there's going to be time pressure. You're going to say, oh, I need to get this field into a report. I'm just going to copy it in the same way that it is in the old system. It happens. But anyway, we're going to do this, so we're going to have 3 systems that we have to maintain, but at least now we can add new functionality for our users so we can meet those compliance deadlines or whatever. Once we've added that functionality, we can go back and carry on with the migration, right? I'm sure business will give us time then. They will, right? Please, someone. They won't. Well, they might give you a little bit, but you'll have to scramble for it, and that original system is going to live much longer than you ever thought possible. It's a bit like trying to build an aeroplane while you're flying it. I asked Stable Diffusion to generate an image of an airplane flying while you're building it, and I've got to say, this is also a really good description of microservices. It's terrifying. So now that after we've done our distribution of everything, the second thing that we can do to make our system worse is to attempt to do a big bang rewrite. I said there were two cases where Big Bang rewrite works. The first is if the system is actually small enough to be rewritten in a reasonable time frame. This is tricky, though, because developers suck at estimating. So how do you know that it's small enough? Maybe it is, maybe it isn't. I don't know, it's unlikely. It's also, you kind of have to take into the fact, into consideration that working on an old system that you want to rewrite is unpleasant. It's emotional, so it's hard for you to be objective about how long it will take to actually do a rewrite. So the first time it works is if the system is small. The second time that it will work is for your CV. So you start the rewrite, and you do the rewrite in the most amazing technology possible, and then a month after you've started working on it, you go for interviews and leave. It works for you, not for the project, but that's fine. So this is what we've got now. We've got 3 systems we're maintaining, and the longer that these systems are in production, the more of the suckiness we've got from the first system bleeding over into our new system as well. Let's make it worse. We don't want to be malicious about it, though. So remember this situation where we had the drop-off in performance because of long-lived calls waiting for responses? We don't want to do that in the new system, right? We want to accidentally make bad systems, not purposefully make them. So instead of service A calling the credit card service, because it's just going to wait around for a response and the same problem is going to happen, what we'll do is we'll introduce a queue. And then service A can put a message on the queue to say, charge this person's credit card. And once that message is on the queue, service A can end its call and terminate. And then we're done, right? That means that service A is less likely to live long enough to get promoted to Gen 2, so we've solved that problem. And everything's fine. We then go to our credit card service, which takes a message off the queue, calls Swift, or whatever payment provider we want to use, and everything's fine. Okay, cool. Except now our message gets to the front of the queue, and this message says, charge William's credit card £50. Cool. As we do that call, though, something goes wrong. The network fails somewhere along the line. Swift fails for whatever reason. Something happens. Okay, but we haven't actually charged William's credit card yet, but that's fine. The message is gone. Well, that's no good. We've lost money for our customers, right? That's a financial operation that we don't want to lose for them. So we suddenly think, okay, what we'll do is when we take the message off the queue, we'll process it in a loop. And in that loop, we'll put a try-catch. So if something goes wrong, we'll just keep processing it, and that'll be fine. And then we call Swift, and then something goes wrong, and maybe something's wrong on Swift's side, and they have to reboot some service internally, whatever it is. And they come to us and say, you're DDoSing us, guys. Whenever something goes wrong, you're just calling us nonstop. You need to back off. So you go back and you introduce some sort of timer mechanism, and you say, well, okay, each message can only be processed 5 times every minute. Yes, perfect. And then that goes into production, and Swift is at least happy with you there. But then you get someone like William who puts his credit card details in incorrectly on purpose because he doesn't want to pay £50. And then the message will never actually get processed because that's an invalid credit card number. Or maybe there's a bug in the code upstream that generated that message and that failed. But now that message is sitting at the front of the queue and everything behind it isn't getting processed. And you're like, well, okay, I know what we'll do. We'll introduce a dead letter queue, and then we'll take that message, move it to the dead letter queue. Oh, and don't worry, we'll also make software to manage the dead letter queue. And this is a really cool bit of architectural kit. This is fun to work with. And you're living for this framework that you're making. But it is a framework that you're making. And in this case, this type of problem is solved by Poly, NService Bus, Mass Transit, Rebus, Brighter Command. There's many options in the .NET space that will handle this problem for you. So, but instead of doing that, you're getting a lot of joy out of working on this framework. You might even open source it one day. That moment when you get your first star in your open source GitHub project, it's, oh. So the next technique we're going to use is we're going to make sure that we suffer heavily from not invented here syndrome. And every framework that we come across, we say, no, we don't want to use that because it doesn't 100% meet our requirements. We're going to make our own one. And that's how we ended up with so many JavaScript front-end frameworks a few years ago. But we're going to keep doing this. Because honestly, when you've got a system like this, some of the only joy you can get is working on cool engineering problems. And you're not going to get that from business problems usually. So we've got our monolith. We've got our new system that we're busy maintaining. We've got our integration layer between the two. And then we've got this really cool framework that we're working on. At least one, try for many. I highly recommend it. And at this point, we're basically not delivering any business functionality at all anyway. We're having a lot of fun on our custom stuff, but not really doing much for the business. So they're going to come to us and say, listen, we need the search screen that you've been promising us for months. Please, can you give us a search screen? And you think, fine. We'll do it. We've got a product service. And maybe they're an e-commerce site. They're Amazon, no, rainforest.com. So they're rainforest.com, and you can search for product, or that you can purchase products off of rainforest.com. And you've designed your product service to match this requirement. So you've got, for instance, the name of a product. You've got the price of the product. There's images for it, whether it's in stock somewhere, description, the rating of the product, fairly standard product-y things. We've all seen these types of things before. And you come up with a class and a data structure that sort of represents this, which looks a bit like this. All those fields, except it's got an ID. Yay, computer science. And based off of this, you can go and implement the customer's search screen that they wanted. So you can, in your product service, have a little search API, pass in a text string, and we'll search the name and the description and spit back all of the products that match. And you pat yourself on the back, and you go back to work on your framework now that business is satisfied. But then they come to you and they say, I've got an idea. The correct response when business comes to you and says, I've got an idea, is for you to excuse yourself from the room, say you want to get a coffee or something quickly, leave the building, get in your car and go home and pretend it never happened. But you don't do that. So business says, I've got an idea. We have a theory that, especially on consumable items, if someone has ordered a product before, there's a higher likelihood that they'll order the same product again. So can we maybe have a little field that shows, hey, you've ordered this before on the search screen? And you pause what you're doing on your cool framework, and you swing over in your chair, and you kind of just look incredulously at this person that's asked you the most obscene question ever, because the order status is not in the product service. That's in the order service. That's a very different thing. But you want to get back to working on the cool stuff as quickly as possible, so you make them promise that this is the only time they're going to do this. You even pinky promise with them. And they agree. They pinky promise and promise to name their firstborn child after you as well. So you say, OK, fine. So the product service, once we get the request, we'll also then call off into the order service just this once, and we'll go back to doing the cool stuff again. I mean, this isn't pretty. You've made your search screen slow because now your product service has to first query its database, then query another service, then put all the stuff together. But it's just once. It's fine, right? Then business comes to you and says, hey, I've got an idea. Remember the correct response? Leave the room, leave the building, get in your car, go home. Denial, denial, denial. We want to reward our gold customers and give them a 10% discount. So special pricing per customer, please. And I mean, at this point, you may as well give up because they're going to come and ask for every single service in your system anyway. So the customer status doesn't sit in the order service. It doesn't sit in the product service. It sits in the customer service. So we're just going to start chaining all of these calls together. And eventually, we're going to end up with dedicated teams that can manage our API gateways. Has anybody worked with in an environment where there's a dedicated data-powered team, and only they can make changes to your API gateway? It happens. These API gateways can solve these problems for you, but they can become they are another layer of coupling that you introduce into your system. A new set of technology you have to worry about. Has anyone seen this video? If you haven't, do it. It's called Microservices on YouTube by a channel called Krazam. It is the best description of this type of thing ever. The man's face is like a mirror image of me in business meetings sometimes. Why did we end up like this, though? I mean, we've got a product service. It's nice. It's concrete. It's very neatly encapsulated. We've got an order service, a customer service. Look at these classes. These are beautiful. Why is this not working for us? And the reason is that people don't interact with products on your service. They don't productize things. They don't producty. They search for things. They perform operations in your system. They don't perform things. Even if your user is busy updating your product catalog, they're still not producting. They are updating a product in your catalog. And having the idea that a product service, a thing service, is going to neatly encapsulate and not bleed over into other boundaries is a bit weird. It's like when you do a search on a screen, it's like a puzzle that you build, and you take pieces from different places and you put them together to make the whole puzzle. Although I've actually just realized the puzzle is a really bad metaphor for this because it's always got the same pieces in the same places. But think of something like that, right? You're taking information from different places and you're putting it together to build one experience for someone. The thing is, people interact with your system by doing things, not by objecting. So the next technique that we can use is when we define our service boundaries, we can make sure that they are designed based off of nouns and not verbs. Anybody working in insurance? This is a big one that I see very often in insurance space. You don't have to put your hand up if you are doing this, but if you've got a claim service or policy service, usually that's a bit of a red flag and something to look at. People, well, I suppose claims might work sometimes because you do submit a claim, but people don't policy. They do a quotation. They go through the order process. Their underwriting is a process. They don't policy. Okay, so we've got our three systems, our monolith, our integration layer, our new system. We've got this cool framework that we're working on as well, and we've made sure that when we defined our service boundaries, they're all based on nouns so that we can maximize the chance of having cross-communication service calls between everything. We're building another great monolith on that side. Let's see if we can make this even worse by trying to make it better, right? So we'll go back to that search screen. Well, we don't want this, right? This is bad. Let's see if we can improve it. What we'll do is we'll introduce a new service, a search service. To search is a verb. We're doing something, right? Yay, we're learning. The search service will be a dedicated service only responsible for searching. So it won't have a product class. It will have a search product class, which has a couple new fields on it. And if we need to change the business rules in the search service, we can update that, right? Sounds reasonable. How do we get the data into the search service? Well, that's easy. We'll pub sub it, right? So what we'll do is we'll tell the product service, hey, whenever you update your product list, publish an event for us, please. And then I'll maintain a search catalog, and I'll update that whenever the product list changes. Okay, and whenever the customer status changes, also publish an event, and then the search service can update its list. And we can do the same for the order service. This is an awful lot of data duplication. We've got things in different places, but we're smart, we're engineers. We can explain this away, right? The source of truth, if you use that phrase, it's clever, the source of truth of the products is in the product service, right? What we've got in the search service is it's a different model. It's a, what can we call it? A read model. That's right, we're doing a projection. This is CQRS, yay! And we're using pub sub, right? So there's events, so it's CQRS and event sourcing, and services, domains. We're doing DDD CQRS event sourcing. This is a good system design. Go technology. We still have the same coupling problems here. If the customer service changes the way that it rewards customers, that has to flow through into the search service as well. For instance, if the customer service says instead of rewarding discounts based on status, we want to reward the top 100 customers. Our top 100 customers will get 50% off. The next 200 get 10%, and then the rest just get an extra 10% added on because we want to help them monetize their way up into the stream, right? We make that change in the customer service. We then have to make that same change in the search service because now the search service doesn't have statuses that we have to worry about. That coupling still exists. We haven't hidden it away. And the thing to remember here is that even though it looks like it's separate and it looks like it's decoupled, the view isn't the same. So the logical boundaries and the deployment boundaries, or the physical boundaries, are different. And we've treated it as if they're the same. If we have a search service and it's deployed separately, it must be separate from everything else, right? It must be decoupled. But it's not. I've always really liked this poster for episode 1 with Anakin standing there and his shadow projected as Darth Vader. I've always thought this was incredibly clever because we know Anakin is Darth Vader, or is going to become Darth Vader. But in this particular instance, in this moment, he is not. The logical Darth Vader is different from the physical Anakin at this point in time. So what I'm going to do now is I'm going to show you a technique that can make this previous situation a little bit better. I don't want you to go and apply this because you don't want to make things better. Also, because it's not a golden hammer, it doesn't work in every scenario. So don't just go and say, William said apply this. It sometimes makes things better, sometimes it's not applicable. But it is a technique you can use to get rid of the distributed replication of data that you're going to build. So what we'll do is we'll replace our search service with a search engine, right? That sounds more natural, doesn't it? Search engine, search service, search engine. And what we're going to do is we're going to implement what's known as the engine pattern. So the engine pattern has some coupling in it, but not logical coupling or not business coupling. What do I mean by that? So the search engine will expose a contract that the other services must comply to. So they'll expose, for instance, 3 interfaces maybe. An iFind product interface, which given a text string will filter through a list of products and return them. We'll also have an interface for iPrice products. So for a particular user and a particular product, what discount percentage should they get? And we'll have a third interface for iTrack orders, which just tells you, returns true or false, whether someone has ordered a product previously or not. The search engine takes these 3 interfaces, compiles them into a DLL, and hosts it on an internal NuGet feed or something like that. The product service, the customer service, and the order service can then download that NuGet package and implement whatever interfaces they want. So what I mean by that is that the product service can implement the product finder class. And the product finder class knows how to query the product service database. I hope it's clear that the product finder class sits squarely within the logical boundary of the product service. The customer service can do the same with a status pricer, and then the order service can do the same with a order history class. So all of these classes implement the interface that was exposed by the search engine, and they're currently sitting within the service boundaries that they're implemented in. And this is great. How do we wire this up together, though? So what we can do is we can take the product finder class, compile it into its own assembly, and then take that assembly and stick it in the app folder of the search engine. And then when the search engine runs and it needs to do a search, it can ask .NET, hey, .NET, give me all of the classes that implement iFind products. And .NET will go, oh, here's one. It's the product finder class. There you go. The search engine can invoke that product finder class, which will then go off and query the product database because it knows how to talk to its own database. And then we can do the same from the customer service. You can take the customer status pricer and compile that into a DLL, copy-paste that DLL into the search engine folder, and then the search engine can apply that to the products that it's got from the search result. And we can do the same with the order history one. We can track what the person has ordered before. How is this different from the previous one? We're still doing 3 sets of queries, right? Well, if the customer service changes the way that it does discounts and it goes away from status and changes over to ranking, the customer service deletes that status pricer and creates a new class, a ranking pricer, compiles that ranking pricer into a DLL and pastes the DLL into the search engine folder. Now the search engine, when it does a query and it tries to find all of the prices, the high-price product instances, it doesn't have the status pricer anymore. It now gets the ranking pricer. The changes were constrained logically within the customer service. Physically, though, we deployed a different assembly into a different runtime, but that's not really a big problem. The interesting thing with this type of pattern is that you can apply things that seem like they come outside of that domain into different domains. So for instance, the product service could implement a daily pricer. Maybe every Monday, these products get a 50% discount. That can get put directly alongside the existing pricer. The same with the order service. It can create its own bulk history pricer, where if a customer over the lifetime of the customer's account has ordered 99 of these items, on the 100th item, they get a 99% discount. That can also just be deployed alongside. And all of that sits and resides logically within those individual service boundaries. Physically, we've deployed it somewhere else, but logically, it's separate. I always find it interesting that when people consider this type of idea, that it feels weird to them. Like we're putting these things together, we're coupling it, right? But this type of distinction between logical and physical is fine when you're talking about scaling out instances. We'll take the same code and run it in 2 places. That's also physical differences, but logically it's still the same thing. So don't do this. In fact, what you need to do is you need to make sure that you conflate your logical and your physical boundaries for everything that you do in your system. So a quick recap, what we've done is we put an HTTP call in front of everything. We made sure to attempt a big bang rewrite. Note I didn't say do. I did there. I shouldn't do that. Oops. We didn't use any off-the-shelf frameworks. We created a whole bunch of cool frameworks that we get joy out of. We then also made sure that we use nouns instead of verbs when defining our service boundaries so that we can get the maximum chance of having cross-service communication. And in the places where we have cross-service communication, we made sure that we kept the logical and the deployment boundaries the same throughout the entire system. And if you follow these 5 techniques, you'll have a great time looking for a new job somewhere, I'm sure. I did say I would get you out of here a little bit early, and I'm pleased to say that I did that. If you have any questions, you can ask them now. Otherwise, you can also find me around NDC. I'll be here tomorrow and maybe a little bit later. I'm always excited to talk about writing bad systems. So if that's a common interest, we can write bad code together. Any questions? No? Okay, great. Thank you, everyone.